Welcome to Rings Plumber Conference 2025 Build MC. My name is Yoon Sung Kim, and I'm very excited to share my work with all of you today. The title of my talk is Debian Official Debug Kernel for All. So this presentation will address a little gap in Debian ecosystem, and we will explore why official standardized debug kernels are essential for maintainability and security and proactive security posture. So yeah, I will continue to doing this slide. Yeah. Thank you. So comparison with Fedora and RHEL and OpenSUSE. Yeah, Fedora and RHEL offers official kernel debug. Kernel debug. Yeah. With some sanitizer and bunch of the debug configuration, OpenSUSE maintains dedicated debug configuration for memory and log checking and other many things. But Debian currently only provides a debug symbol. Debug symbol. If someone wants to take a debug kernel, forcing developer to build custom kernel. So my patch introduces official Debian debug kernels to address this gap. So yeah, there is three aspects for I wanted to emphasize. We must be realistic. Some of debug config and sanitizer is very heavy. It can make the system too slow. Also, simply enable all the debug config read to false positive because our generic environment is different. So I propose we establish a lightweight debug reference first. This aligns with what Qualcomm use for their common kernels. Yeah, so there is some table from this reference. Yeah, here, Qualcomm document. So before going full heavy with sanitizer and other some log checking, we should at least agree on these essentials, like debug spin lock for logic errors to catch corruption for the spin lock, and slop debug for basic memory checks. This set serves as a common denominator that every distro debug kernel should have, balancing performance and debugability. And yeah, I want to introducing the middleweight things, a step up from the lightweight checklist. This level of the debug configuration can be highly verbose and significantly slow down execution, requiring a cautious application in real-world environment. The Qualcomm document list in here on the slide as a reference for more debugging options. Yeah, I want to introduce pain point for the some user and some teams for the user's request. The core problem we must solve is the more info needed loop. When a user reports a critical bug, such as system freeze or hang randomly, the development for the Debian kernel team finds it hard to reproduce and send back a request for more information. The fundamental bottleneck is that building a debug kernel is too high barrier for most users. Consequently, the user give up. Yeah. The bug ticket remains unresolved, and critical bugs remains in hidden and unresolved. I want to some a proposal for the Debian Delta and Debian specific patches handling. In comparison to upstream kernel, there is a Debian Delta. the numerous custom patches Debian maintains that differ from the upstream kernel. Upstream CI thoroughly validates the mainline kernel, but Debian's unique patches in this directory, Debian under patches under some series of patches directory fall outside the verification scope. Yeah. So currently, we have to rely on manual verification, which has a fundamental limitation, as you know. This is another important reason why we must introduce an official debug kernel. Yeah. So I suggest the solution, official debug flavors. And my proposal introduces official debug kernel for the at least AMD64 and ARM64 kernel flavors. The implementation defines these new flavors in the define.toml and add the config.debug configuration. Yeah. It would be an enhancement and check for the three aspects in here. Memory safety, strengthened using some memory sanitizer like Kasan and Ubisan, and deadlock detection enabled by the LockDep, and coverage-based debugging supported by the enabling KCOV. Yeah, but you should remember that this is the a heavyweight configuration for the Linux kernel. Yeah. So I wanted to show the main use cases of the debug kernel, especially KCOV, with my tools named BOK. Visual Kernel Coverage Tool is a visualization tool that overcomes the limitation of the existing text logs and the message. BOK uses KCOV to record the kernel execution path triggered by a specific application and visualizes the execution flow and as a heat map on the Linux kernel source code. This provides a debugging environment of start guessing, start seeing, and with the introduction of the official debug kernel, all Debian users can immediately use tools like BOK. So, yeah, this is some demo presentation for the BOK, but the PDF file stopped for this screen. So yeah, you can see that is a GIF image in this link. Yeah. So this demo presents some when I make some make.dr with some new directory, we can see the whole bunch of some kernel paths with some execution of the user application, and then we can see some Linux kernel that have some executing in the Linux kernel. Yeah. So yeah, I want to mention some seedbot in this session. Seedbot, the kernel bug hunter. Google Seedbot team has expressed support for Debian. We can provide the debug kernel images and headers, enabling proactive QA through Seedbot. Seedbot validates Debian-specific patches against corner causes corner cases. Yeah, against the corner cases we can manually test. It provides a high-quality report, including actionable reproducers like CDLang-based or a C program, and root cause analysis. This allows us to join the security ecosystem alongside with the something like upstream kernel and Android kernel. So yeah, I prepared some mailing thread with some Dimitri, who the Seedbot maintainer and Debian kernel team members. So Debian kernel maintenance is done in the Debian kernel team members in free time. Yeah, and they lack the manpower to handle a flood of the general bug reports. So the Debian kernel team can only accept report if the CDBot can filter for the Debian specific issue. So they can afford to investigate bugs that already existed in upstream mainline kernel, and they are willing to receive private reports only if the CDBot can accurately distinguish and filter for bugs that are reproducible only on Debian kernel. Yeah, issues introduced by the Debian patches. So I think it is a good point that CDBot have already have some filter function for they support Android kernel, so we can drop down the upstream kernel and we can see some filtered Android specific bug in the CDBot dashboard. Yeah, so CDBot team technically said we can distinguish them, but not sure about setting up the reporting workflow because CDBot is technically capable of detecting downstream distribution-specific bugs with reasonable precision, citing existing success with Android kernel trees. But he expressed uncertainty for the exclusively send private notification for the specific Debian bug. So filtering for Debian specific bug and private reporting, mandatory condition for the Debian kernel team. But the CDBot have unsure if the automated reporting system can be configured. So this is some issue in this now. So I wanted to say about if we take this chance, we can make the security response from the reactive approach to a proactive approach, like detect via fudging and fix silently, release secure kernel would be to a proactive approach. The proactive goal is to detect bug via fudging, fix silently, release secure kernel. It emphasizes that memory safety issues account for upper 70 of the vulnerability. Catching this issue at the bug stage prevents them from becoming exploit. So I wanted to suggest some roadmap and challenges. Key challenge is including multi-architecture, X, various page sizes supported by the especially ARM64, and as you know, some of architecture support a real-time kernel, so we can add more X in here in the entry, and there is some 3 types of the sanitizer that Linux kernel support this now. So there is so many combination. So and this is also problem. Build time are very increased about the 3 times for some sanitizer and compiler instrumented configuration. As you know, the kernels are there's a lot of kernel for this combination. The storage, largest storage package size cause some storage issue for some community-based ecosystem. So I wanted to suggest some roadmap proceed in 3 pages. Page 1, pilot and assessment. Release debug flavors in the experimental repository to assess infrastructure impact. And phase 2, CI automation. Incorporate boot test with sanitizer into Salsa CI pipeline. And page 3, ecosystem expansion. Extend coverage by integrating with CDBot and kernel CI. So by introducing the debug kernel, we can convert unreproducible bugs into actionable reports, reducing issue resolution resolution cost. And we can improve quality through the automatic verification of Debian specific patches. So my key message is that debug kernels are not a waste of the resources, but an investment in maintainability and security and call for discussion. So I want to talk about this. Let's discuss flavor.debug official in Debian. Yeah. So
Fedora's been doing this for a long time.
Yeah.
And I can give you some hopefully tips and insight. In fact, what we did for years, over a decade, was the rawhide kernel, when you had an rc.x release, was a regular production kernel.
Yeah.
But we've always built regular production kernels and debug kernels. What we did for over 10 years was we forced rawhide users, if you were updating daily, every Linux snapshot build. So basically Tuesday through Friday, those builds were debug kernels only.
Mm-hmm.
And we forced users to use them. And that was a great way to expose a lot of bugs. The real problem you run into with this is upstream starts overloading debug config options. So you can take the time and create a debug config that is fairly well balanced and not too much of a burden on the users and gives good information. And then suddenly 2 years later, it's not usable. You can't run a desktop on it because it's just too slow for certain things. So we've now gone away from that, and we don't force anybody to use debug, but we build debug kernels with every single kernel we build for production, for rawhide, for everything. And then we have some automated testing and all of that.
Mm-hmm.
Yes, it does increase the build time. It increases storage drastically.
Yeah.
Which not too much of a problem there. Now, Debian's probably also got the same problem we do in that, RHEL can do builds internally and push them out when a CV is released, right?
Mm-hmm.
But with Fedora, everything we have is open. So I can't commit a fix until a CV is public, and then I have to worry about build time after that. So when you start introducing too much build time, it gets, it hampers your CV reaction time, right? So that's also somewhat problematic. But you will have to constantly look at build options and say, is this still a usable debug kernel? And also race conditions end up in a weird state that sometimes those debug kernels make them go away because you've slowed down the kernel so much that the race is no longer there.
Yeah.
So I'm not saying it's not worthwhile. It's very worthwhile. We continue to do it. We continue to test on it, but it is also, it's not just a set it and done. It's kind of a constant, what are our debug options now? How are they performing? Are they useful? And are they worth the overhead that they're introducing?
Thank you. Thank you for great suggestion.
Yeah, I kind of second that. We had the same thing in production. We created a debug kernel, and years later, I figured out that the options that I'm setting are not even in the config file anymore, which I should have checked for. Yeah. My question is, have you considered, like, one of the things that we kind of like stumble upon when trying to introduce debug kernels is like some options are mutually exclusive, so you cannot have ksun and kcsun enabled simultaneously.
Yes.
So how would you think addressing this case?
Yeah. My great references is some Fedora and RHEL debug kernel. So my works only focused on the ksun, some mutual exclusive condition, and I follow up some other references for the cases. So I think when I forging the Linux kernel and research for some vulnerability, ksun is the good de facto for the debug kernel, and the speed is almost much faster than other configuration. So I want to start with the ksun and some major configuration based on the other distribution. Yeah, thank you.
What about also kfans, which is the lighter version of ksun?
Yeah. I think K-Fence is good for the debug configuration. So yeah, I need to consider those things. Yeah.
Yeah, that we also do it in prod, but you can even disable it in a command line. But
So yeah, it's there in the stable kernel. So yeah, if you want to do your KSAN versus KFence, so our debug kernels have KSAN, and then we have KFence in our stable kernels, and make everybody run it. The overhead is just not. There is overhead, but it's small.
Thank you.
Has he been waiting for?
Oh, yeah. So I know earlier in your slide you mentioned how performance was a big thing. You don't want it to be too slow for regular usage. I also see in your patches you're enabling KASAN, you're enabling proved locking, which is all of lock depth configuration, and you're enabling KCOP. From experience,
Yeah.
because I run that configuration with a whole bunch of other debug configurations against syscaller on a local instance day to day. That is tens, if not hundreds of times slower than a kernel built without those. So that is absolutely not a configuration that people can deploy widely. I'll give it to microphone to you in a second. So I would recommend that there are two very different cases of like automated fuzzing in an automated system and something you can actually deploy. And I would not conflate the set of options that you use for those. There's like some common things you probably want in those, but I do not think you want all of those like in the configuration you give to end users. I think that's not going to be practical to get useful data out.
Locking in specific, it used to be that was the one option that we determined that I was not willing to turn off in our debug kernels because it gives too much good information. But over time, for years, like I said, we forced rawhide users to run these kernels, and proved locking wasn't that big of a problem. But it was probably 2 or 3 years ago that the overhead, people started adding more functionality to it. The overhead got too high, and it's no longer usable as a desktop configuration. And that's why it's still in the debug kernel because I wasn't willing to turn it off, but we don't force the debug kernel on users just because of proved locking.
And a lot of these debug options, like the overhead they add is not additive, it's multiplicative. So like you go from each one of these having a minor overhead individually, but as soon as you enable them, you're 10, 100 times slower.
Other question?
One thing that was tossing around in my mind at one point is things like Sysbot a good way to work out if what we would call in the embedded business the evil vendor kernel? Can we use that to evaluate evil vendor kernels versus mainline?
Sorry.
So
Yeah.
with embedded boards, usually we get some vendor kernel with a lot of extra patches in it.
Yeah.
If we run Sysbot against the vendor kernel, how can we evaluate that output versus a mainline kernel that it may or may not have derived from?
So you asked me some how can the Sysbot support the vendor specific kernel?
Yes.
Yeah. So I can introduce to you that there is some guide for some city color can enable the specific remote machine and some essential configuration for the some other corner. So there's some official document. So
So your tool that you were going to demo that starts with a V, is it VOC or?
VOC.
VOC. Okay, so that looks pretty cool. I think I've seen some video of it in action. And it looks pretty like an amazing debugging tool. So that depends on, does that depend on a debug kernel package existing for Debian? Does it rely on that to run?
Especially I mentioned that Dmitry, the essential configuration for that application is the kernel config KCOP, kernel coverage. So yeah, the kernel coverage makes some user applications, some code paths.
Right.
Yeah.
So if you have a
That's right.
if you have a debug kernel with KCov enabled, then
Yeah.
you can use your tool.
Yeah.
Okay.
Right, that's
Have you
right.
thought about porting your tool? Is it Debian only, or are you looking at porting your tool to other?
This tool is not related with some specific distribution. So yeah, you can enable the KCOB, you can use it. Yeah.
I have a question. And I'm looking back my memory in my previous project as embedded developer.
Mhm.
And if I add the 2, 3, or 5 debug configuration, and I saw the boot failure sometimes. And sometimes
Yeah.
an kernel image size was increased so very higher because it is more than 2 megabytes. So I think that could you consider provide some of the information that this debug configuration will increase this size of the kernel image?
Yeah.
If you provide this kind of information, and Debian kernel team will not be afraid of your suggestion. That's my suggestion.
Yeah. Thank you for the great suggestion. Yeah. So yeah, almost 59. Yeah. So yeah, I wrap up my session. Thank you for joining my session. Thank you, everyone.
I'll switch the slides. Oh, we're figuring out how to do this now. Next speaker is Frank, and I'd like to thank Frank especially for motivating BN and I to actually organize this session. He's been a very big help getting all of us organized. So, and he's going to talk to us about UEFI secure boot.
Did a lot of the legwork.
Yes. Made my life much easier.
Is it all right if I grab a selfie with all?
You're going to do a Steve Rostat?
Yeah, I am. That's where I got the idea. All right.
It's not a real camera, though.
No. I'm trying to make my big head
He
small.
doesn't really know how it works.
I'm going to.
Okay. Oh yeah, that much better. There. Ooh, all right. Thank you. This is a big moment for me. Okay, so I'm Frank. I'm mostly involved with Open Embedded these days as a troublemaker. I ask the questions others are afraid to ask. Okay, so this session is going to be about UEFI Secure Boot. I'm going to give you the background. I'm going to explain how it's implemented in the distros that support it. And then I'm going to get into the problem that we faced, which is how not to disclose the private key that is used to sign the Linux images and kernel modules that are what enable secure boot to work. So, and then I'll explain some of the solutions that exist for solving that, and many of them involve distros working solutions right now. And then I'm going to open things up for discussion because I think this will be a pretty animated session. All right, so I think most of you probably know what UEFI is. It's firmware. It's an industry standard. It's adopted all across the x86 ecosystem. It also acts as the root of trust for secure boot. So there are public certs enrolled in the UEFI firmware. Like UEFI has kind of subsumed what used to be called BIOS. BIOS is kind of a legacy thing nowadays. That's just my opinion. Where is it located? It's on SPI flash on the motherboard. All right, so what is in the UEFI firmware? There are X509 public certs enrolled. So some of these public keys include the platform key, which is an OEM key, you know, Dell, whoever manufactured the machine. There is the key exchange key, which is used to update the factory keys in the database that's on the UEFI firmware. And so there's two databases. There's a database of active public certs, and these are provided by Microsoft. So these are signed by Microsoft, and there is DBX, which is the deny list. So these are public certs that have been revoked because they've been infected with malware. And again, all those keys, they typically reside in non-volatile RAM, which is usually stored alongside the firmware on the SPI flash. Now, the solution that distros have adopted in order to enable UEFI secure boot is shim. So typically the way UEFI is supposed to work is that there is a chain of trust that occurs in the UEFI boot sequence where the executables are validated against a database of public keys as the system boots. So those keys that I showed you in the firmware. Now that's how it's supposed to work. What shim does is that it inserts itself into the boot sequence as a first stage bootloader. So it will boot grub, which will then boot the Linux kernel. And by inserting itself into the boot sequence, it embeds a distro public cert as a new root of trust. So it's not you're no longer relying on the factory keys. You're inserting a distro key to act as the new root of trust. In this way, you're able to boot bootloaders, kernels, UKIs, kernel modules, all that are signed with the distro's private key, rather than Microsoft, than signed by Microsoft.
But the shim is signed by Microsoft, so you're still maintaining
Yeah.
the level of trust.
That's correct. Yeah.
So yeah, the shim is signed, and that's how you maintain the level of trust there.
Yeah. So the shim has to be signed by Microsoft. So every distro had to get who has their own shim had to get it signed by Microsoft in order for this to work. Okay. Okay. We're not here to badmouth Microsoft. This is just this is the reality. If you're running x86 and you're using the factory keys, you're relying on Microsoft signing things. And this is what it takes to get Microsoft to sign your shim. So you got to fork that repo. But notice RHboot, that's Red Hat. Red Hat has done most of the work to enable shim and mock and all the things I'm going to talk about. And so first you got to fork the repo. You got to embed your certificate in there. Then you got to submit. You got to submit your binary to this other repo for review, and then after peer review, which is other it's other distro maintainers, then eventually goes to the Microsoft for review, and then once Microsoft approves it, then they sign it, and then they return the signed shim back to you. Seems like a lot of work. Most of us probably don't want to deal with this. even if we are, building and maintaining our own distro. Luckily, we don't have to. So shim enables us to bypass all this. So you can piggyback off someone else's shim. And the way you do that is using what's called mock. So this is a machine owner key. So this is actually, this was introduced by shim. So it wasn't originally part of the UEFI standard. And what it does is it adds an extra database of certs outside of the factory keys. And they're stored the same way the other keys are on the flash. And so this is by enrolling your distro's key as a mock, which is a kind of a manual process. That's how you're able to enable secure boot for using images that are signed with your distro's key. Or if you want to do self-signing, you can use mock to enable that as well. So if you want to build your own UKIs and sign those, you can enroll your public certs into the UEFI firmware using mock. So I did a little bit of research to see how this works. So I'm running Fedora Bluefin on my ThinkPad that I just bought. And I looked at the Bluefin documentation, and it says that they support secure boot with their custom key. And then what happens after the first installation, I use the USB installer. You're then prompted by shim to enroll the secure boot key in this sort of BIOS-like interface. Using the keyboard, and so this is what this looks like in practice. So there's the BIOS setup. I had to enable secure boot. I also had to enable that allow Microsoft third-party certs. So that is what makes shim possible. If you turn that off, you're not able to use shim to boot your system. It won't boot up. And then this is what the UI looks like for enrolling the key the first time the system boots up. So you select enroll mock with the keyboard, and then you have to manually enter in the password, that universal blue password, and only then will the key get enrolled. So this explains how that actually happens. So mock util is a user space tool that you can use to, emulate what the installer is doing. So what it's doing is it's not writing to the UEFI it's not writing to the UEFI flash directly. It's actually staging a pending request so that when shim comes up the next time, it asks you to go through the enrollment process and enter the password to enroll the mock key. So this is all for security, right? You don't want an outsider to be able to do this. It requires physical presence. Oh, okay.
I see it on the Chromebook, actually.
Yeah.
Yeah, okay. So the question is, for these works, oh no, that's not the question. Yeah. If you use secure boot in the context of Yocto embedded systems, wouldn't you want to disable the Microsoft keys in UEFI? With mock, you only allow an additional key, so any other distro image would still boot on your hardware. Yeah, everything you're saying, Jan, is correct. But this is not for you. So,
I would actually disagree with that, because you can't, I've got the mic.
Okay.
Yeah. You can't set first of all, you can't disable the Microsoft key, because that's what signs the shim. So that's how you maintain the chain of trust. So you can never disable the Microsoft key and then your shim actually doesn't just enable every distro to run. You know, shim, like our shim by default, trust Fedora, trust Red Hat, that's it. And if you want to use another distribution, you'd have to manually go through this process as you're talking about, have physical presence to the machine and introduce your key that way. Oh.
I don't think that's really the point. I think the point is that any shim signed by any distro could still run on that system. So it's not. Yes. So, but I will also point out that the drivers in your GPU card, for instance, are also signed by Microsoft. So if you disable the Microsoft keys and keep secure boot enabled, then you have other problems.
Yeah. So Jan is talking about the embedded use case, which is different because in embedded, you're able to provision the UEFI firmware yourself and then put whatever keys you want in there.
Well, but even if you're using an x86 platform, you may want to prevent the Fedora or something else generically being loaded. So I mean, a use case, for instance, is let's say you have a windmill with a power controller at its base. You don't necessarily want people to be able to install their own Linux on that if it's in the middle of a field and physical security is defeated. So in that situation, they would remove the Microsoft key, put their own key on there in order to prevent other things from being loaded in those situations. You can. You absolutely can. It is fundamentally done in our power grid right now. Yeah, no, it is. That is a thing, and that is how it is done. So yeah, the Microsoft key is only useful when you want third-party things generic to be loaded with general-purpose operating systems from third parties, without having to each sign those things. So.
Okay, so Bluefin and
Okay.
any more?
I just wanted to comment, like we use this like general purpose servers, and you can go and disable. We don't use shim. We disable the Microsoft keys, provision our own, and just use platform. We don't even use key exchange keys. Like platform key and DBX straight and done.
Okay, so Bluefin, the OS on my laptop, it's actually piggybacking off Fedora shim, and I know this because if I use EFI Boot Manager, I can see there that there's Fedora's shim, and because it's the first stage bootloader, it boots before grub. It's the 0 entry in the boot order list. Now, Fedora Bluefin, which is kind of a rebrand of Universal Blue, it did require me to enroll their mock on my system, which I did, and I can see that public cert in the UEFI firmware using the mock util tool. So you can see there that it's a uBlue kernel. Universal Blue, so that must have been that was the key that was used to sign the kernel that's being boot. Now you can also extend that into kernel modules. You can sign the bootloader if you want to make customizations to grub or system deboot, whichever you're using to boot your system. Okay, so let's talk. So now that we know how it works, let's talk about what the problem is. So for build systems specifically. So the problem is how do you build these images and sign them for UEFI secure boot without ever leaking the private key? Because if that private key ever leaks, that's it. Like all those systems have been compromised. So every Linux distro that supports UEFI secure boot has to grapple with this key management problem. And so far there's no reports of this ever happening yet, but you don't want to be the first one this happens to, because you will look pretty foolish. As a working developer, I mean, I did maintain my own distro once. You're kind of incentivized to take shortcuts which leads to anti-patterns. So what's like the stupidest thing you could do to dealing with the private key is like commit it to Git, right? Like where anybody who has access to the Git repo can get to it. Obviously, you don't want to do that, but hey, if you're really in a hurry, seen people do it.
Who here has had to go in and change Git history to remove private keys that somebody has checked in? Yeah, it's like you shouldn't do that. Well, let's delete it. Oh yeah, now we have to go back and change history. Great. Yeah, a few people in the room.
Okay, so then the other way, so a lot of these CI/CD systems, they have environment variables, that's how you insert secrets into the build. That's pretty terrible because obviously you can output those to the shell. They write them to log files, and they leak that way. There's something called repo variables, which are a level up from that. Supposedly you can't output those to the shell. They don't appear in log files, but like anything, there's ways to circumvent that, and I don't trust that. Another technique is file injection, where you don't display it, but you write it to a file. It's still, it's still a variable. It's still terrible. And then GitLab has an API which lets you fetch the key at runtime, over HTTP. I'm assuming. So what you get is a yeah, HTTPS, hopefully. What you get is a temporary job token. So it expires with the lifetime of the CI job. So once the CI job is over, the token is no longer valid, and you can no longer fetch the secret from the GitLab API. Again, I don't think this is anywhere near adequate, but if you're in a hurry, that's what happens. Okay, how do cloud natives do key management? So from what I've seen, they also use short-lived tokens and credentials. So HashiCorp Vault and OpenBow, which is an open source fork of Vault, that I know that people are actually using these tools to sign images, and they rely on JSON Web Tokens and OpenID Connect access tokens. I think JSON Web Tokens are easier to deal with. OIDC is in a more involved protocol, but again, these have a limited lifespan. I think it's an hour or a few hours. And then there's KMS. So AWS has a KMS service for key management. I don't know that this works for this use case. So I don't know that you can use KMS to sign images or retrieve a private key. Yeah. You can. Okay. So
yeah,
that does work.
Yeah, you can access keys in KMS through PKCS 11, so anything should be able to use them for signing.
Wonderful. So there is PKCS 11 support.
Yes.
Oh, that's okay. I didn't know that. All right. So that's another way to do it. And the way permissions work for KMS is the way all the other AWS services work. You use IAM credentials, which are temporary, just like the token-based approach. All right, so what are the distros doing? I know there's some people from Debian here. I have no idea how they sign their images.
From the Fedora standpoint, we actually have our keys are hardware keys.
Okay.
So there's no way to take our key, and certain jobs by trusted developers get routed to, well, I'd say there's no way. You can physically go in and take our key. We have to get through data center security.
Right.
So like certain users have permission to, like my builds I build an official kernel, automatically get routed to that server. But other users without those credentials do not get routed to that server. There's no way to do it. And I can't even do a scratch build for a user with secure boot enabled.
So it's in an HSM.
Yes.
Nobody has direct access.
Correct. So just certain users have access to build packages on those servers, and that's it. And all other builds, whether any other package for those build servers are only used for secure boot builds.
So now when you're building full-blown Fedora, image for distribution, are you using Koji to build it? Okay. Now, so that's using PE sign D, which is under the cover to actually sign the images.
Correct. And so the way that our spec file works is we use the same PE sign call, but if you're not building on one of those servers, it actually just builds it with it's called the Red Hat test key, which is shipped with. So that private key is shipped with the kernel RPM.
Right. But it's a test key. So
it's a test key. It's not trusted, and it expired, I think, 5 years ago.
Okay, cool. So, and I guess it's safe to say that the other, RHEL and CentOS are doing the same thing.
Yes. Well, they have a slightly different process, but it's still hardware keys internally. I think they can sign after the fact, where I have to sign during the build.
So I know a little bit about Ubuntu and the Debian way of signing things. When you build a Debian package, you can output non-packaging outputs as a result of your build, and then infrastructure can pick them up, and you can have a specific process that you trigger for special packages. I don't know how the keys are backed up in Debian. I don't know how the Debian admins manage the keys. On the Ubuntu side, they also store in HSMs, very much like the Fedora story we heard. You cannot access the servers, only special servers can do that. Not every package, not every archive can get access to the signing keys. So if you're a random maintainer of one package, you cannot use these keys to sign other things. The kernel team can work from the main archive, or they can work from PPAs, which are specially designated with access to these keys. One tool that is not on your slide that is recent is a tool called Debussy. It's a new CI mechanism. It's a bit similar to OBS, I guess, but with kind of Debian semantics. And they have the concept of signing workers. And the signing workers are dedicated for signing tasks, such as signing EFI binaries. And they use an HSM as well. I mean, they expect you to set it up with an HSM.
Just a note, nobody cares if keys are expired, right? Because the firmware doesn't check dates.
So there was a key that expired, but from actually Microsoft keys are set to expire, I think in April, but it's still going to boot. Yeah, the old ones are set to expire, but your system will still boot.
UEFI deliberately does not check the validity. I added the patches to OpenSSL to support that exception. Yeah.
You can't expire. You can't check dates in EFI because you can't trust the clock. Especially in certain industries, you can't even use batteries, so everything's got to be dead. So, yeah, only revocation works.
Okay, and so thank you for mentioning that new tool. A tool that I came across that I learned about from the System D team is OBS Sign D. So I just learned that that OBS is used to build Particle OS, which is System D's Linux distro, and so they have to deal with this key management problem. And the way they do it is they have the keys in an HSM. And they use, they're building Particle OS using OpenSUSE's Open Build Service, which doesn't just build SUSE. I mean, it can build Debian-based Linux distros. It can build Fedora-based Linux distros. And I didn't know anything about it. And so the signing server that's built into OBS is OBS Sign D. And so that's how they are signing Particle OS images. In the Yocto world, there's Matt Madison of OE4T has a signing server. So OE4T is open embedded for Tegra. So it's you know, NVIDIA Tegra images. I mean, NVIDIA Tegra does support UEFI secure boot, even though it's ARM. Yeah.
Sorry, just for the mic, the UEFI spec for ARM supports secure boot. So yes.
Yeah. And so hardware security modules, if you want them, you can get them. There, you can get a Nitro Key HSM2, $65. The firmware is open source. You can pay UBK key more money and get a closed source one. And then get this, AWS has a cloud HSM. You can rent an HSM from AWS for $1.45 an hour. And so.
Yeah, I just wanted to mention that it is worth noting that you don't need necessarily strictly a HSM. Anything that talks PKCS11 like a YubiKey can work. And by the way, this is, I think, what Debian is doing. They just plug a YubiKey to a server, and they just do the signing over that YubiKey.
Or TPM.
Yeah, or anything that talks PKCS11 that is reasonably secure and trap the key is something that you probably want.
A little bit of shameless self-promotion. I'll be doing a talk tomorrow, and I have a long-standing controversial with other maintainers on the Linux kernel crypto mailing list. So there is actually a very useful technology in the Linux kernel called Linux kernel key store, where you can like inject a private key there, and then use it to sign anything, like including secure boot. And in this way, this kind of like it's a kind of soft HSM model where you don't expose the plain text to your processes, so you cannot like accidentally leak those, but you can still like reasonably well sign with kind of zero things. But like everyone except me thinks that like kernel should not have like private key signing support at all. So this is where they try to rip it off. I try to add more, and we have this long-standing like controversy.
There might actually be some good use to that because there are things like AK mod. So if it's people who are running our kernel who are running the NVIDIA modules or other modules like that, AK mod can actually, you can enroll your own key, it generates the key on your system, but the key is always in a known location. So it would probably be a pretty easy remote attack, right? So if you're doing it with generated keys in the running kernel, you might be able to do that in such a way that it was at least somewhat more secure. Maybe, I don't know.
All right, my time is up. Thank you, everyone. I think, are we a break next?
This break now.
Okay, yeah,
I think the break is 30
please come
minutes.
back. We'll have lots of great sessions for the remainder of the morning and early afternoon. And yeah, so I never got to these points, but I didn't need to. These are questions I have if you want to look at them. The slides are online. Thank you.
As much as we're on break, the recording is going to continue. If you're going to have conversations that you don't want to have on stream to the internet right now, I suggest not having it in this room. So go outside. If you want to publish the whatever thing you're talking about, come on up and might as well talk straight into the mic.
And the break is over at noon.
Yeah.
Yeah, well, Leonard was right there. He should probably be the one to talk about that.
You guys still around?
I'm gonna go.
I take my bag.
Yeah. I have one. Yeah.
So my end goal is to make because the problem is buying like relays go out of style. So like I want that's all digital logic. I've never touched it. And it just uses firmware's on. Yeah, no. Well, I noticed that OBS sign too is so yeah, oh, that works on that too. The other part actually. So what Linux are you building? Is it like the absolute AMI? Yes. Now, then Amazon has a distro. Yeah. Right, so you're using Koji. Yeah. Yeah, I mean.
Then actually deploy the structure, like replace components, like we have to align, like,
So I haven't actually, so I come from like the embedded world. So I have no experience with any of these like, mainstream distro build systems like no Koji, no IBM. I'm curious, I mean, given that you chose Koji, like, was it just the best? Was it the best option out of like a bunch of bad options, or did you actually? Oh.
we chose Koji, I think.
Yeah, okay, because that's what was around.
And we're still running Koji because they all know.
Yeah, okay. And so
Significantly better solution, like no solution has worked.
I would say hoping for more of that, or
If I was to do it again.
complicated.
I think it was just right on.
Right, okay, so this is my other question is like, so you use Koji to build Amazon Linux, which kind of makes it Fedora based, right? So like Koji, could you use Koji to build other types of, like, could you use Koji for Debian based distros? No way.
Because it doesn't support.
I would say, yeah, I didn't think so.
It's very specific to your object.
I didn't
As
see
opposed
it.
to, yes, it's a nice thing. And I can make it a system. It just
That sounds like.
I get to the database.
Like that one, yeah, we have to fix this. We have
Build
to have
servers.
like more secure.
And you feel that it's a task, like things to do.
Right.
You
Right, that's what,
build servers.
that's what BitBake is in the octet, it's a task.
It's very hard.
That's what, like, what Koji is, ultimately it's what OBS is.
Because like
That's why it's just OBS are the more fancy that around its tasks. But,
Right,
like,
so
using-
it sounds like OBS is very GUI, so it's easier to get started and then it all falls apart. So, as the project starts to grow.
And then expect to see.
Yeah, I think it works well if you have a established
Like years ago.
infrastructure, physical server. So
It's only for like.
Oh, so you can self-host OBS, like you don't have to like rely on.
Yeah, that
like
is
you can deploy it.
basically.
And I'm not sure the same Koji is the same.
Yeah, ready.
The whole point is that they kind of like. still-
Yeah, so I've actually been, I have a friend who works at Red. And so he's involved with RHEL.
Yeah.
He's trying to get RHEL, everything in our ecosystem to run on RISC-V. Like that's his goal.
This is where.
So he's looking at all whatever build systems are out there. Like, I don't think he understands Koji. he has friends who like do the rel builds, and know how coding works. They've been doing that for years.
Then the new
And so he's actually been talking to me about trying to build Fedora and rel using Docker.
but the kernel
So like somebody. So they were talking. That gentleman there, he was talking about how like the packages weird, like it's all you need the source code to build the one build. It's like it's not like well-known. There aren't like recipes. It's kind of like, but it sounded like that's changing. That's no longer the case.
The way that most package developers you use source files.
Right.
The blob store host.
Right, but those are like
packaging tools.
Okay, but those source tarballs, like they're just like or they're located stores. Like, how do you reproduce the build? Yeah, that's what I want to know. Like, how do you?
Like in our case, we have people of all of the packages. But then people they contain the spec file.
I mean, this is
They contain
one of the
without the
reasons
files
I
and like which source file and what's the signature to verify this source file. And then it's a set of
So it's not database. Or it's a use case. It's a Git. Okay.
and then we have a separate system that keeps all the store of data. Like where we either we generate.
So you have a tarball
and
when there's an All right,
so I think it's similar with the Fedora anyway that works.
kind of like
We did
it's an
initially it was an
so the internal environment does it not like ECDH?
It does its own ECDH.
Yeah, I guess I gotta learn
You have a number of options to make ECDH
because I don't know, it doesn't seem like there's anything
and
better.
then like this
Unless I have to build Debian, in which case
there is specifically Opium more. It's also very limited functionality. All it does is just build stuff. And then all of the logic of
or like
issues that come up with could use when it to be built as a package of this. If I build this one and I can take other downstream package.
I mean, that's
logic is built with it's an OBS. Like an OBS, you build one thing, you build everything. Why could be the mechanics?
So what do you do? You test.
Fedora have their own wrapper. Good. We have our own wrapper.
So yeah, so it's like I will just start with it.
So you have your own build system. That does these things. I mean, because Yahoo does specific for like, but then we go back to I got a lot of resistance from people, trying to like I would like to trust the word, like I don't have a hard time building my own Linux distro that's designed
doesn't have the right primitives to.
But it does all these other things like cross compilation
and parameters.
The whole layering is hard.
Anyway, yeah, I will take a look at the patch set and stuff. Thank you.
And it's also very black. Like it's very easy for things to break and it's hard to debug. But for embedded, where you have control over everything, it works. Yes. Oh, cool. Let me give you my car. It was great to meet you, and I'm so glad so many people were attending and interested in this topic.
And it should be easier.
And the thing, I disagree with the whole shame idea.
Okay, I mean it's a hack, right? It's a total hack.
And I think the whole problem is that, and we're kind of like, we may release an open source tool, which you can disable Microsoft key, but it's not dictated by a stack.
Yeah.
So every vendor, you
Oh my God.
so
You know what I decided that I'm not allowed to eat
the door. That's why I don't want to go, if I want to go my own keys, you can't expect like non-tech user to go into the device. This is the whole purpose.
I have to do it, but I'm pretty tech.
Yeah, but this.
Yes.
No, customer is running this here. Yeah, I think a lot more tips you can build out. So there's
And the whole point is like for a regular user.
I know, actually, no.
If a distro installation would strip the fact that it go and disable the Microsoft key and provision you don't need it. And then even lockdown the security to your specific distro, because in this case I agree, you have the share, but the root of cause is still the Microsoft key. So like if I want to prevent like boot malware on my machine, but someone else discovers a CV in Debian, they could boot the whole Debian still. So, like, this is why, like, in service, we also don't want.
Yeah, honestly, I don't believe in UEFI security. I don't think it was ever secure. You know, it's by design.
People perceive UEFI secure as something. Like people don't understand the threat model. The threat model of your secure boot is to prevent persistent malware.
I'm not sure I'm here yet.
If a person has a physical access to your machine, they could circumvent this. They can go and disable it, even if you put it back, they can bypass it. So like, it doesn't protect a hacker stealing your laptop and doing the system. It only protects like, oh, you download something.
It's absolutely not.
So it protects you from, oh, you download some shit from the internet, because malware now is system. Yes, this is the only reason that was invented. And it works quite well for this case. Right? So like,
But yeah, so for like a lot of these embedded installations, like that's not good. Like you're in a power like perfect. You're like no, you can't. It just goes on.
It's like ocean.
BIOS password.
There are curves that are easy.
You can see the curve. That's unacceptable. That's not straight.
Something better.
Mobile device. Yeah. So I went to the. So in October, I went to the open source firmware.
I saw that.
It was in Sunnybase. Google Cloud Office. So it's like 2-3 days of and it was like supposed to be a firmware. Almost all the talks were about UEFI. Like, almost all of them. And so there are open source. It's always like patient. Yeah, but not only that, the UEFI dev was co-located. So it's just like double the UEFI. And I wanted to learn about firmware, right? You know, I wanted to do like, how do you write firmware in Rust? No, none of that. It was all UEFI. I'm sure somebody is done this.
To be fair, the thing is like you cannot easily script the device. So we're kind of like partially figured out that problem, I think. So we kind of like, because it's not only about UEFI for us. Exactly. So like we need to find out a system. So like nobody's logging into device and fixing anything. So we actually developed a tool which piggybacks on rarely used features in the UEFI settings that we can kind of decipher these settings.
It's like shit.
Well, it's more complicated. You get this, you can actually script. You can cover like a config file saying like for this server model, I want these settings set to these values. And the tool will automatically do it. And with the same tool, you can like disable and enable Microsoft.
Wow. So you're only modifying the TV. You're not doing like
So Shim has this mock thing outside of the DB, DBM. So you're actually modifying the DB.
Yes, and DB and also other settings, other UEFI variables, other settings. Yeah, and then like if you can incorporate such tool, you still would need the sign shim, but the sign shim could be only part of the installation media. So like, let's say you install a Fedora, and on the laptop, it's not supported, the shim could load that script and script say like, okay, now go disable my keys, provision like Fedora keys, and like Fedora and all the Fedora.
Yeah, so we do this in the embedded world, and it's that's because we provision like okay, so the funniest, we wipe everything, and somebody in the lounge or but that doesn't work for like mainstream, it's not gonna, nobody's gonna do that. And we're all like, or probably even like a case I don't know.
Because like really do it. Okay. And the whole reason I don't want like I want my traffic to control it.
Okay. Yeah, it's your machine. It should be your machine.
But as I said, like vendors.
Oh, you know who's really into this concept? Have you heard of offsite computing? They're really, they don't even use UF. All the planes are just. I don't think they use ACPR. They don't use it like when they use this. Yeah. I don't know what they're, so they have like they're doing their own thing. Like they have their own root of trust, like their own microcontrollers. It's not to basically say, what the hell? And they said, well, we can't do anything. I talked to you. Yeah, no.
Again, like iPhone, like mobile device has a different platform. So like iPhone, I have physical possession of device and still I cannot get it. This is where UEFI would not fit.
Yeah, no way.
It's cut.
Yeah.
The problem with it's a website.
Yeah.
Yeah.
Look, so do you know about the Steam Deck?
Screw that. I'm just doing I have.
Yeah, me neither. I think that uses UEFI. Not only that, but like that has like a TPM. Computers too. You can get like TPM lockout. You try to get the deluxe key. But you can still plug in a keyboard. Bypass all things.
Even the whole premise is also if you store the key in the TPM, but not the system around it.
Yeah.
You can do remote attestation with TPM.
Yes,
so
if I am Victoria.
this system is untrustworthy. But you cannot provide the system right and do stuff.
It'd probably be, I like.
Yeah, I think this is the whole premise of.
I like it.
People don't see the this is what the initial I remember the controversy on
No, you can. You know what? It's surprising because I figured that by now everybody just realized that and accepted it, but no, it was like people seem kind of outraged that they have to use Microsoft keys. Like the whole stack is practically built around Microsoft keys. That's how it works. If you use
This is an exhaust manifold.
But yeah, then I saw like, oh, they're expiring. So the like the ones from like 2012 or whatever.
There are ways to
expire. Like in April. You can also still gonna live. So it's like those expiration dates.
Yeah, just like because rightfully mentioned, you cannot trust the case. The servers that go around. The funny part is before we improve the provision and infrastructure so you have a lot of things for its time, but then like the TLS fails. And then you go and like the bug is like, oh, this clock is like 2 years in the future. It's like, okay, like we have to think, even before we start doing.
Yeah, no. face when you're not, when you're outside and not inside the data center. It's just like time, forget it. There's no time. All right, well, great to meet you.
Pretending to do it, and so I was at the point where they're like, next jump, you can do it yourself. Yeah. But I only did a few jumps, and then I decided, nothing crazy, yeah. Sorry, 5,000, yeah, 5,000.
Minute or two?
Free fall is, yeah, about a minute, and then, you know,
I have not yet jumped out.
The problem was that time I was doing scuba diving and starting to do docks, and I was doing one parachuting. Well, the problem was both were expensive.
Right, yeah, exactly.
So I decided to go scuba diving instead. So
Scuba diving is much cheaper than aviation.
At the time, they were about the same. What? Yeah, like once you pack your own chute, it gets cheaper.
Oh.
But when you're paying, like it was $100 per jump otherwise.
That's cheap. Wow.
Well, this is also 30 years ago. I was getting that's like 15, 30 years ago. Damn it.
Well, I was 5 years old when I went.
Exactly. So I bet stories like that too.
Me too.
It's like I lived in Amsterdam when I was 7.
That's when I did my best work on
That's
Black
70s. Yeah. No, it's the first time I was in somebody the other day asked me, you've been to Hong Kong? I'm like, yes. 35 years ago when I was 18.
I've never been there. This is my first time in Asia.
Really?
Same here. Yeah.
You know, in high school, we went to China for 2 weeks in grade 11. We had a travel thing, and so I can honestly say that I was in Tiananmen Square 1 month before the big.
You kidding? No shit.
We saw Mao's grave. We saw like Mao was laying in rest. We saw all that stuff. We saw the whole thing, and then a month later, like I was standing right there where that tank is,
rolling over a child. Yeah. Fun fact: that's how I test LLMs. I asked him what happened. Yeah, what happened in June of I forget the year in Tiananmen Square. And it just that's right. I know it's. It's like Italy, like 67. And in 89 was Paris Striker. That's when it was. That's right. God, we look crazy.
You know what's really weird though? I sometimes wonder whether it's me. It knocks it down, you know, and it burns.
Yeah,
I was in it a month before that happened too. So somebody recently said, "Are you the ones causing the
Flying Dutchman?
Oh no!
Force up stuff.
Yeah. Oh, I used to live in Paris, so we used to go there all the time. So I was there for something else. I thought, let's just go see all the things I saw when I was a kid. And it was beautiful. It was wonderful and everything else.
You know, I took my wife to New York City. I grew up in the Northeast.
Yeah.
And we're at the top of the Empire State Building, and way in lower Manhattan, we see the trade towers. I'm like, we'll just hit an extra.
Oh
no! Yeah. Yep. Exactly. That was 1999.
And you said hit.
Yeah. Oh, we're recorded. I had nothing to do with it. I had nothing to do with it.
Don't get us in trouble.
I have not spoken anything that would get me in trouble.
Not yet, at least.
Yeah. Let's give it a minute.
We'll talk more.
Absolutely. Absolutely.
I'm up next, huh?
You're up next. Thank goodness. Joshua, have you met?
Oh, we haven't set the slides. I guess you can get from here.
I actually flicked to the sponsors because I realized we should have done that at the beginning of the break.
Yeah. Smart.
Pure virtual, one of you.
So when we're done, we should flip to the sponsor slide.
Okay, that's fine.
Are we?
At the end, yeah.
Oh, you were with Steve. Yeah. Oh, you were.
Go find it. Where's the restroom?
Okay. You're lucky. You just stand close to him with himself, that's all. He hasn't got to open his mouth yet. Absolutely. Yeah, he's got a giant. Absolute giant. It's a shame to lose him.
I think the way I most appreciate about Steve is that he's able to
literally talk to anybody.
Things,
yeah, exactly.
Make complicated things simple.
That is a challenge. I don't think you can, I don't think, I mean, I don't think you can get that purely from just practice. I think there's some. It is a desire to as well. You just like shape. It comes from the college professor. I would say the college professor comes from him. Oh, yeah, that's correct. That's right. The other way around. Yeah. So we learn anything in the SBOT? I wasn't in the SBOT presentation. Did that? How did it go?
Yeah. So they figured out a way to generate the bomb from
Which are driven by K2. But you get your flavor, you basically get your flavor in there.
Yeah, so it's got it writes out all the things to build and all of the
Okay.
But what about like, will it
One thing I was thinking
tell?
is people with hash instead of use of.
Like, what
You know,
what does that say?
no.
All right, I'm going to switch over.
All right. That's enough. Okay, so yeah, that really does create a lot. How big is it? How big is it?
Yeah, so I would imagine it's not very. Well, my bar.
I'll let you introduce yourself.
Yeah, that's fine.
Okay. Is it okay if I can press this? Hunter seemed to think that we should let the catch box fall to the last person to use it.
Just leave it there?
Yeah. But
I think the big thing is they can't see who throws you next.
yeah.
So I don't know.
I don't think it makes any difference because I think they just have, it just happens to stare at me a lot and I have to remember not to make faces.
Take your note.
Of course, it just got through the internet.
I assume they're gonna edit.
Look how blue it is.
Yeah.
The colors are weird.
The important thing is I don't.
It's like slightly larger than most of them, but it's lightning fast. That's
It's all more scale. Like if you do the like that one. You can choose how hard it
Dusting.
Again, did a bunch of.
in 10 years. It's gonna do something better.
He doesn't. He's done a lot of.
Oh, yeah. No, I know.
Yeah.
I had somebody say, that's a good time. Well, you know, when people move on to get to the next thing. That shit doesn't happen. People say that about seed.
He's the one like throw around with a little fog.
He was sucking him actually in Amsterdam. Idea.
They used to have an SCA conference.
I'm not ready to see all this.
Tyler xylophone. Especially.
Okay, we're actually.
All right.
All right. So not everybody's back yet, but we are in a situation where we're on the clock here again. So we will get started again. Oops. So, hello everybody. My name is Bian Webster. I am I work for Lenaro, and this talk is purposefully named in such a way to get as many people here as possible. It is clickbait. I will totally acknowledge this. This talk is all about talking about configuration and some of the problems that we have generally in the configuration space. The idea is not to talk about a way of doing configurations specifically, but how to handle configurations across the board. So the whole tenet of this talk is basically to show you prior art and some of the things that are there, some of the problems that are there, and then to talk about how we can perhaps make this work better across the ecosystem, across applications, maybe across kernels as well, but ultimately how build systems can ultimately help to put these things together to make the ecosystem work better, as opposed to trying to fix things after the fact. We all know that things like optimization, debuggability, security, and configuration are all fixed after we write code, right? So how can we make this stuff happen early on so things work better that way? So the big problem is, of course, is things like predictable, reliable, failure-safe full system upgrades are hard. Certain industries have solved the problem or have tried to solve the problem in various ways, but everybody has their own way of doing things. When it comes to things like configuration in the etc directory, of course, it's all designed around the idea of people editing, text files. Those things can change over time. Different distros and other systems have been put together in order to try and mitigate this. Projects like systemd have tried to move towards other kinds of systems to get away from editing etc and that sort of thing. When it comes to embedded systems, read-only file systems are sort of the gold standard of doing things. If at all possible, you don't want those to change, and so on and so forth. But what that means is that we're always in a situation where everybody does things slightly differently. Every application, every different system does things slightly differently. We're still in a situation where users don't like upgrades because upgrades break things, right? Who here can handle failed upgrades in their situation, right? None of us. We need upgrades to be 100% reliable and always work. So why are we putting up with upgrades still being sort of one of the primary risks of things happening? We need people to upgrade because of security and other kinds of issues and whatnot. So right now we have a number of different ways of dealing with this. Looks like there's some replication, rather some repeated statements here I should fix when I re-upload my slides, but there are certain systems that do use layered paths. A lot of this was actually has been pioneered by the systemd project. Things like having defaults under user, having so it's your default configuration under user. Things like your persistent changes in etc, and then maybe your non-persistent changes under run. There's different versioned only, read-only systems that have been brought in. Things like by Confax and such like that. There's the various fragment configurations that various distributions have introduced under the various conf.d directories that have been added over the years by Debian and Red Hat and Fedora and so on and so forth. But the reality is in most situations, most applications, especially if they have things under etc or not, is they tend to largely start off with minimally monolithic configuration files that potentially can change, and certainly sometimes have non-backwards compatibility modifications that happen over major upgrades and that sort of thing. The other thing is in a lot of cases when application or systems configurations are put together and changes happen, not everybody thinks about backwards compatibility, right? And so when people have made changes to configurations, when you do upgrades, all of a sudden things break because you haven't gone in and solved that particular problem. I like to refer to this as the dovecot problem. And so the really funny thing is that Steve Rostow, one of the runners of this particular conference, wrote a really interesting, I think it was a Facebook or LinkedIn article where he complained about upgrading his dovecot server and broke and said lots of things that perhaps I can't repeat here. The funny thing is I had gone through the exact same experience 1 week earlier and had to revert to a backup of my my dovecot server. So I'm still on version 2. Whatever. Okay. The reality is that whose responsibility is it for upgrading those non-backwards compatible changes, right? Is it the user, which is in this case is the deal? Is it the Debian package maintainer or Fedora maintainer or whatever else? There has to be some way of going forward. Should it be Dovecot themselves that provide the tool for doing that? We can have that argument. The point is there needs a way to actually be able to handle that going forward. And so we have all this fragmented different mechanisms of doing things. Build systems handle it differently, different vendor stacks, different application systems. Everyone's got their own way of bespoke way of doing configurations, and very few people think about the upgrade path problem. Some do, but most don't. Okay. So we're getting into a situation now where we have a number of perhaps not new, but certainly new underlined problems. And one of them is that we're getting into a situation now where not only are upgrades mandatory, but unattended upgrades are becoming mandatory, certainly in the consumer space. Being able to make sure that things happen on a regular basis, that things are upgraded, and if there are failures during upgrade, that there might be penalties under certain circumstances, whether it be the CRA or other kinds of situations going forward. And then, of course, there's certain industries where upgrades aren't a failure. You know, things like airplanes, just as an example, or similar kinds of situations, medical devices, military, automotive, right? Now, in the telecom and datacom space, of course, for a long time on things like switches and whatnot, we've used AB upgrades, right? So you put a new upgrade in, you go to it, and if that fails, you go back to the old one. But to a large degree, that largely deals with not so much configuration as it does with the binary side of things, right? So the way that AB upgrades usually work is people figure out a way of making sure that when you go to the B from the A, that in theory the configuration still works. However, there's still lots of situations like doing BIOS upgrades, right? Where they say, do you want to keep the configuration or go back to factory defaults? And then it says, you know, note, it's not guaranteed if you don't wipe out your configuration and go back to the defaults that it'll necessarily work. Basically, they're saying you have to go back to factory defaults. And that's ridiculous, right? Who needs to change your firewall interfaces for your IPMI and all those other kinds of things on systems? You know, things like configuration drift that happens over multiple different machines. The way factory reset works on every device you deal with is slightly different, how it's implemented. It's all you know, bespoke ways of doing things. A lot of processes also require your root file system to be writable, or at least have a layer over top of it that's writable, or what have you. So there's lots of different ways of dealing with that. And of course, dealing with that for one machine, like a single desktop or a series of a dozen servers or so, perhaps not so big, right? Now you have 1,000, now you have 10,000, now you have 1 million devices out in the world. So how does that happen when you start getting into fleet management kinds of problems as well, right? So it doesn't scale well, the way a lot of things are working at the moment. So, I mean, right now we have lots of different patterns that do work. Things like defaults from vendor defaults from local state that you start from and then add changes to. Things like layered fragments, again, having things like your upstream defaults under user and then your local defaults under etc, for instance. Of course, you can put some of those defaults into read-only locations for safe upgrades, but then how do you make sure that essentially your local configuration changes are applied upon the new set of defaults that necessarily works and so on. And so you have a whole bunch of different kinds of problems like this that happen either at build time or at runtime that all have to be handled appropriately. So basically, how can we look at systems that work across all these different domains and still work across multiple distributions, multiple build systems, and so on to make these things work going forward? So, you know, where do these approaches fall short? Now, I do want to point out there's a few pieces of prior art where certainly the claim is that these problems have been solved. Certainly the NixOS GUIX people will argue that their approach to doing things solves a lot of these problems, and that's fair. Unfortunately, these things don't always work in all systems. Dealing with a fleet of devices where you're trying to upgrade things across, you know, 10,000 devices, perhaps not so much, right? System D solves some of these problems, and certainly from a deployment situation under certain circumstances, it does a great job. Again, not all systems run System D necessarily for due to space or size. Increasingly more and more, but not in all situations yet, right? Things like Convex, of course, enables read-only overlays that with schema validation merge semantics, which is great. We also have similar kinds of ideas when it comes to doing things like the kernel configuration that we were talking about this morning. A certain amount of similar ideas. So there are fragment systems for different mechanisms to make things go forwards, like kernel configurations. And I didn't actually realize that Fedora did similar things, so that didn't make it into the slides. But Fedora kernel does similar kinds of things, as does Debian. So that's all good. But the big thing here is that there's a bunch of different mechanisms. Everyone does things slightly different, even if they're similar, but it's not the same. We're not sharing kernel configurations across all the projects, for instance, and so on and so forth. So really what I'm trying to figure out, or trying to put to this room effectively, is how can we basically make these things work across the ecosystem, between build systems, between applications. How can we push good practices across the ecosystem? And because we can't solve it just in the build system, we can't solve it just in the kernel, we can't solve it just in the initialization system, right? How can we basically make these things work going forward? So there is one approach that I find works fairly well. It does fall down in certain situations, and it is absolutely tied to how network operating systems work, right? The idea of effectively having a single command line config situation where you basically build effectively a JSON or YAML file that is then used to generate your etc directory at boot time. And this is how Viata does things, right? And this is how a similar mechanism to how things are done on Cisco and Juno S and other things like that. Does it work for all systems? No, right? But it does work in this very minimal situation. Viata basically takes that configuration file that's kept separate from a base read-only file system and then generates a layer that goes on top of it, is really what it comes down to. It's all written in Perl, but we will forgive them for that. It doesn't have to be. It's been around for a long time. Come on. By comparison, Python's relatively new. Okay. Again, context. The context is primarily in the network operating system. It is reliable. It does have validation. You can roll back to previous things. There are ways of dealing with it. Unfortunately, you do have to have that writable etc directory, right? So it does mean that you start getting into drift, because you can change that layer. The nice thing about Viata style configuration, though, is you can get rid of that writable file system and go back to the original underlying read-only file system. So factory reset is handled in that particular situation. Again, does not work in all situations, merely a way of doing it, right? It solves the problem in this particular case. The nice thing about this is that when you do major upgrades, because you're going from metadata and generating specific configuration files, you just change the in this case, Perl script that goes from the shared configuration to whatever the new format is. So there's a way forward to deal with those weird upgrades. Okay, so really what I'm suggesting here is some not rules, but some suggestions as to how people can go forward in order to make things work. Just generally, I'm suggesting that applications, certainly user space applications in general, should follow the systemd style, defaults under user, local configuration under etc, ephemeral changes under run, those kinds of ideas. Now, for things that are handled by systemd, kind of a solved problem, right? But in situations where systemd can't be used, apply the same kinds of logic. Right, so still use that same kind of idea that's how these things go forward. And the thing that's interesting about this then is how do you put together the defaults that go under user, and this can either be done by upstream, or it can be done by the build system itself, right? So the default that goes under /user should be something that can be put together under Yocto project or build root or whatever else, we could generate that based on a configuration fragment kinds of systems going forward. And again, that's kind of a shared pattern that could go across all build systems potentially. Again, site-specific overrides under ETSI, but again, to a large degree, you want these to be different, or to at least override or merge with the configuration, the default configuration under user. Things like having overriding local intents and other things like that, search and precedence ordering and so on, validation, rollback, and all these kinds of ideas.
I wanted to quickly say one thing is the way how this works in systemd, right? Like we actually wrote a spec about this.
Yes.
It's on uapi.org.
100%.
So yeah.
A lot of these ideas I got from.
If you want to ever point somebody in like how to implement this, just point them to that spec.
No, absolutely, and I fundamentally want to say that a lot of the ideas here come from looking at systemd. So 100% agree to that.
Any thoughts on how we can export this information for audit and replaying for actually doing analysis back down the road?
That's
when issues come and play.
That's a really good question. So I did not put any thought into this.
I'm a Vita fanboy. I love it. And from a configuration standpoint, one of its real strong points is that applies semantic meaning to configuration segments.
So that we have validation.
Precisely. So that when you need to audit yourself, you have semantic meaning already applied to it.
And this is, again, if you go back to the Viata way of looking at things, you can basically say, this is not going to work. And you can tell this before you even try it, before you even write things to the configuration.
You have one view of the semantic picture.
Yes. Yes. Again, a lot of systems don't do this. Some do, which is one of the reasons why I'm glad you're in the room.
What I wanted to say is, regarding auditing, in my perfect vision of the world, right? Like where you have ETSI and then you overlay a couple of convex. Of course, the auditing comes through the convex stuff, right? Like because the idea is that every convex image that you apply is Verity enabled and things like that, and that we can measure it before we apply it, so that the measurement blocks will tell you exactly what's actually applied, and you can through remote attestation, whatever you like, figure out exactly in which state the machine is.
Does that work for local configuration? So somebody actually has a device, a consumer's device, makes a change.
So in my ideal world, there is no local configuration.
Yeah, well, I realize.
Like it really depends in
this is why I asked the question.
If you're cattle or pet thing, right?
Sure.
Like in the pet thing, there will be local configuration, but then you don't need auditing. And in the cattle thing, there should basically be, I don't know, ETSI machine ID as local configuration, like these things that make up the identity of the system, maybe an SSH key that is persisted or something like this. But other than that, there shouldn't be much. Right?
But no, think about this though. Think about the infotainment system in a car, right? How many changes do you make the configuration to that? And that's still a fleet managed device.
None of them, because they're all stored. They're all user preferences that are stored in the cloud and applied to the instance when the user logs into the.
Not in my car, they're not.
In a modern vehicle, that's how they work.
Okay.
So there are literally no local configuration changes. I built an automotive OS last.
I have too, but yeah,
those get pulled down from the cloud. So in my world, I actually have local configuration changes, not because I want them, but because the hardware mutates over time as it gets impacted by micrometeorites and the like.
Okay.
And so I actually have per device configuration information, not because I want it, but because the device literally has parts of its environment that are dead, and so it has to be locally mutated. And so I actually end up persisting that information out to the cloud and apply that configuration as I perform the update.
There's lots of devices though that can't necessarily do that. Though.
Exactly.
So
I'm in the order of thousands. I'm not on the order of millions.
But I'm very glad that you brought that up, because I know that that's your ideal case, and of course it doesn't work in all situations, which is one of the reasons why. No, I understand, but right now it doesn't, right? So
I'm sort of looking at if you're basically having to maintain something for 30 years and you have to basically take yourself back to a state to fix issues.
Yeah.
And how can we keep enough metadata around so that we can do that?
We have many use cases.
So what I also wanted to say, things like ETSI machine ID, which are inherently local configuration, right? And that need to be written. They're also measured by system already separately, right? Like so that you actually have that in the measurements. And about local configuration, the model of config actually allows this, like, because configs nowadays you can have mounted writable layer on top, but it's always like separated out. But I mean, when you add auditing to this, you would have to think, like, if you actually want to have mutable etc locally by any application that there is, then you have to think about auditing of files, and I fucking hate that.
No, absolutely. The point is,
yeah,
we don't necessarily want mutable etc as much as we want a mutable configuration that somehow leads to a validated etc. So, yeah.
All right.
Yeah. So I'm first of all, I'm glad everybody's brought up what they brought. This is exactly the kinds of things I was hoping would be said. The big thing here is that we do want to be in a situation where we get away from these kinds of problems, where we have patched out ad hoc configurations. We do need migration paths that work 100% of the time. Without conflict and read-only that work with read-only systems and other things like that. Downtime RMAs, these are all things that we don't want to see happen. We don't want to have to ship devices back and so on and so forth. The big thing is the upgrades need to be boring and reliable by default. No outages, denial of service, no fear, especially for embedded systems for doing upgrades, right? So basically, the whole point is, how can we make this work with or without systemd, and how can we bake this into the fundamental ecosystem to make things work going forward? So, and again, the whole idea is to balance sort of structure and process with the ability to be flexible and to have people do their own configuration and that sort of thing. So, the big thing that all comes down to is whatever the ideas are across the ecosystem, I do think they fundamentally need to work both with and without systemd. Lots of systems will use systemd, some won't, right? So the ideas need to be compatible both ways. Systemd will very heavily, therefore, influence the way things going forward. So it's compatible. It needs to work with root-only file systems and also support things like factory reset. It does need to support partial or incremental adoption, so parts of it need to work even if the whole thing isn't. And then finally, of course, we need to be able to preserve existing configuration fragments and other systems like that. Yep.
So should we be thinking about meta viata?
No, I think that's prior art, and it solves some of the problems, but it does have issues.
Yeah.
Right. It's not the only way of doing things. If everything looked like a network switch, yeah, sure. Right. But not everything looks like a network switch. Right. That doesn't necessarily work. The thing about network switches is they're all slightly different because they have to be set up slightly different because everything's plugged in slightly differently, right? As opposed to a whole bunch of VMs that come up over and over again, or come up, do something, and then disappear again, right? In that case, using systemd and configs makes a lot of sense.
That's a very good point.
Right?
Yeah.
So, but this is the big thing, right? We don't have, it's not going to be a universal solution, but we do need a way that deals with always with validation, with rollback. We do need a layering system. And we do ideally need something that hopefully works across the embedded ecosystem minimally in a similar fashion, right? There'll be a similar way of solving it in cloud. There'll be there needs to be a similar way to do in embedded. Right now, we have everything different on every embedded project I've ever worked on has been slightly different, or we've solved the problem again, right? So how do we basically make this so that we have a minimal set of processes, approaches, and ways of doing things, ideally further up the food chain prior to the build system as a part of the configurations.
This is a great set of requirements. Maybe we should just think about, like, making this more formal. Here you go.
So, as mentioned, I'm not a big fan of mutable etc, but
no, of course.
When we added this mutable feature to configs, right, like that you can say if it can top layer, we discussed a couple of things, how this could look like in the end. We never pursued that because we not big believers in mutable etc.
Understood.
But, the mutable layer that you put on top is just one directory in var lib somewhere.
It can be, you're right.
So
totally right.
If you want the rollback stuff, right, like what we discussed back then, is you can just basically say, I don't know, systemd configs checkpoint or something, and then it just makes a copy of the thing in varlib, and then you can return any time back to the original state.
And on systemd
things like this.
systems, that's perfect.
Yeah, sure, but I mean, of course, I don't think there's anything else in systemd systems, right? But then again, you know, context is ultimately trivial to implement, right? Like it's just fucking overlay FS thing, right?
It depends how much memory and storage space you have is really what it comes down
Yeah,
to.
but my suggestion would be maybe like, I mean, all these embedded devices are going to have overlay FS in there probably anyway. So maybe if you really dislike systemd, just make something that works like context, not systemd.
We argue over 1/10 of a cent in BOM costs. So unfortunately, that's not always something we can
Yeah, but I mean, overlay FS is not large, right? Like,
I'm just saying it doesn't always fit, is what I'm saying. So just really fast, we're running out of time. I put more in the slides here, which we may not get to. The whole point here is that we're basically the thing to think about is we're trying to solve. As an ecosystem, we need to solve problems that will work under situations that are becoming increasingly covered by rules and laws and other things like that penalize people who make devices and certainly software people and so on and so forth. So the big thing is, how can we make things predictable, auditable, failure safe, and boring. We want upgrades to be boring. And the ideal situation is one where the upgrade happens and nobody notices. Okay, I know everybody here hates having automatic upgrades and all these other kinds of things, but to a large degree, if you see the latest, let's say SSH, CVE that comes in, and you go in and check which version is currently running on your machine, you're like, oh, I'm not, I don't have the version that's covered by the CVE because it's already been patched, right? That's the ideal situation, one where you don't care about that sort of thing. So I've got a whole bunch of questions here that I was hoping to get to before we actually started talking about things, but like these are the kinds of things that the kinds of questions we need to solve as an ecosystem, as a cross-industry kinds of problems. To look at best practices from certain areas where people have put a lot of thought into it. Certain areas like the kernel where they've solved specific problems, certainly around these kinds of things with config fragment, Yocto project and such. How do we build it into the build systems in a consistent way so that it can be shared between different systems, between distros, between build systems, build root, Yocto project, and so on. PTS, dist, and so on and so forth. And how do we make that work appropriately? And so that's really my call to action, is how can we get this to work across all systems in such a way that the users, the people who are ultimately making things, don't have to worry about it anymore. We shouldn't have to solve this post build system. It should be solved before the build system or by the build system. Yeah. Does that make sense? So yeah, we're almost out of time, but that's the big thing. Upgrades you don't want them to be. It's like flying on a plane. You don't want it to be exciting. You want it to be boring. And I'm not just saying that because of you. So yeah, fear-free upgrades, ecosystem requirement, not a luxury. That's the message I want to put forward and basically have people start thinking about. And I'd love to see like this stuff built into the build systems. And 3 seconds to 1, we're out of time.
All right, let's thank our speaker.
Who's next? Who is next? That's that one? OpenWRT?
Yeah.
Perfect. Good. Just want to make sure I put the right slides up.
All right, our next speaker will handle his own introduction.
All right, so I'm Denver Gingrich. I work at Software Freedom Conservancy, and this is the OpenWRT build system, talking about all the compliance that we got and how we can maybe adapt this for other build systems. So to start, I just wanted to introduce why it is we're talking about this and use an example here. You might guess I'm using the OpenWRT1 as an example. I don't know why it's orange. It should be blue. But anyway, I'm sure.
You look blue in the up there as well.
Oh, okay.
It's very strange.
Ah, very interesting. All right. So anyway, Okay, excellent. So the OpenWRT one is a blue router. It has a USB-C serial port on the front, so you can see all the boot messages very easily. We've really made it something for developers who like to hack on things. You also see the Ethernet ports on the back. You can power it over USB-C or power over Ethernet. You can also see there's a NAND and NOR switch on there. So you can switch between your different firmwares. And if you corrupt both of them, you can also boot off the network. So it's an unbrickable device. Then on the inside, we have some interesting things like a populated JTAG header and microbus port. So people might like to use those. There's also an M2 slot for adding storage or other PCIe things. So anyway, just wanted to set up things what we're talking about right here. So why is it that we need embedded build systems? Well, I would posit that is because we want to build embedded devices. We would also like to sell those embedded devices. And when we sell things, we must comply with certain requirements and regulations. And so that is what I'm going to be talking about. And so with this compliance that we need to have, what do we want to know first? Well, we really want to know what's in the thing that we have, so that we can determine how to comply with the things. And the simpler that thing is, the better. So ideally, we would like to just have a set of package versions and package names, and that's what we would have. Of course, there is a bit more to it than just that. And the other things you may have are things like out-of-tree patches. You may also have some non-free stuff here. I just mean, proprietary programs that may also run in addition to the Linux or whatever else that you may be using that is hopefully fairly upstream. And so these are the things we would like to minimize. There are also other things you might want to think about. I'm just going to mention this briefly because many people have spent lots and lots of time talking about this, so I don't think I need to spend more time on it, whether your proprietary thing is derivative of some copylefted thing. So anyway, I'm going to be focusing on the other things here. Now, I would like to start with this example of the OpenWRT build system as we have implemented some of these compliance things using that build system for the OpenWRT1. So we start with the OpenWRT base tree. So you could call that the OpenWRT build system. The thing called openwrt.git that you can find at git.openwrt.org. So this is something that was long ago derived from Buildroot in 2004 when OpenWRT started. Buildroot had started just 3 years prior to that, and it has diverged a lot since then. There are a lot of OpenWRT specific things in it now that assume, a certain file layout and set of packages and things like that, initial packages. So that is what we are starting with here. Now, once we have that, we run make menu config to get a nice .config file, and then we run make download, and that will put all of the upstream packages into a folder called DL, and then a bunch of metadata and configuration for those packages into a folder called feeds. So we're almost there in terms of getting this package of complete source code together. We just need to add some how-to files. So these are things like how to set up the build system, how to build the system, and how to install it. And so this is really important, and one of the things I'm going to spend a fair amount of the rest of the time on. In addition to your questions, of course. And so these are the sorts of things that developers who like to hack on things will naturally create because they would like other people to be able to use the work that they're doing and to be able to build on it and add interesting features. And so this is the sorts of thing that you might build naturally. And thankfully for us here, it is also required by the GPL. So we can include this. You can have fun both ways there. So what do we get out of all of this? So we get a minimal set of things that we can reason about. This is really the key here that I'm trying to get to for the purposes of thinking about compliance. So for example, with the CRA, you may want to know whether the packages that you have certain security vulnerabilities in it. And so having this minimal set of things makes it much easier to find those than if you have a much more complicated system with things like the FCC. Yes, go ahead.
Okay, you mentioned the CRA, so I get to ask SBOM.
Uh-huh.
Are you able to generate SBOMs for this?
So you could absolutely, if you wanted to, but I would posit that the thing that is more important is that you have the complete source code, because when you have that, then you can answer all of the questions that an SBOM can answer for you.
I'd say the SBOM is going to say what was actually made it into your image, as opposed to the full set of sources, and so that lets you know exactly which licenses have been combined together. If you get the detailed SBOM information, and the CRA is asking explicitly for an SBOM now, so this is kind of why I'm saying that the sources are not going to be just sufficient.
Right. Okay. So yeah, I'm happy to chat more about that generally. I think, that's partly also why I use the word minimal here. So like if there are sources you are not using, please delete them because they are just confusing for what is going on in the system. So that's really what I would say, and what I'm trying to focus on here is that we have this set of things. So yeah, I could see situations where, if you're building something, it's configured in a certain way that not every line of source code is used. Absolutely, that may be the case. But yeah, I'd be happy to chat more about specific CRA requirements on that. So the other thing that we can get out of this is kind of on the flip side. You might want to know if something has changed, so that whether you perhaps need to recertify something. So maybe a wireless firmware has changed in some upstream repository, and then you may need to recertify it, possibly under the FCC or other things like that. So that might be another thing you would want to know. Now, importantly here, we have a simple base that is the OpenWRT build system, and these how-to files, simple configuration, so that .config file and the package-specific configurations, and really the rest here is upstream. And for the OpenWRT1 in particular, we were very fortunate that the people in OpenWRT were able to get basically everything in upstream from the time we announced till the time that we launched approximately 1 year later. So this is really super nice to have. I realize we don't always have that, which is part of why I'm giving this talk. So the other thing that we have here is that once you have all of this together, once everything is organized in this way, the development of future things on top of this image are steered towards simplicity. So if someone is wanting to add a package or change some configuration options, they will naturally see how it has been done. They will add a line to the .config instead of copying in a giant vendor tree from somewhere, and then things will be much simpler. At least that is the hope. Hopefully it is at least easier to train people to use it in the correct way. Now, the thing that we have at the end here is a self-contained source tarball that was easy to create. So the source tarball for the OpenWRT1 is approximately 1.2 gigabytes. That includes the whole tool chain, all of the upstream packages, etc. And you can build the whole thing offline because everything is there that you would need. So you may be wondering that you may be thinking like some of this stuff is not part of the build system or the process that I use. And that's, partly why I want to chat about these things. And in particular, you may be wondering about these how-to files. And so I would like to chat a little bit about these how-to files, what they look like, how we can maybe adjust our build systems to at least suggest that people, be sure to have these sorts of files in the thing that they are distributing for compliance purposes, whether that be compliance with copyleft licenses like the GPL or other things of that nature. So let's fix that. And the examples that I'm going to use here are from a project that Software Freedom Conservancy started a couple of years ago called Use the Source. So this is a website where you can take a look at different source code candidates that companies have provided, and you can discuss how you can do interesting things with those source code candidates, or discuss whether they failed to work for some reason for you. So I'm going to go through the first 4 devices on Use the Source, and I'm going to go through abridged versions of the instructions that they provided, these how-to files that are required by the GPL and other copyleft licenses. So I will start with the OpenWRT1. Before I get into the files themselves, I just want to show this is a diff of the LS between the OpenWRT build system itself, that openwrt.git repo, and then the thing we actually shipped for the OpenWRT1. That is this full source tree that provides for all of that GPL compliance. So you can see that we added the .config file by running make menu config. We added a DL folder, so that is the folder containing all of the upstream package tarballs. We added a feeds folder, so that contains a bunch of the package metadata and configuration. And then we added these 3 how-to files. Now, the first one is there for convenience, not required by the GPL, shows you how to set up the Wi-Fi. The next 2 are required. Those are how to set up the build system and how to build and install the software. So let's go through those. The first one, how to set up the build system. It shows you right here that you need to install these packages. It provides a bunch of different distributions as examples, like Alpine and Fedora and others. I'm just showing you the Red Hat example here. They're all very similar to that. Now, you don't have to do this. You can just say, I only tested it on this one distribution. That's okay. I would highly recommend you do more than that. That's up to you. And so then we have this how to compile and install. So if you want to see more details about the build setup, you can do that at that URL. You can optionally install Lucy, the web interface for OpenWRT, and then you simply run make, and that builds the toolchain, builds all of the packages, including Linux, and then assembles them into an image that you can flash onto the device. So you do that with the using SCP, using the built-in OpenSSH server that is there by default for OpenWRT, and then you run the sys upgrade command, which updates you to that new firmware image. So pretty simple, pretty straightforward. Yes.
But this is in the existing README file.
Yes, that's right. Yes.
But the problem is the file had the wrong name.
No, that's fine. It's just we want to make sure that it's very easy for people to find this information, because if you have someone that is not familiar with OpenWRT, maybe hasn't read that entire giant README file, they should be able to simply find these steps so that they can do this very, very easily. And notably also, this gives you some device-specific information about the upgrade. I mean, in this case, it's fairly general if your device is already running OpenWRT. In the case of the OpenWRT1, it is, of course, shipped running OpenWRT, but on other devices, that might not be the case. You may have to do something more complicated. So this would not work, as, a README for a random router that is not running OpenWRT if you wanted to install OpenWRT on that router.
Are these how-to files a requirement for GPL compliance? So is there presence in the big tarball or whatever it is that you submit for GPL compliance? Are all devices required to have these sort of how-to files?
So these are the scripts used to control compilation and installation. So that's text straight from the GPL and LGPL. And so these are what is required by the license. You don't have to call them how-to whatever, but you need to have these files in there.
So if this information is already in the README, why do we have to have another one, since it's that, wouldn't the README suffice for the conditions of the term of the GPL?
Yes, it would suffice if all of that information is there and easy to find. Part of why we did this for the OpenWRT1 is to show people how they can do this if that is not the case for whatever system they are using. And so that's partly why I'm going into these additional examples here, so that people can see how it's done. So I'll move on to the next one, and then we'll take it from there. So this next set of, you could say, how-to files, I think they're named something else. These are from Samsung for a Samsung television. So in this case, Samsung is showing us how to build Linux. So you copy a config file into place, run make old config, then make image, copy it into a staging area, and then with BusyBox, you run a make command for that. Here you need to specify the cross compiler, so we ensure that that is done. So now you have your BusyBox binary. You want to put that now into a rootfs image. So helpfully, Samsung has provided this rootfs .image file in the source code candidate that they provided. You don't necessarily have to do that, but you do need to provide a way of making sure it gets installed. So you unpack that image, you put BusyBox in there, you repack the image, and then you have a new rootfs with your updates. Now, once that's all done, in order to install all of these changes, you connect a serial cable to the serial port, is what Samsung tells us to do. You make a folder called update on a USB stick. You put all of these files on that USB stick. You plug the USB stick into the television, and then you turn on the power to the television. And then using that serial cable that you have connected, you use a few different key combinations in order to get you to the U-boot menu. And then once you are in the U-boot menu, then you run, then you type I think it is BBM USB, then press enter, and then it will give you a list of all of the things you can update, like the different sections of Flash that you can flash these items to, and it tells you how you can install the kernel, the updated kernel, and then the updated rootfs image onto the Samsung television. So the rootfs that Samsung provided does not contain any of the proprietary programs that Samsung ships on their TV. That is okay under GPL version 2. Samsung does not need to make those keep running if you change the copylefted programs that are working underneath of it. So this will essentially boot you into a BusyBox prompt on the TV. Now, people have gone ahead with this source release, and they've created a project called SamiGo, and that allows you to do some more TV-like things with this source code. So that's a neat thing that we definitely encourage. You know, it's how the OpenWRT project started when we were able to get a source code release for that way back in the day, and that's been super helpful. So this is how Samsung tells you to build and install on their television. Now, I just want to go back to another router for a moment here. This is perhaps even simpler than the OpenWRT1. So you unpack the tarball, you simply run make, and then it creates an image very similar to the OpenWRT1. And for the installation in this situation, all Think Penguin routers come with a web interface, and so you use that to install the updated firmware image onto the device. Going to that address, going to navigating to the Flash firmware section, and then uploading and pressing the Flash image button, and then that new version of the software will be installed installed onto the Think Penguin router. And lastly, I wanted to go to this AVM device, also a router. And so in this case, you can see here they've told you we only tested this on Ubuntu 22.04. That's fine. We will go ahead and get the source code that they provided. Now, it's better if you include this source code in the source package itself, because then you're not concerned about these websites going down or something, or becoming unavailable for some reason, which would make you out of compliance. But anyway, once you have that source code, you can run your make menu config, and then you can run make tools to build those things you just configured. And then once that is done, similar to the Samsung television, you unpack an image that is provided, you install the thing, you copy the thing that you wanted into that image root FS. In this case, AVM is showing us how to put an updated UC libc into that image file. And then you repack that image file, and then you install that image file onto the device. So in this case, AVM is showing us how to connect another computer to the router using a particular IP address. And then there is this tool called push firmware, and you use the push firmware program to wait for the device to boot, and then it will transfer the image onto the device and then install it onto the device. So it is all ready to go. So this is how AVM tells you how to do it. Now, these are the 4 examples of how you can make these how-to files. And so I think it's pretty nice to have these, and that's partly what I wanted to open things up for discussion about. So I'm just going to summarize, and then we can get into some more questions here. So we want to make it easy to reason about things. We want to make it easy to build the things that we have, and we want to make it easy to install all of these programs that we just built. So I wanted to just briefly mention, I work at Software Freedom Conservancy. We are in the middle of our end of year fundraiser right now. We are a 501c3 nonprofit charity. And if you like the work that we're doing, I would highly encourage you to donate to us. Your donation counts double for the next month, thanks to generous matchers that we have. So there is also slide source code available using the link at the bottom there, as you might expect from me and Software Freedom Conservancy. And I would love to chat now about these how-to files, how to encourage people to include those in source releases that they make, and also, how we can make sure our build systems are simple enough, generate minimal enough things that are easy to reason about, with all of the other build systems that you might be familiar with. So thank you very much. And I think we have some questions already here.
Yeah, so a lot of regulation now is moving towards requiring a completely signed boot process all the way into the root file system with like dmverity or dmcrypt. How do you have a plan for how to handle that?
So for the OpenWRT1, the hardware does have that capability. We chose not to do that for the initial instance of OpenWRT on the OpenWRT1. But yes, that is something that we can definitely include, that I think will be important, as these things become more clear about what exactly is required.
You don't have to do it already, honestly.
I'd be happy to chat more about any particular regulations and things that we can be aware of and make sure that we've got included.
So in the Samsung television example, is that an instance of where the SFC was applied pressure on Samsung to release all the source code and how-tos for how to build that TV firmware, or did they just voluntarily open it up?
I mean, it is a case where we did request the source code from Samsung. We expressed some concerns about what they gave us initially, and this is what we eventually got from them. So there's some more details on that on use the source if you want to check it out.
Okay.
Yeah.
Do you know what is there a build system that that is required to build that TV image, or was it just some scripts?
Yeah, so this one is a little more custom. I don't know offhand what they used to make it, but yeah, it was whatever it was, they were able to make it some fairly straightforward, simple instructions. So I'm happy they were able to do that.
It's all in the how-to files.
Yep, that's right.
So
Exactly.
there's no outside tools that aren't already included in the tarball.
Yeah, exactly. And I believe Samsung is another situation where it's fully self-contained. So there's nothing you need to download. You just set up the build environment and then off you go.
Okay, you can tell me if this is out of scope, but I'm aware that OpenWRT supports runtime package management. At least they did, the last time I played with it.
Yep.
Which means that you can download and install packages using OPKG.
Yes.
From package feeds, cloud or wherever. Is that something that OpenWRT users are taking advantage of? Like, are they building their own packages, either submitting them to whatever the main repo is for OPKG? Are they standing up their own package repos? Are they doing things like that?
Yeah, I mean that's one of the great things about having something like OpenWRT on these devices with a package repository that has all of these user-created packages in it. I think one of the most popular ones is an ad blocking one, specifically a tracker blocking one. It just so happens that today, if you block trackers, you also block most ads. Sadly, we could differentiate those anyway. But yeah, a lot of people use that to prevent websites from tracking them. So that's super popular, and I'm glad that we have that as an option. And it's also a good reason that people may want to install something else onto their router or other device because it can make sure that it is doing what you want it to do and not what someone else wants it to do.
Full disclosure, I have an OpenWRT one, and I bought it expressly so I could keep my son from connecting to the Wi-Fi. Basically block his hardware MAC address.
Sure, I mean you own the hardware, so right? Yeah.
And so yeah, if someone were to create a package to easily do that.
Yeah.
So it used to be the case that if you install extra packages, as you said, then you install one of the sort of official release upgrades. All your extra packages which were installed on the overlay were lost. But there is now a managed sys upgrade option where basically it uploads the set of packages you have installed, and it will generate an image for you with exactly those packages you upgrade to. So that they're not even lost on upgrade packages from the official.
Okay, so that way, when there's a full OS update, you're not forced to reinstall the package.
Right.
So time for maybe one more question, if there's any more discussion. All right. Thank you so much, and I'll be around.
And our last talk will be from Joshua. No. Hold on.
Are they on?
They're on.
Indigo?
Yes.
Give me 2 seconds.
Okay, sorry about that.
No, it's okay.
While we update the slides, I would like to commend anybody who makes it easier to explain how to actually do what it is that we do. Because I've certainly told someone that it is ridiculously easy to build an image based on my instructions and they get mad at me because they're not clear.
1 second.
Sorry, I had to keep it complicated, you know.
No, it's okay. Hamster wheels grinding. And there we go.
Hey, there we go.
Hold on, I have to give you presenter. There you go.
Yes, the colors are definitely off.
Yeah, that's weird. It's just on there.
Yeah,
It's just
there.
on this screen.
Yeah, yeah, no.
It's correct online,
It is,
so
it is. So
you'll just all have to. There you go.
it's been rebranded.
Yeah.
Yeah.
Yeah. I've got some colors in my slides, so they're not going to show up properly, but yeah. Yeah, there you go.
Take it away.
All right. So my name is Joshua Watt, and today I am going to talk to you about improving build time software bill of materials. I'm not going to go through too much, but I'm mostly involved with Yocto and SPDX and do a bunch of stuff there, but it's fine. What is a build time SBOM? And this is supposed to be a more or less interactive thing. So, you know, if no one talks, then we'll just get to our bento boxes early. So please let me know. All right. So what's a build time SBOM and why do we care about them? Build time SBOMs are a little bit different than some of the other SBOMs you might have seen out there in that the intent is to document a build process that occurred at a given point in time, not necessarily the state of a piece of software. A lot of times when people are talking about SBOMs today, they're talking about what's the software running on a server or running on my device. And that's great. You do need those. But this is more about how did that software become into existence? And that involves documenting the process of doing the build, which happened at some point in time. So it's a little bit different than that. And generally these SBOMs, the idea is that you have some process and there's inputs to that process. We need to know what those are so we can track them. And then it has outputs. And ideally, we would like whatever we do to be attestable. For example, like the Salsa project and in Toto, they all want to know, like, not only can you say you did something, but can you sign off and say, yes, this happened at this time. So there's very much a sliding scale of what you can consider a build time SBOM. You could have it be as basic as the high level command that the user executes to do the build. So, you know, I'm familiar with Yocto, so that could be as simple as the user typed bitbake core image minimal, and that could be documented as your build process. It could also be as precise as this was a specific invocation of the compiler that took in this source file and spit out this object file, and basically every level in between. And even though there's like this sliding scale of how detailed you want this build process to be, the other thing to keep in mind is that you really want these to be composable. So you want it so that that high level build process that you have, where maybe the user typed in, you know, make or bitbake or whatever it is, that actually then links to the next level of the build process, which then links on down to the next level, all the way down to these invocations of specific compiler commands and things like that. So you want it to be, you know, there's a sliding scale, but you want them to also be composable in a way that you can link them together and recreate that hierarchy. Okay, so why do we want these? The thing that most people talk about right now is, of course, regulatory compliance. That is some really ugly looking cheese. I would not recommend eating that. It's supposed to be yellow. I really like this picture from from CISA, I think it's from CISA. Yeah. So their whole goal with the regulatory compliance and SBOMs is not to completely eliminate all the vulnerabilities, but to remove a lot of the holes in the cheese. But you know, a lot of SBOMs in the regulatory compliance space today are mostly concerned about that runtime component, although we are starting to see more and more people that are interested in how the software was originated. And so, because that's really important for a lot of things. But it does seem, yeah, like I said, it is likely that we are going to see more and more this build time SBOM stuff show up in regulatory compliance. We don't know exactly what the CRA is going to require, but I suspect there will be some level of build time SBOM involved in it. I don't think they're, yeah, because they want to do, and the reason they want to do that is because supply chain attacks are relevant, highly relevant, and build time SBOMs can maybe not 100% prevent them, but it can certainly help triage them and figure out that they happened much sooner than you might be able to detect otherwise. Even if you're consuming pre-built binaries, you really want to know where those came from if you're putting those into your software. And again, the attestation is really important. People want to know. People want to be able, for you to be able to say, like, we did this thing to produce our software, and we can sign it and attest that that is what actually happened. So there is some prior art on how build time SBOMs are generated, and I'm going to go through a couple of examples of kind of different levels of that pyramid as to that are generating how build time SBOMs are being generated today. So kind of the first option that I have seen out there is tracing, and this is basically where you use strace to trace your whole build process and basically produce an SBOM from that. So I mean, this does work, and it is highly accurate, right? It's a very complete SBOM that you get by doing this. And one of the advantages of this is that it is more or less toolchain agnostic. You can do things that aren't even builds with these tracers, and it will accurately trace the files that were accessed and things like that. Yeah, go ahead.
Have you measured how impactful that's going to be?
Oh, it's terrible.
Oh, I think
yeah.
Okay. I mean, you could go for ftrace or something else, right?
Right. Yeah. So I have opinions about how useful this is. Yeah. So that these have really high overhead, right? Like this is gonna, order of magnitudes make your builds order of magnitude slower, and they almost always require elevated privileges, which is. I don't want to type sudo make on the kernel just for personal, preference. So there's that. And they can also lack context. So, not necessarily every file that the compiler opens ends up in a build or actually has something to do with the build, although most of them generally do. So, that is one option, is to do tracing. Another approach is this sandbox approach, and this is basically where you sandbox your build in such a way that you are accurately tracking all of the inputs to the build, and then you can see all of the outputs to the build, and you generate an SBOM from that. So one way of doing this would be if, for example, you did your build in like a container, right? Like you have to manually copy all the inputs to the build into the container. When the build is done, you have to pull out whatever it built. That's just kind of one example of the way of doing that. And that ensures that all of your inputs and outputs are accounted for, unless you have things downloading from the network at build time, which is always a bad thing to do, so don't. This one has a pretty medium overhead. If you can efficiently copy things, it's actually pretty low overhead. And in a lot of ways, you generally, you generally want to do this type of thing anyway, particularly if you're doing like a cross-compile embedded build, which is why this is more or less what Yocto does. And it is also toolchain agnostic. The downside is that you have to actually specify all the stuff you want in the sandbox and also what the outputs are. So if you don't have a good way of specifying that, this can, be very difficult to do in a generic manner. And it also tends to overestimate the inputs, where you might be copying in whole source trees of code that needs to be compiled, but only a fraction of those source code files actually are relevant to the final build. But they're all going to end up in your SBOM. And Also, my examples are by no means complete. These are just the ones I found. I'm sure other people are doing things like this. So, yes.
I'm trying to get my head around the attestation part of all of this.
Yeah.
I come from a different community. Maybe it's just only me in the room. So sorry for that in advance. We have we have in the IETF a RATS working group, which is kind of things like attestation as part of somebody who has some measurements or something, some reference values from which it gets those reference values. And from this build process, I'm trying to relate that attestation part, which you mentioned at least twice. So is the thing that basically what we call as the relying party, the other party which is trying to get this thing, is the case you are making is that now you have that build and that relying party will also have access to all these files and all the processes and all the things that you mentioned, inputs, process, build process, outputs, and it can independently generate from its own sources all of that, and then compare with what it is getting from this SBOM or whatever you call it, like, and then compare with these reference values so as to be sure that the one it is getting from here and the one it computed itself are both matching, and thus I can have the trust in the build process. Is this roughly the idea I'm following correctly, or is it completely
I think that would be a valid use case. You could probably do that. Yeah. So you're saying you want to be able to have a third party reproduce your build and then verify that they got the same thing? Is that
not necessarily
quite?
a third
Okay.
party? Maybe. So let me give you an example. So
First party. Okay. Yeah. Okay.
It's maybe only two parties. Like we do have in RATS like three parties, which is the verifier, relying party, and the tester. But that would be a bit of a detail, which I will not go here. I think, so let's consider two parties. Like if I'm the cloud provider, you send me your code and data to execute, and you as the relying party want me some guarantees from me that whatever I did with all of your code and data that was kept, let's say confidentiality is another part, but here you are talking about integrity, that the build process I used your files as and the inputs you gave me as the cloud provider, I built that correctly and then send out you the outputs, and you want the guarantee that your inputs were the one that I used, your build process you wanted is the one I used, and your and the outputs I give you are the ones which were from your build process and your files. So this is the
Yeah.
two-party case that I am thinking of. Is this matching with what you have or completely off?
I only started looking into attestation like 2 weeks ago. So I would love to talk. I would love to talk to you more about how how we could make this do that.
I would love to do that. Sure.
This is a learning session. Yeah.
Yeah, I do have a couple of talks also in the rest of the week, tomorrow and
Okay.
afterwards. so you're
Yes,
welcome.
I would love to learn how to do that because I would say historically attestation has not been in the forefront in particularly the embedded space, but I think that's going to be a thing that is more and more and more becoming a thing that we're going to need to do. Yes, for secure development practices. So we do need to figure that out. I would really love to be able to figure out a way to do that from our SBOM, so that we don't have to do something different just for that, because that gets to be tedious. Yeah, I don't want. It's the same information, so it'd be nice.
Yeah, I just wanted to quickly add. So we are kind of missing this piece from your side, like the SBOM part. The other part we have done.
Okay.
So it's kind of, I think we complement each other. So we
Yes.
are missing the SBOM part, and you are probably missing the attestation part.
Yes.
So probably we need to talk, and we can
do need
figure
to
out
talk.
things, and that would be great.
Yes, we should talk.
I guess I didn't follow some parts of that, but how much does build reproducibility have to do with your question about attestation?
So the piece that I'm missing in my attestation thing is that how I could be sure that actually the files that I gave to the cloud provider, it did not mess up with some, let's say, reordering of the files. It depends on the use case. So I haven't looked deeply into this, but this is something I think you guys have expertise.
Well, that's why I asked about build reproducibility. If I give you a binary and you want to prove what went into it, you have to be able to just reproduce that, and not everything's reproducible. Like a lot of stuff is not reproducible. Yeah.
In the case of Android, for example, they roll in all the tools into the AOSP to have hermetic builds, and unless you do that with a project, you have no idea what's coming out. Yeah, I mean, you change distro versions or even distro, and that's it. It's completely. Totally, absolutely, yeah.
Well, there's more cores on the build machine, right?
Yeah. Yeah, great. Any other questions?
When are your talks tomorrow? Morning or afternoon?
Yeah, let me know. I will definitely try to get to that.
I mean, you can always generate checksums and sign the checksums and everything, but that's as far as you can go.
Yeah. Yeah. Okay. Oh, yeah.
So these are the two approaches that you...
Nope, there's more.
Oh, there's more?
All
right, just have to let him keep... Okay, go for it.
Okay. There's also the concept of a post-build scan. I would say the majority of SBOM, maybe not the majority anymore, most SBOM tools that you'll see marketed today do this, right? They take your binary, they take your container, they scan it, they try to tell you what's in there. There's certainly nothing wrong with that. I don't think that's a great, I don't think that's ideal for a build time SBOM if you're not actually looking at the build. It is very efficient. It is simple to integrate. It is also, I think it can probably fall down pretty easily with cross-compiling. It's very easy to miss static library dependencies, and it can sometimes be language specific. Is anyone here from Heimdall or ever used Heimdall? No? Okay. You should look at it. It's actually pretty cool. It does a lot more than this. It comes up multiple times. There is another way to do this, which is actually to look at the debug data that's generated when you compile. This is technically a post-build scan, but you look at the debug data and you can trace that back to the inputs that went into it and then generate an SBOM from that. I know this because Yocto does this, and so does Heimdall. This actually works really well in a lot of ways because it can even detect that static library code because the static library files will show up in the debug data. And then you can figure out that that's in there. It is very efficient. It's quick to extract that data. It's not too hard to parse, depending on how difficult you think dwarf data is to parse. I would say this is a definitely unintended use of the debug data. So, there's that. And it's also, it's not very useful for files that don't actually have debug data. And I actually saw there was a comment on here. Sorry, I need to scroll all the way down. Oh, okay. And of course, it depends on your compile options. If you turn off the debug data, you won't get any of this information. So the next way you could do this would be a feature of the tool chain itself. So this would be, for example, either your build system itself, Meson, CMake, whatever you have, tracking this stuff and producing it, or even GCC or Clang itself, spitting out SBOM data. And there are actually some projects that are doing this. Estra is one, and again, Heimdall shows up in there. And so Estra is actually a plugin for GCC that does this. It basically makes GCC write out another ELF segment with all of the inputs and outputs and their hashes that GCC ran. It is pretty cool. This is very accurate and very complete. It's also highly efficient because it's running as part of the compiler process, and the compiler is already opening those files, so checksumming them is not really that much of a deal. However, the disadvantage, of course, is that every tool chain would need to implement this. Heimdall also does this. It does it as a plugin for, I want to say Clang's, I think it might be Clang, C or C and C++. The Heimdall one is interesting because it's language specific. It's specific to the C++ compiler. And I'm not exactly sure why. Yeah, so that's another level that you can do this at. And ideally, again, all of these things would cascade up to your top level SBOM so that you can track it down even to the specific invocations of the compiler that are done. I don't think we need that level today, but it's definitely a goal we should get to, right? We want to get to this point where we know, post-mortem, when the supply chain attack comes in, oh, this version of GCC compiled this source file to this object file, right? That's really the end goal, with these compiler flags. And hopefully that will help with a lot of those things. So did you have something, Kate?
I was just going to say, and we also want to know, is this file actually even in my build, so we get the
Yes.
false positives?
Yeah. That's another thing that I didn't mention in my slides, but I should have, which is a great thing. People really want specifically for CVEs and especially for the kernel, because it has a lot of CVEs. People really want to know, be able to filter down the CVE list of kernel CVEs based on what source files are actually in the kernel. And there's a project that's doing SBOM output for the kernel. I think Maximilian Huber's doing that. Yeah. Yep. I saw his talk this morning on that. And then Yocto also has a different implementation that does something similar. And people really like that because it's always useful to be able to pare down your builds. So that's all my slides. So yeah, go ahead.
Feels to me that this might be a sort of problem that fits really well for eBPF BC. That kind. I mean, you can just sort of just spy on the actual file openings of, group of processes coming from a parent and then just going down and writing all them out.
Does that require special privileges?
Well, eBPF BCC's got all the security stuff that's already worked on for it. So the specifics of it are, but I would presume that if you're able to sort of just get that to run on a system level basis, all this info.
Yeah, I think the tricky part, yeah, that could be. And that's always, so there's kind of multiple levels of this. So one is always want to be able to, you're going to want to be able to build on a system without having to make system level changes to it necessarily. So you always want that option of being able
But
to
there's the whole
generate
point
that.
of eBPF BCC, right? So, I mean,
yeah. But the other thing is, it's also very useful, even if you do have to, even if there's a mechanism that you can use to make change that requires you to make changes to the system, those are really helpful for validating that the other things work properly, right? So, yeah.
The other issue is whether or not you can get that working within a container, for instance. Because
Yeah.
more and more builds are being done in containerized builds.
Yeah, as host isolation. So
right. So host isolation is kind of a deal, and at that point, eBPF is typically off the table. Otherwise, it's a great idea. It's a really interesting idea.
Yeah, I'm always leery of things that require like special kernel permission things just for that reason. Because again, I don't want to type sudo make.
But you don't need to. You can actually apply it to binaries.
Oh, okay.
It's something you can deny or allow per binary.
Okay. So you could have like a trusted tracer binary that you don't have to invoke with sudo.
Exactly.
Okay.
But the problem is it can do other things then at the same time. So anyway.
We can talk. Yeah.
I think it was earlier this year. I noticed there was a Hacker News thread about. So there's somebody named Victor. I think he's Swedish. He's been experimenting with Yocto SBOMs. For cloud. I mean, in embedded, but also eventually cloud purposes. And so this thread got quite a bit of attention, more than most Yocto related threads usually do. And then there was there was a criticism that it was there was somebody, I don't know who it was, but was criticizing the quality of Yocto S-bombs. And I think his claim was that it was the grown-ups in the cloud world, like our S-bombs are like, have all the build time dependencies in there, whereas you can't count on Yocto's S-bombs to have that. Maybe I'm a little off.
Well, yeah.
Okay.
Yeah, I would say like I'd be curious what those criticisms were. I will say the older, when we had SPDX2, because SPDX2 didn't really have a great way of expressing build processes. So we kind of munged it in there a little bit for SPDX2. It's there, but it's like domain specific. So you have to know it's a Yocto S-bomb.
So this wasn't motivated by any of that.
Yeah, okay.
But no, I mean, I'm asking you if like this move towards, this, your focus on build time S-bombs, was it motivated at all by this person's criticism of?
No,
Okay.
no, I don't think I've seen that, but.
So this wouldn't be a plumber's talk if we didn't bring up something like Rust.
Oh,
So
sure.
How does this work? How does this work for systems like with Rust?
Well, I think they have the advantage, I think, and I'm not a Rust expert, so please don't. But they have the advantage that they're I don't want to say closed, but they're a like self-contained
No, for sure,
ecosystem, right?
sure.
And
But-
so
but
they
how do
can
these approaches work?
standardize.
Okay.
So they can standardize a lot of this, right?
it.
They can have cargo spit out an S-bomb at
totally
build time because it's not this open-ended.
So you don't have to
thing.
retrofit it. It can
Yeah.
be built into the system.
Yeah, yeah. Like anything with a package management
the
system like that, I think has a lot of this solved. And Python, I think just recently.
Yeah, Python's
adopted-
starting to spit them out automatically as well. And basically all of the language, the interpreted languages and things like that, most of those have, because they're so popular out there, there's solutions out there, they're evolving.
Yeah.
And going to continue to evolve in terms of fidelity. But the C and C++ and assembly Yocto is probably one of the better solutions out there. And then we'll hopefully kernel S-bomb stuff for the kernel. And Zephyr has their auto S-bomb stuff that's been hooked into CMake. So it's a CMake, so it's a build that way.
Yeah.
But getting the builds are going to be part of it. The other piece that's missing in terms of why builds basically got identified because people were talking S-bombs, some were talking source S-bombs, and some were talking build S-bombs, and the security people cared about what actually made it into the image. The piece that we're probably going to see emerge in the next couple of years after everyone gets their heads around build S-bombs, is what have you actually deployed on your system?
Mm-hmm.
And recording that deployment on a system. You have your built image, what did you actually do? And I think that's a step where we want to be able to refer back to the build S-bomb as well as the configuration information for the deploy.
Yeah.
That's going to come to us, I think, eventually. But right now, just getting ourselves into the builds is going to be the key.
Yep. So anyway, if you work on a build system, think about this. Oh, and yeah, the other thing I was going to say, like, even though all those ecosystem stuffs, they have an easy time generating an S-bomb, right? Which is great. But back to that hierarchy thing, it's important then that, it's very rare that the only thing you're shipping is this one piece, right? It's, generally it's part of a larger system. So you almost always need to be able to layer on that next layer of hierarchy, right? Like, yeah, so that's a thing to keep in mind. Anyone have anything else?
Just hold it still. Hold it still.
All right.
Otherwise the camera moves and people get sick.
Oh, is that?
Yeah, sorry.
I'm telling you this now so people didn't start doing this. But in the next sessions, you can do it.
Yeah. Right. Let's see. Did I get all the? Okay. Yeah. Cool. Let's,
Thank you.
What's that? Sorry?
So, no, I haven't. I'll do the problem solved well. Yeah, but essentially the issue that you're mentioning, right? You can resolve it another way. You can't.
It's a very different
You can just say, okay, I'm gonna permit this container can ask you Damon, to go get this information for me, and could just like start a build.
All the containers are running under Windows or under Mac OS.
Whatever.
Basically, yeah, it's, I know, it's basically. And then
Only works depending whether the underlying operating system.
BCC is a heavy dependency though, because you need, you need LLVM.
There is a formal definition.
To get these. Sure.
Yeah, but it says that
It's not really bad. I mean, LLVM is pretty ubiquitous. I mean, this week's graphics, so things like that.
It's also got a cover, so this
But there may be
comprehensible
guidance that
by
further
humans.
restricts what that is, but that combined with the discussion about.
Not like Gcraft where you need like 3 layers
how
of
it
tool to
should
actually
be
understand.
So just actually really
Means that
fast
when
for
you have
everybody.
an actual completed corresponding.
Was this
that
session
should
useful
be
for everybody?
the SMOS.
Is this something we want to do
The
again next
guidance
year?
may come in differently, but.
Okay.
Yeah,
Next
well,
year?
okay,
I'll look,
tell me
I'll
what
look,
you think.
I will look
Thank
at
you
it
for
and be like.
putting the
Yeah.
I'm sorry, basically you dealt embedded in.
Of course, I know you have, I know you
That's
have.
why.
From the first time I saw you at the pathology meeting back, whatever that was, 20 years, 15 years ago, whatever. Yeah.
No, but that, it's the NTA,
But the part that's really interesting about this and why, like, that is that everything is, like, everything is there. So it's like.
No, I get it, it's just because there's so much there, you can't get the thing out of it. Yes, you need to try to get the thing out of it. Whereas when you come down. That's what the security guy.
I mean, I see the point in that, but we're after different things.
Oh, I know we are.
Yeah.
I know,
But with the
like I
same
said,
ultimate goals.
Oh, definitely, yeah, it was just more along the lines of, I basically.
Use the tooling, this will work. I was still trying to work together.
I came with my family.
That's what it was.
Yeah, well, I'm so glad you gave me an idea. I just saw, if you're gonna have to rework.
But then also,
to the source.
but then I would also say that one, it's not a profit motivated project, so it also would be, and then also on top
No,
of that,
but the
there's actually like 4
manufacturers-
different layers.
But there's so many layers.
In this particular example, so it's.
Oh, yeah, no, like,
Yeah.
no, it was an interesting stuff. I will go look for definitions.
I wasn't sure how.
Take a look.
If you don't need to have solutions.
Right.
No. You're saying, you know, 70% of the cases are this, let me solve this.
I'm not trying to argue that you have wrong, but I'm saying.
That's fine.
It's not a simple problem to solve.
It is not.
Yeah, no, but fundamentally, it's gonna be.
Yeah, so, you need
All
tomorrow.
this, like, you want to sort of everything.
They'll be here like until lunch probably. I just, someone cut it too close.
Right, yeah, no, you don't want it. It's not, you don't have.
It's a wedding, right?
Let me.
Because poor decisions were
This one's
made,
like a
and somebody leaves, you basically take their laptop, it's sort of a network machine and you.
Oh, they are.
So.
This guy's machine.
The golden machine.
This one will, don't touch it.
Exactly.
Thank you so much.
Yeah,
Appreciate
like,
it.
I mean, you're probably aware that. Mike. Very.
Right.
Thank you. Oh, good, no, I totally.
I had.
Catch you later.
Yeah, right? Can we?
Yeah, sure.
Hang out?
Yeah, I really appreciate getting that.
Yeah, totally.
Yeah, I will, definitely. Thanks so much.
Yeah. Well, session, Frank. Yeah, yours too. I'm glad you made it, man. I really, I mean, obviously, you know, we've got Philip and Beyond, so it's like, you know, open embedded is represented, but, you know, the focus was supposed, of this year was supposed to be security, so. Oh, so, I mean, come on, you're the man. S-bombs without security, I mean, no, security without S-bombs. Yeah, it's not a thing. I'm gonna go get my bento box. Right on, Philip. You did it, man.
Yeah.
Oh, before I forget, my wife has something. Make sure. Yeah. It's chocolate. This is from your wife? Yeah, yeah, she was just like, make sure you eat. Well, thank you. Yeah, yeah.
Sugar. There's been a lot of not sweet stuff.
So when I went to OSS in Denver, they gave us chocolate bars.
Thank you.
I'll take a bento box over the chocolate bar.
Too many things. Pieces of paper.
Hey, hey. One of these days we'll solve all the things.
Yeah. I mean, the big value is just random people learning about each other.
Yep. I actually love it when people say, did you know about this thing? You're like, no. How did my Google searches know that? Something that Jan would be right? But, you know, good and that's fine, but his, you know, his work rate dropped and then also other related technology. But, you can take that. Yeah. Well, not really as well, yeah, but I mean, you know, he has a lot of good ideas about how it's. Yeah, exactly. We only had the 10 people I was hoping would be here, so that's good.
Steel page out here.
What's that? Oh, yeah.
The page out of your book here.
Yeah, well, coming back to everybody from the stuff too.
So I think you're skipping the Saturday event. No, based on the review?
Yeah.
Oh, no, the review, I mean, I want to see this one. So apparently it's a chain. Okay. Apparently another one of them was an inspiration for Kill Bill.
Oh, really?
Yeah. This is why you can hang out with the AGL.
Oh, because that's just Scott. He's hang out with Scott.
Yeah,
See here.
yeah. He's there at an AGL thing.
If you want me to show you Tokyo, Scott's our guy. Last time I was here, he and I, the last day that worked on a plane. I saw places I would never see otherwise.
Yeah, there was a camera exhibit.
Right.
Which I'd never heard of until they pointed it out. It's basically, son of Godzilla or something.
It's a Godzilla statue.
Yeah, yeah, I got a picture of that. Yeah.
Not life size though.
Now, the review, there's a very long review of the Saturday night venue. And I think the classic line is, you can't eat architecture. Go to Google, look up the Saturday night venue. Yeah.
What's in this room after lunch? Is the Android one there?
No, Android is on Saturday.
There should be tool chain, remember the wrong room.
Is it this tool chain? Perfect.
Nice to see you.
Thank you. Yes, you do. Oh yeah. Hey, how you been? Good. Well, yeah, we don't travel on the same planes anymore. No, it's I have to say that the LLVM terms which will be in conference. It's amazing. I love the words. Do you need to know what it is?
What's that?
Do you need to know what it is?
No.
So. Yeah, say and ask about how we can add support for everything with us on from the teaching.
Oh. Project that was made in GCC another project that did it for this class. Is the movement called Nation Hall.
There's a homepage for the pull-out. And there's also a Samsung firmware update tool for Windows.
Popular.
That's beautiful.
Because you're trying to generate like which source. Yeah. Track all of the off and then spit out the result. Or it checks on. So it's. Is that so? That is a thing you could do. What is the outcome you have to change? So you're going to do source level attestation for like vulnerabilities.
Yeah, it's on the map.
Yeah, just general, just, yes, all of it. So generating a supply.
Still West Palm.
Still time response. So and you can have, this could be hierarchical, so it could be the high level command user things like me. Yeah. And then that can have sub builds all the way down to the
Specific implications.
yeah, of the compiler. And generally, you want that all integrated into a single final output, even if the intermediate steps are independent. Yeah.
Your argument that Rust basically builds this in and then the Python builds this in.
All the compilers can large the information.
Not for child reference.
Yeah. You want to eventually it all the way down. Yeah.
No, across the browser.
But again, so I'm not familiar with the entire thing. There are instances where it can be useful to say something like, while the kernel has a CVE, the CVE was in this C file. That C file was not a part of the kernel header. It then got used as a user space application. There's nothing to do with the kernel or the kernel CVE. The source level attestation forward should say, my application does not suffer anything related to it, because otherwise, kernel generates kernel headers, generates, of course, library headers generated to the application. And there's like, you were to just taint the binary artifact you generate. Yeah. At a SBOM package level, you're pretty hosed. But if you have source level attestation and build SBOM, you could say, no, none of that applies to me. So therefore, I have to rebuild any information containers to ES.cv should have the kernel and doesn't have any tags.
People are the version of that
Tool chain doesn't need to do that though. Generally, that's done in any long line, like K-Bell. So there's actually talk to some more people. They're adding it'll spit out the source files. But make has. That's only if your build system precisely defines LPC pattern, whereas that might not be the case, then the source resolution can happen like. Doesn't always happen. I think the compiler, to some degree, may be involved. Ideally, you have like a high. Yeah, but are there other use cases other than source level activation? I'm just curious if other use cases. So for the supply chain, I can say this thing got attacked. What do I do? So again, what happens in a supply chain? Like someone swapped out a file during the build, and the compiler compiled a different file.
Oh, so you can actually say this is what's supposed to be a section what was built in.
Yes, exactly.
But if that's not file time, it's just going to say the version that was supposed to be in this is the one that's actually used.
Yes.
How do you know that the file is fed into the file that was intended to use to build the thing?
Right.
Okay, so
But you can just supply chain.
Okay, but the point is that if somebody puts something into your Git repository, you would in other words, you don't know, you assume that the versions that you're compiling are the correct versions.
Let's say someone compromises their build system.
Right.
And swaps out the kernel, the file that where the kernel does a security check on it.
So it's been checked out at Git, and then it's been modified before it's been compiled.
Right.
Okay.
And then they clean up their evidence so you don't see it.
All right. It's totally a thing.
So that's where the compiler like output is something that will be useful as you can see. So that's not the right.
So assuming the compiler itself hasn't also been attacked. Again,
So the compiler is not attacked. The compiler generates source of the and then you take that thing and you go to something like which would be like a public record of what that file should look like for the checkout that you have. And then you attest, did that thing match with the browser side?
But you have to test the compiler first before you do it.
Yeah.
Wait. I mean, the classic attack.
The compiler would have come from, but I guess you're not wrong. But then the question was like, you compile, compromise the traces of the compiler. How did you do that? You gotta compromise it.
Well, if you think about it, that was the original attack, right? Login, change login and then change compiler.
Right, yeah.
So in that lasted for decades until he basically undid it. He basically made sure that it was login was changed so that he could log into any system in the world. Then he changed the compiler to make it the code that did that. When he changed it so that it could recompile itself and add that code even though it was in the source code. So attestation of the compiler was actually hard because the compiler would always add the code that would make all those changes.
So my thing, yeah, so you maybe we can do like certain columns.
Yeah, the third party.
You can detect that like card. So the first time I installed Blue compilation,
it did both. Start with a different compiler.
Yeah.
And
then I just.
You have to assume that at least one of the compilers can be using two compilers in both compilers.
Yeah. Nobody's really stuck. Nobody's stuck up, right? So like mine was really trying to innovate, which is really neutral. But there is all the third party. Yeah.
It's actually always starts.
Yeah, we go back.
That's probably also.
So I remember reading Wolf for change. Went all the way back to GCC Go. So bootstrap GCC Go all the way to Go 1.7. And then that they bootstrap Go. You can slide the proper Go line. And then they got Go line working. And then they're like, and now we have a binary that doesn't produce a file anyone but us. And so we standardize it rather than start from a binary that goes.
No.
But it wasn't like something to it.
And C compiler still potentially.
Yeah.
I mean, there's still a piece there that's.
But the number of layers you would have to survive to go to.
No, the mitigation is extremely high.
Gosh, incredible. Oh, okay. Everything that happened, working on these courses like this. You made
Oh
yeah, that's right. You were there.
You're like, play with this and then I drove it around for a while. It's like, I want to see what happens.
Also, another way to recycle these things. Yeah. Burnable versus non-burnable versus. No, they have a place to put them all. Okay, all right. I'll be right back. But I'd like to know what the strategy to say was the one. So when you, so if you have a distro installer, you can take the doors, ship, sign them together. That's cool. And so that's
You prefer better all of the firmware you need to have the DB updated, which means you might need to update PPX and DBs so that you will get a shift.
All right, I'll do this and try to make
So
somebody else confused.
I'm not really concerned with like
younger folks.
I don't have my firmware. I only have
Somebody
like
is still doing it.
I might have UCI, let's say.
Yeah, that's right.
Or maybe I have my own drug, maybe.
I want to say you can verify.
Yeah.
If that's the case, then you can use as long as you have to get my.
It don't have to be. Because you don't want to.
Oh, yeah.
Yeah.
Yeah, it's just hard. It's hard work to get engaged now where first that's why everyone started.
Okay, so now how do you
Yeah, I would miss it as long as it's something.
Can't I say so? Yeah. Because the nice thing about the way Bluetooth well, you gotta enroll it, yeah, but it's easy, yeah, it's pretty hard to. All you have to do is roll key and then. So yeah, so I agree that way.
And then you look at that to verify. I think it's what it lets you do is take everything that is on the video process.
It's really the very first key.
Are you, and I'm assuming that.
Okay, but in order to like, wow, so you're saying you could have your. You should have your own ILK. That's right.
If they're compromised, they have to statistically highlight different areas. So you produce differences in the initial compilers yeah, that's what I was thinking. Ideally, you build something.
This was actually something that started empty template and just right. Yeah, so with VMs, like with the VM, it's like you have complete control. Which means you can provision your situation any way you want.
Compromise the.
It's a lot harder on real hardware. Right. But yeah, on a VM, you could do it all.
I won't fight the beyond the mechanics of how that works. It'll read the paper.
Yeah.
Yeah, he's still working on the peers back end.
Yeah, he goes, yeah.
Yeah, and then you don't have to get Microsoft to sign it yourself. Okay. Yeah, that's,
that solve is.
I didn't think of that, because no one had the VM example. The only examples I've seen are like, what Bluetooth does. Piggyback off Fedora. I'm guessing people do the same thing, like,
Same GCC.
Piggyback on Debian.
So the question is.
Cool. Are you gonna be at the confidential?
Well,
meeting?
is your question like, what is the default version of C to compile and check? Default version or the compile users?
Or I've done internal pairing for this.
Sorry, no, what I was
GCC internal is
for
going on,
GLC,
but I'm gonna be here.
what version of C are you mandating?
So.
There's big differences, as you know, between C89 and C99.
So, GCC.
Right.
Recently.
Yes.
Changed to C99.
Okay, yeah.
glibc has internally always been running. Here you see a lot of semantics. particularly because CLF is a well-defined.
Trusted one, two, three.
Which we then can use for.
Yeah, so eventually you get into DM therapy. Yes.
But, I mean, GCC.
Yeah, I would.
C++.
So we could scale.
So is
back in March, which is
But
like
largely,
Los Angeles.
yes, recently,
Yeah,
we lived in Fedora.
Right, I think
all
I
the way
went
to
to,
the.
I went
So
to,
everything
I went to the organization.
So you remove a whole.
So that's, so you're, that does, yeah, it's
In like implicit declaration.
Yeah, that was very
Things
interesting.
like that.
Yes.
Which would cause, I mean,
Yes.
cause
So,
defects and then.
I mean, that's leveraging like
But
kernel
runtime
features to do all
Lots
this
of
stuff.
trying to do this years, 1999, even more.
So we would see
And that's still ages ago.
The more interesting.
Well, that is very
that
cool.
we learned for C++, I'm hoping that we should.
So we just.
Ooh, I was hoping 15. Okay, 20's better, that's better. Okay, cool.
But we only.
Not 25, that's not 26 years even.
We only just made for the state.
Yeah.
Yeah. Most of the pieces are there. And so we put
Yeah. Kernels all C11 and all gives,
I'll give you three. So you're the attestation. Yeah.
Which is really good.
You're giving to your friends, colleagues.
And we're implementing right now,
So you're gonna be in missing, you're gonna be in three,
and we're breaking our because C23 ends up, so C23 ends up adding things in user space like temporarily work around. It just defined headers, it created a thing. As soon as you move up to the standards, you can launch stuff like a bunch of stuff, Mesa Bro, right now. So right now, Fedora, if you clone like expect once, once and I'm not sure how we're gonna fix it. Or we're just gonna tell the Chrome guy. Yes, I know.
Always pissed me off. He said, I was starting to get some new. It was your code. I'm sorry.
No, it's not even that, it's just like, they have code, that
I know we have you basically building the.
defines, like, a lot of these applications basically define things early. And they just do it just because they're like, oh, no, we want these things, so we'll eventually catch up, break it, and then they have to go back and write those things. But then you have a life cycle issue, because they haven't made a live release yet, it has those changes, who made a release, so guys make release, want to.
My favorite is, we wanted it to break, so we do it, we have to fix it.
Yes.
Really? No, really, that's totally happens. It's like, we're gonna redefine the thing that is going to exist. It will break when we upgrade, and then we'll know when we fix it. And then, of course, the crux is when it comes time to that.
Yes. I was gonna say the technical debt is too great.
We'll get a little later.
It really makes you appreciate that. It's good and it's bad, but you know, the process. Yeah, there's a place on the far end, you know.
And so you then effectively depend on Intel or how you're going to provide it. They could say,
Some people that are, I think the version of. So basically there's a problem when it comes to upgrades. We have the binary upgrades. Oh shit.
The one is over, right?
Oh, yeah, let's do it.
And then I better upload the slides and everything.
Absolutely, yes, sure.
The Chromebook is working.
Yeah, exactly. It's another 25 minutes, right? Before.
Huh?
Another 25 minutes before it starts, right?
Yeah. No, it's at 3 p.m. that we start.
An hour.
Yeah, well.
It's one of us.
That's an hour,
Yeah.
hour and a half. Yeah.
Still, I better upload the slides here.
Hey, my slides are online.
Yeah, you have to upload the PDFs.
Oh.
Yeah, they go button, they gotta be in this button.
I have to upload them?
No, that's his problem.
No, I do.
He needs help. As long as you've got them uploaded, you should be able to do it. They can add some PDFs or PowerPoint.
Sorry, we wrote the.
Right.
Before we were presenting.
Sorry. Yeah, so the problem is that a lot of people have asked out with, how do you upgrade, although that's somewhat broken in the sense that everyone does things so great tomorrow. One of the major issues that we can still have is that configuration. You do an upgrade, you don't necessarily have configuration. You survive an upgrade, and there's lots of devices where factory defaults or things change. Regardless of the upstream applications and which central bad actor is done for us. These are going to do a major upgrade, they change their configuration like out of the way. So you can't just upgrade without having to rewrite all of your custom configuration stuff. So how do we basically, so people can basically start with a default configuration and then make their own local changes. System E like, right? In such a way that we can basically allow for systems to be able to upgrade with head computer and by default work. But in order to make that work properly, it's not something to be solved by system E or by it's supposed to be solved ideally upstream with help from the system. And so there's a bunch of ideas going forward to see how to make this work with and without system E in a way that allows for applications to have their own configuration language that don't allow for because we're introducing a very certain embedded space for things like CRA and other governmental rules and laws basically are mandating that things not only have to be upgraded in an automatic way, but upgraded and
So yeah, so if you can just,
if that's not too much to ask. So how can basically spread ideas across the ecosystem so basically people do the right thing and definitely support them. Yeah, of course, but things don't make updates only work. So like you need provider updates and you need configuration updates. And there's certain systems that survive upgrades necessarily, that don't. If you upgrade a BIOS on a machine, you're almost always going back to factory defaults. Whereas if you upgrade a switch, for instance, it's going to work because from whatever version, whatever you go to, you can't bring down, the internet effectively. And so those systems have long since, telecom, whatever else, they always upgrade. So the idea of them not being able to upgrade is insane. Nobody would buy their stuff anymore.
because I don't know if that's something
So like a server or a desktop, whatever, if it breaks, you almost expect that to happen. It shouldn't, but you don't want your card up to upgrade. You don't want your plane or your pacemaker or your headset or your phone. Like, that has to always upgrade.
And I don't really want to learn either. Yeah, and what my wife,
Exactly, yeah. This should not be the first thing whenever you mention updates.
My wife said, what are you doing? I say, updates on. Those are terrible. They always break. It's like, that's the wrong. Like, everyone thinks that updates are awful and unstable. That can't be the case.
My wife laughed because I have like a 99%. So I was like
a lot of times
my watch,
I help
my
like
bike,
developers,
the furnace, the coffee machine.
I mean, for me, I've got the last 30 years, I have a 100% upgrade success rate on all the systems I've ever. I have demonstrated I installed and still upgrade.
It's blue.
Hardware underneath and everything else still upgrade.
Yeah.
And
okay. So it's not that funny as it could be.
No.
I don't know why. I don't know why.
I thought you were cheating.
But you are so blue.
That has to be possible.
Yeah, I thought you were just sitting.
Yeah, this
But it struck me when I saw the presentation how red it was. So now when I am
something wrong with your projector.
okay.
Yeah, it looks fine online. So, you know, I had a picture of some keys and a picture. Yeah.
Right. So they're trying to figure out how to.
Yeah, the red is showing blue.
Yeah, they're almost here. It's fine.
Okay, well, we don't care.
Yeah, crazy stuff. I think the thing about these they have, like all the people here are capable and things that allow you to do. Those those capabilities are encoded into the instructions. And yeah, and people, because like it's just green grass, like none of this is set in stone. People are open to crazy.
Oh, well.
What did he say?
Oh, he brought up the design precepts that's gone into CCD. More or less talked about it. It's, well, that's cool. That's fine. I would expect it.
I got two already.
That's really nice.
They got two.
That's
Presents.
So that's the same.
I got two to distribute as I wish among, you know, the speakers. So we are 8 stickers, not only 2 cards.
That's fine. The guy.
Yeah.
It's
It's handmade and everything. But look at it. No, it's not from me, it's from Stephen. Look at the
So that's like one
That's not problem. I don't know, it's card. It's a rifle. I eventually wanted to have one.
My wife spent a year in Japan.
Oh, okay, so she knows.
She studied Japanese for 2 years, and we have
so this way.
I have 2 children, and they love to eat rice, they love to eat tofu. They will gladly take bowls. And I'm here for a month. I read the assignment, so I've been cooking for a month.
But when did you arrive?
Right.
Again, it all works because it's in the cloud.
Oh, okay, but so now you can stay here for like 2 more weeks with your family.
Yeah. Use this. I have an apartment, the apartment's barely furnished.
Oh, we are on one. So we are on the range of the microphone. Just saying. It's right, yeah.
I mean, it's the way we have what I do. It's easier way.
People can hear.
Oh,
Well, you know, there is a way to switch this off. Nah, egal. Let's go outside.
Thank you. Beautiful.
I mean, again, it's important that he is in a place where he can make an impact on solving that problem in minimally
There are like
yes.
enterprise grade HSMs, partners,
Yes.
it can cost thousands and thousands of dollars.
Was it? I mean, that is going to be good to when people are working with this. It's the run of the traditional design part of the class. So.
And this is what we have come to a consensus that like.
the sheet signing. Yeah, so the keys that I was talking about are the keys that are used to sign the kernel images and the kernel modules for security features and stuff. So I don't know if it's the same. So what, I guess the thing that's trying to attest, distributed, lack of a better word, is that the OS image that you're doing, whatever your Linux, your Linux kernel, potentially the bootloader too, if you could sign up.
Yeah. It makes sense. Like when you say OS, it's not never talking about inside the
Think about the confidential test, right? Well, there's a whole thing inside there. So then I'm going to measure all the pieces of the boot chain, whatever.
I don't understand under what circumstances that's going to
So
be.
the only thing
I've seen is
Yeah.
and with the plumbers, then I do it that way.
Yes.
Right. Yeah, I think.
So like it doesn't make sense.
Yeah, we don't organize a code in 5 minutes. Right.
It's still work. I don't.
Yeah, I was.
Yeah. I hear you. After doing it with you and Cupertino, I was like, ooh, that was. I said to Honda, I said, I have everything for you.
Yeah.
Really, I can do.
The thing that I understand, right, is that
But the
LTL solving that problem is too
So
expensive.
to pay Cupertino, I just made an invoice. I made the metro tickets. So the way the CIC works is I have to make an invoice and I have to invoice the CIC. It's just the way, just for the accounting perspective.
That's PGO. That's more of a guided option. That's different.
Expecting donations from the CIC.
No, absolutely. So PGO is.
Pay, when we had it at Prague last, so
The reason why
this year, we had it in Porto, but the year before we had it in Prague.
From guided, you get even better.
So you need to expect a remuneration for the time you spend. And Hansa just pays you, and then it just disappears.
That's the locality part.
But with the CIC now, the only consequence of that is she has to write something, I have to find a way to pay her. And the CIC rules, I can't have volunteers, and I can't have employees, and other things. But if someone invoices, I have to pay them. I should have just written the invoice and showed it to her.
Was he using?
We figured it out a couple years ago, so it's.
There are, but it adds an extra layer of interaction that I think Pedro felt uncomfortable going through to like request. He needed the. And then.
Yeah, well, there's two things. I mean, for the design for the t-shirt and everything, I gave $200 to Estonia. He asked me how much you want, because I cannot submit an invoice because he's an employee. At the moment, he's getting
Using the CPM to take measurements. It's probably PCR. I think it was registered with their values. Their hash also these are hashes. And so for measures like all like there's an expected value. PGO doesn't use it. The register. Like something's been done. So maybe that's closer to how it should be.
Yeah, I don't know. I don't know the check rates.
I know, right?
I'm in different places, it works different.
And then last cauldron is connected to those chocolate.
Okay, well, it's already.
And I was like, this is very Czech. I don't know. You don't remember the chocolate?
I just can't help thinking that the vast majority is probably.
Yes, I'm not sure. Yeah.
Okay. It would have been.
I think I would remember.
So what does you put together a profile, check it in.
Yeah, I think it's.
How have I missed that? I've been in every color like in the last, I don't know.
I don't know if it's the same. I don't know if it's probably architectures and compilers and.
No, it was
2024.
Yeah.
Remember?
Yeah.
Oh, was it during the visit to the seniors?
I don't know. You can.
Shouldn't matter because you're still.
I don't know. Where was that?
Yeah, but the population is still the same.
Okay, are they good?
In theory.
Yeah, are they good? Yeah. No,
They're green.
I've never. I bet they are, but I've never been here. I've never seen. Sure.
You don't remember it? Yeah, so that was on September 15th. It was one of the desserts they had.
Okay, no, I might have chosen another one.
Just made me think when you said everyone has a different way of doing it, there's a check way of doing it.
Right, that's, yeah, well, you never know. Like. But yeah, the CAC. What I said in the meeting the other day, in the office hours, I really mean it.
Oh.
It was always straightforward, yes, smooth.
My goal was to make it possible for the organizers to beat me quickly.
But it was like that.
And that's good.
It was like that. Well, it was. Okay, I get the provider, send me the invoice, I got approval, okay, send me the invoice. All
That's great.
That's how it should be.
It should be that smooth, it should be that easy.
Yeah.
Because I want to encourage more.
So it worked very well.
Yeah. I think if anything, you talk to retail. I was nervous.
Well, I'm used to those because of Boston.
I am not, but, well, so you're well, operational perspective, but not the administrative side.
Well, yeah, of course. Yeah.
So because there were actually some administrative.
Is it weird?
No, it's straightforward, but there are some operational questions like, if someone didn't show up, do you refund this or not? When do you have a ticket refund? Some people didn't come and still charge them for the ticket. We didn't refund it. We're kind of loosey-goosey when it comes to the policy. Unless and until someone shows up and complains.
Well, maybe someone claims for the money, then I guess, but what policy is that?
Just be like the Albert's own policy. Yeah, I know.
So you offer a refund?
For some people just say, oh, I can't come, like.
I know, but that's different. For a no show up?
Yeah, I didn't know anybody knows.
Why would you do that? Like refunding that case, like.
Yeah.
11 seconds versus.
Didn't show up.
Yeah.
Yeah.
But even in cases where people emailed and said, weren't gonna come, we didn't really, I didn't have a clear policy. I could operate in the refund. Oh, you can make it. So fast. In some cases, it was easy. If someone can't come, I refund. And the charge someone else to their wait.
Okay, yeah.
Remember, we had to wait.
We did.
If you find the stuff.
Yeah, Culver's getting big.
It's good.
I think we need 4 days. Andrew was not happy about the idea, but you have 4 tracks or you have 4 days.
I find this is crazy. No, actually,
This. Yeah, but this is way bigger.
I agree. But it's hard in terms of
Take the thing you're gonna do.
But I think we
Like, some of
can,
the EVPF pieces I wanted to see, some of the builder pieces I wanted to see, but.
yeah, well.
Yeah.
But to me, LPC is completely different. Certainly for me, because I go to all the LPCs, but the same I go to the LSFMM and I go to serve. Because I have stuff to do. If I don't have stuff to do here, I will.
In here? It was useful for me because a lot of the Red Hat kernel people come, and talk.
So you got stuff to do here.
And two of my in-vehicle operating systems from Red Hat are here as well. So,
I like flowers. I like flowers. But
you know what I mean? So you're not wrong. If it weren't for the people, I don't have much to present. And like, I tell my wife's like, are you nervous? No, because they organize it. I could talk for an hour about my ass about a pile of different problems that I have. What I need and how to fix it.
yeah.
And if it wasn't going to be about systems, when you see my slide about syscall wrappers, you'll see like how sloppy we are.
Well, in some cases,
Yeah.
My best example is the RT deadline schedule. We added it in 2014 into the kernel, and it is 10 years later that we added the user space interface.
Yeah, well.
Yeah. Why?
Look, when I started with the first micro conference, this year is micro conference because I didn't know how many people would come.
And how is Nick involved?
Not by myself.
I mean, well, I don't, how much organization work is required to run this process? You have to get people together, add them to the list.
Not much. If you know how to do it, it's not much. No, I don't need help for the organization aspect of it. You are already helping by, like, I mean, what I need is teaching people.
Yes.
That's what I need.
I want to say that's where.
But I was not sure how many people will show up because it's Tokyo in December. So then I thought, okay, so because recently we were doing full track. I did not like the idea this year, and so then I was just help me to make a conference for this year. And what do you know? It's always the same shit. 3 days before the deadline, 8 proposals.
Is that what happened?
Huh?
Is that what, I don't know.
Yeah, that's what happened. Last week.
Okay, last week.
It was, yeah, the last week. Actually, I was when we were in
I thought the
Calgary.
deadline was way before this.
No, not last week, the last week before.
Oh, last week before the deadline. Yeah.
When we
Well,
were
that
in-
was me too.
When we were,
Right.
everyone, we were in Calgary, I told this, look, if I don't get anything, I cancel the microconference, because there is no point,
Yeah.
and then I don't go, you know, which is best. Because there is no point in having something if there is no.
Yeah, if people don't.
And then, boom, I got all this stuff.
Yeah.
So. That's why there is only 20 minutes to use per topic. But
It's, what do they say? Our meeting, you make every meeting. Always on time, on
yeah,
point.
I mean, this is a micro conference. This is not supposed to be a presentation. It's not supposed to be like a problem discussion.
Yeah, it's what I
Problem
do.
discussion, right? And but yeah, I really like the micro conferences. I always like it. I think it's the right the micro conference. I think that's especially useful. That's why I wanted to have something similar in Calgary with the kernel. Problem is this year it was like shit because I basically improvised. And that's why I want someone from the kernel side with next
To be involved with run.
to run
Because
to run a kernel. I know some people probably don't like that.
That's fine. Kernel are major users.
So
There are probably enough people to present. I think,
I
that was
think
huge
you run
because
very well.
it's new,
But I
and
mean,
because it's
I
new,
yeah,
you have
so I
to
think
community
you guys see
outcomes,
what's
and you're in office of what they have.
That's why,
C for us stuff.
right, but that's, we have established already for several years, those checkpoints between LPC code. So what we do is that we manage to get the tools and related kernel stuff in a continuous process of review, adaptation, and follow. That has helped.
We make progress.
Like I said, like crazily, the
So,
front is
like,
like,
how
I
many
can't program it,
people
so
go
between, like,
and
heavy
do the
moderating,
work?
so I've just learned to stop.
Check,
Actually,
and
every
this
once
is
in
a
while,
very
I-
nice way of
you can
not
still,
letting anything
like that.
LPC 16 is our he's the number one rule.
Right. The other vendors,
is coming out.
What happened with
We broke the kernel.
Yeah.
It's not like the number one kernel. Yeah. So the kernel. I'm breaking the kernel, we promise. So the kernel is.
That's exactly it. I've been using it for like 30 years.
Like and spec for making it available. So when you find, basically we take GCC 16, we just did it up pre-release, and then we mass rebuild the whole operating system. We have to find all the packages that fail, we mass file bugs in everybody takers. When they get the file bugs, they can then use the GCC system in a public instrument, they put in the new GCC 16, packages that build up, and they see, no, if you're together. Because if it doesn't go from source, then it's
Editors that I
work. That should be enough time for them to prep for.
And I can do it with BI, I can get finding access if necessary,
Still,
but I don't know it.
By the way, I saw the Lua stuff in the LPC spec file.
So I have been confident, so I rely on all the team. It uses some of them have to do those as the stage, but yeah, without like running shell. Why do you learn why do you have to?
Like I said, I find it really fast.
Because we have the Lua, we don't have the Git
I
repository.
think we can tell a lot about operating systems.
It's like some ads. Oh, well, so it reads something. It does some clever.
Exactly.
It's fine, because there are log files out there, like
So are you talking about Git, the new one? So this is, we have a new tool, but it's Lua, it self-generates the spec file.
That's what they're.
Oh, I mean, the spec file has a ton of Lua.
Yeah, but this is the one that.
Patch it
This is the one that
on
the
Git repo,
Yeah.
and it self-generates.
I know, I know.
changelog and.
I know in my camp, I know.
That is Florian.
I knew it, I knew it. I know.
But it generates But if you don't have it, then yeah, that's interesting. If you want to, never thought about
Yeah, right.
I trust Flutter.
Well.
I was serious because anything you're trying to achieve.
Because I know it's Florian and I know that Florian is pure and
I made the case for it.
Yeah.
But if it was anyone else, forget about
His
it.
goal was
I made the
no
case, so I
merge
was,
requests.
people were basically doing some work on it. And, they were starting to redo a bunch of the work that I
And
do.
your tax files.
And so I was basically explaining how this
So
worked.
any
And
merge
I thought, you know, what, iterate the
pull
documents
or
before I leave, because
PI
essentially
in the
they're
subsystem
gonna end up redoing
generates
the work
basically
that I
like
already done anyway.
And
So
so
all I
we
did was,
wanted to be able to operate
I
on
got
as many
ChatGPT
different
to
subsystems
basically
as possible
interview
and
LPC
LPC and
instead of a
RS.
document.
Because we're making a lot
And
of
then I went from there,
changes for
and it's like
text
50
and provide
page document with tons of
Yeah, on the Spark days.
Yeah, you're gonna find a patch kit, this is like it rolled out to every patch.
Oh, I knew it. When I saw
So it's such a good idea though.
well, as long as you continue including the log files, it's fine. Because that's what we do. We regenerate with the log files, you know, and that's it. Because it loses the log files if the repo is not there.
Right, yes.
So it's perfectly okay.
Yes.
Now, it's when we add patches afterwards and everything, we have to patch a little bit the stuff.
Yeah.
Because it has, that the script has some
They're just giving you.
sort of opinionated in surprising ways.
Yes.
It makes some assumptions. Some
I was one of the
assumptions.
internal reviewers for it, yeah. It makes some assumptions, it also makes some opinionated assumptions about your actual pipeline as well. And, like, for example, one of the biggest problems we were worried, so we have a containerized build pipeline. And it's kind of changing in flux and they're like modernizing and doing things. And at one point, the containerized build pipeline, they're like, you don't get access to a readable dist-git repo. You can't make any intermediate readable file because patchkit wants to read the git history and reconstitute the file to save the build. That requires you to have a writer to the record.
I mean, theory, yes.
And have access to a non-shallow clone of the.
Right.
of the
And
And some of the build people didn't want that, but then when we showed them the result, oh, that's pretty nice. And so then they changed the build system for us.
Okay. Your build team is more understanding of my build.
My build team is more understanding. It's already very convincing.
I can imagine.
This is what's called a NIP. It's a mechanical interface where-
So you saw the full news on this from
No, I haven't. What?
The LPC comes
Comes off the bottom.
Yes.
Of course they say,
Yeah.
couldn't say
Fenry
it.
song.
With buds.
Fenry.
With buds. Yeah, it reminds me of the C sharp. You have, they asked for making after a line option experimental, whatever. Who cares?
Yeah, well,
I did.
I did. I did. So, sure.
I was like, you don't know, like, you need to do it all on your own side. And I'm like, what's the point of opening it?
In my opinion, we compiled the frequently asked questions.
There's 55 parts that are made by adding these.
Frequently folded questions about the frame. And we try to actually follow the historical sequence from this move, which has been made just on the fly, you know. And yeah, if you go forward,
Very great.
you realize this is insane.
They're all different, yeah. I just messed around with it like I was working. The original ones I had to actually. That's fantastic. If you look at it. Just enough, yeah. I just messed around with it enough to work. So, but it's worked on 3 different printers.
Oh, I see what you mean. Yeah, it had this little underneath.
Exactly.
Yeah, just like one, they almost.
Yep. That's good. Yeah, it's a bamboo printer. The quality of the print from some of the modern printers is just insane.
So the funny thing is that no, I think you might have just missed it, but during Cyber Monday, like Black Friday weekends, we're like $500 off. Yeah, so they're like about $1,000.
System D, like.
Anyway,
it's like, that's the big.
I mean, it's a really good system. It works well. And, you know, they
Starts all
comes with a whole bunch of it comes with a whole bunch of things like apps, your phone, the tablet camera. It's just also really good ecosystem.
So if six
It's not open source, I'm afraid, but it's based on open source. All the things that are whatever else.
So
Do you have a future video? No.
This goes
They're
against
fun,
like.
but they are a
The Linux
philosophy.
you just do one thing and you do one thing.
Learning how to model.
I have some, just one.
Oh, I got those too.
Everything. So the ones that do.
I've got a festival shaper that I got a little while ago too. I love those.
Yeah.
No, it's one of those huge professional cabinets.
Ooh, that's better than mine.
That's okay.
Yeah, it makes sense.
Yeah. Right, it's built on top of it. But yeah, it's a very thick layer that tries to encompass everything, but I've just decided I'm okay with that, you know, because I'm more excited about my application than I am with. So what I do is in here, and so I've just accepted that. So I'm going to rely on system D to do the problem. The closest thing that happens station I know about, and they're someone using email and everything. That's their primary use case for them, and they're abstracted or still lots. It would not lie away from me, so I don't actually know what to do. No, I have a filter then, I guess, too. And so I organize it and everybody's using it, but then I have a wrapper that integrates it. So I can go into a directory and for a specific label. I would imagine maybe like the Rust, so I could see what.
So you can be a mud without actually mud.
Right. I mean, I have to use mud, but
but yeah.
I like commands. Yeah, I don't do anything other than this.
That's what I'm saying. A lot of people end up doing all their stuff through mud only.
Yeah.
This way it's like both.
Exactly. Yeah, so I can do it by tag, so it messages of operation. I have to print out the key bindings every time because I never did it.
One thing against more different. It is James obviously. The other one was trust. So you're using Opti or local trust.
I really figure out like similar trust. He has a thing that looks like
usual POS authentication. So you would only.
Okay, I get one with the too.
Oh, really?
She's like, you got it.
Yeah.
Okay, well, my
Yeah,
wife's
I
gonna
was
love
trying to
that.
find the alternate spot.
Oh, very nice. Thank you so much. I'm just, this is my It's amazing.
I felt rather lazy.
Andrew was losing it, when he saw that.
Like which Pinsky or?
Yeah.
Okay.
Yeah. As did I, and it was very useful. I hope this looks in that positive experience.
No.
Oh, see? We obviously got to work really well. So this again next year. Big thing is we should do better. This is the third time it's run. Bill and I did it first year, it's like, kind of sort of to beat last year, more or less.
No.
Here you go.
Yes. I did. I uploaded everything.
Oh, yeah.
For
But
once.
for slide changes, how do you do slide changes?
Yeah. You take here, take presenter.
And then you pick, then if you've uploaded them all,
And
you've
then
got them in detail.
they are all there.
Yeah. But what I was wondering is if this thing accepts like a slide changer.
Oh, that thing.
Yeah.
I don't know. This is a Chromebook. Probably not.
Probably. Yeah. Does it have a
Google
USB?
will say, "Oh, you are not authorized."
Is there a USB port? Aren't these USB?
Looks like yes. It's no. Wait. It's no. It's SD.
I can't see that.
Yes, it's USB.
Yeah. It just has the little like port.
Don't break the Chromebook. Huh?
I won't break the Chromebook.
If it detects an unauthorized device.
Really? Will it do that?
I think.
Here, let's see.
Does it work?
Let's see.
Yes, it works.
You bet it works. This is BBB.
No, I mean that thing.
Yeah. It works.
Okay.
No. Okay, so this is added in 2013, 2024. Yeah, okay, you read that. So that was pretty early on. And stuff is just like, wow.
Okay.
It's done.
It's good.
Okay.
Okay, you can switch back to the other one.
So
It works. Do you want me to leave this here for people?
if they want to use it,
Yeah.
that's nice of you.
Default.
Okay.
Yeah, go there. I'll just leave it here, and then people can use it for. There you go. My contribution to your MC.
Huh?
My contribution.
No, your contribution is well, yeah, that's good.
Yeah. And green shows up nicely.
But the various realities that they were area that they're talking about. They also have yes. So you're gonna have
Okay, we should meet later.
really hard to get into.
It would be a guess on the social event.
It's already planned that. Very, very. And probably not submission. Because unless there's something that's highly relevant anyway, it's doing it now, but
it's not
we
going
don't
to
think
Right.
It turned into a little different for me. We'll see what it is. I think Yeah. So it was Richmond and Indiana. My guess.
Yeah.
Maybe we can stay with.
You said, yeah. I thought you doing. Unless I just.
You. Yeah. Well, good. No, no. What I mean is that you like the Stop right there. Everything is red, so it's like blowing. No, it's usually orange.
Yeah. It looks like Jonathan.
I've never watched about that.
Yeah.
It's 8 minutes.
You can
Get up there, touch it up.
put some music.
Oh, I know. Some nice ones. The audience die here. Yeah. I think I'm gonna down this. Top right. Yeah. It was a small room. Weirder shape.
I'm only here to complain.
Join the club.
Hey, Qualcomm bar in Montana yesterday.
Really?
You did not
I
know?
did not. I've been wondering.
I just-
I've been wandering around Tokyo
It just-
looking for fried food and eating fried food instead of.
I know because he was saying yesterday, oh, something's gonna be announced. So, yeah.
Interesting.
He will be working with Jeff, I guess.
Yeah, because Jeff Laza and Tana.
Oh. I'm not sure if this is a good thing or not. For the
I don't know.
All right.
Objectively, I'd love to see just like there be real hardware that we can use.
Yes, they were.
I'm sorry. Maybe it's time to make a step. You can't vote. I just don't think it's wrong. Oh, I mean, yeah, it allows 4 years or whatever. I do. Oh, okay. You can, but I can't, because I don't. Then I would understand. Right. I'm sorry.
What was that? Nick texted me. He said hi, and he's watching the live stream. Nick Sonia? Yeah.
Oh, is he there?
Yeah. You want to talk to him?
Yes. He's not.
He's watching. He zoomed in on my face and sent me a picture of it.
But is he connected to the?
YouTube live stream or something.
It must be the live stream.
Ah, okay. Well, hi, Nick.
He's typing. He's typing. He said go exclamation point.
Okay.
I think he's operating on a delay. A couple of minutes. For us.
Okay, 2 minutes. All right, so let's start. Well, first of all, thank you for coming to the yet another Toolchains micro conference. This year we went down from track to micro conference because we were not sure how many people would actually send stuff. And of course, everyone sent all the submissions like the last week before the deadline, right, of the call for proposals. But so here we are. So we have 8 different activities, and we will be using like 20 minutes for each. So please, let's try to be agile, like in the change. All the slides are uploaded here, so it should be like relatively quick. So the first thing is to thank all the sponsors of the conference, and also to remind all of you that there is a code of conduct in the conference, and it's to be, there is the code of conduct. So let's get at it. So we will start with the security features, as usual.
Awesome, thanks. Hi, I'm Case. Ching and Bill couldn't make it in person, but we've got Justin with us as well, so I'll be covering a bunch of different things throughout the slides. So this is sort of the annual review of security features for the kernel. The kernel uses in the tool chains, and it did not go forward. Why not? Clickety button. Okay, so whoa, these colors are weird. These dark blues are supposed to be red.
Yeah,
That's projector is funny. Anyway, in the things you cannot read. Anyway, this is sort of the matrix I put up every year. This was from 24, talking about a bunch of features and where we are, whether or not we had support, and where some things were pending, etc. I try to go back and forth between 24 and 25. Some stuff I can call out is that finally, after years and years of me begging, the stack protector guard location stuff is now all green, or whatever color that is. And we've made some other changes, and I also dropped a line here and added the pointer counted by attribute, which I'll get to in a moment. So this is mostly just a summary. You can flip back and forth and see them for yourself if you want. And of course, looking at this list, there's GCC and Clang, but we also have to think about Rust as far as getting feature parity across all of them, because we have to deal with cross-language attacks, where if you can, manipulate sort of the state of things from the C side, and then you end up in Rust, you may be in a situation where Rust thinks things are safe and it can do what it wants, but then it starts misbehaving because C sort of overwrote things that Rust would have made impossible. So we have to worry about cross-language attacks. As far as parity with GCC and Clang, we've got the software shadow call stack is done. KCFI is done on the Rust side. There are some small tweaks in other areas that are still ongoing, but the core of it works fine. Some open areas we've got with Rust for hardening is the zeroing call used registers. We just need to have this happening in the Rust side too. That's mostly on the back end, and possibly just flag passing. So if anyone would like to take a look at that, I think it would be fast. Ranstruct, Miguel took a look at this and it was solved, but then both of us forgot about the patch. But anyway, I replied to it yesterday after we chatted, but that's basically ready to go and just works out of the box for the most part. And I wanted to take a look at, we talked about the counted by attribute on the C side last year, and we'll talk more this year. I want to see sort of what kind of interactions we might need to have on the Rust side for that. If we have an annotation on C for a dynamic array, does Rust do the right thing on that side? I assume it does not currently. And then Rust has its own arithmetic overflow handling. So sort of experimenting with that and see what we get when we need to cross boundaries in that regard. How do we deal with that? How do we look at the coming overflow behavior types and how those map to Rust, sort of look at that interaction and see how we go. So I'd mentioned earlier, our last 2 bits for the per thread stack protector guard location landed last year after I think I accidentally nerd sniped Keith into fixing them for PowerPC and RISC-V, I think. Anyway, those are now done, so I can get rid of this slide forever. It's wonderful. As a side note, S390 implemented stack protector, per thread stack protectors. They weren't even on this list, so that's now done also, but I didn't make room for them. Work needed. So the main thing is at the very bottom, this inline hash checking. This is what I've been begging for 8 years, and no one had really stepped up to do the whole project, and I got tired of waiting. So I am now several months into learning GCC internals. I don't have a word for vibe learning, which is using LLMs to read a code base and then tell me about it. But that's sort of how I've been doing my own crash course on GCC internals. But we're now at V9. It seems like I've addressed x86 maintainer review. I've addressed AArch64 maintainer review. Front end and middle end seem to be in good shape, so I'm hoping that this will happen soon, and then I can get rid of this slide as well. Backward edge CFI, again, we've got a lot of hardware details, and we've got the software shadow stack, but it would be nice to have sort of an inline hash checking on the return path, similar to what KCFI does, but on the return side. No one has really spent any time investigating this. So that would be a great place to have some work done in both compilers. So we implemented and reached parity all within the time of 1 year. So I didn't have we weren't at parity presentation at any point, but I just wanted to call out counted by was an annotation for flexible array members. And this has now been extended to pointer members within a structure. So you can specify on an allocation, I have this many, I have a whole array of infos attached to this structure. I have count many of them. Now I can annotate that, and any checking against that, if it's treated like an array, will get managed by the compiler, at runtime. Annotations for this are not quite landing yet in the kernel, just because there is some issue with how we have version skew between when things were implemented and when things got finished. And there's early versions with FAM support, and there's later versions with the pointer support. But then we had questions about whether or not we could use void pointers and whether or not we could put expressions into counted by instead of just member names. So there's been sort of an ongoing discussion about, do we want to wait? Do we want to move compiler version requirement up? Do we want a different macro? So that's sort of an ongoing piece on the Linux side. But in this case, the compiler parts are done. Now it's Linux that is a little bit behind on this one. So this I'll have you come up. This is the one slide that you can talk on.
I've been called up for one slide.
Yeah.
Yeah, I've been working on the Clang side of things. We're trying to get a way to define overflow behavior on a type level. So currently, the best granularity we have is either for your entire translation unit, you can turn off the sanitizers, or maybe on a function scope by scope basis, which is not quite good enough. So we're working on a feature in Clang that's sort of blocked by C++ details right now, but it'll allow you to annotate your types, maybe size T, as an overflow trap type. So if it were to overflow, we could panic immediately. Or you could annotate it as OB wrap if you were really interested maybe in crypto sections of code and in wrapping intentionally. Currently in the kernel, integer overflow, integer truncation stuff is extremely limited, and we're looking to expand support there. Something needed for that are these things called idiom exclusions. A lot of the C code in the kernel follows these patterns like that first one, which is checking for overflow, but in doing so, encounters overflow. So any sanitizer would be very eager to instrument and trap there. So we need to make the compiler aware of these patterns and ignore them. This will boost our signal to noise ratio or reduce it, whatever the good one is. Some other interesting cases is like -1 UL just instantly truncates the second you type that, which isn't very useful, so we can ignore that. Another common pattern that case has some Coccinelle scripts to fix is the while something --. That post decrement is the exit condition on that while loop. It'll always underflow. So yeah, that's what we're working on.
Awesome. Thank you. And yeah, we can talk a lot more about overflow behavior types, but we've got 20 minutes and a bunch of slides. There's a bunch of sort of, I put them in a miscellaneous bucket. Dealing with like nested structures with a flexible array at the end within a structure. This is handled sanely within GCC, but we've still got some open issues in Clang that we still need to clean up. Another piece that got added and supported by both the compilers fully within the cycle of last time I did an update is built-in counted by ref. So the idea is a lot of the tooling in the kernel that was already adapted for the counted by annotations. You wanted to be able to ask this question of like, great, so I have an array or a member or something. What is it that is tracking the count for this array? And this is really handy for the allocators. It's like, I want to allocate this structure plus however many instances of this flexible array at the end. And I've done that allocation, and now where do I write how many I just allocated? Like as trying to make the allocator sort of an atomic unit, so you don't ever exit the allocator without having set your counter. And needing to change the API for your allocator based on whether or not you have a counted by annotation is like a hair-pulling exercise of insanity. So we just added this because the compiler can tell you, yeah, it has an annotation. It's stored over here. You can query the type. You can get at it. So having the allocator be able to actually use that was pretty important. So that got written, and then we're extending it for the pointers case, not just the FAM. And this is very recently just implemented in Clang, and it's like actively in progress for GCC. GCC has a value range tracking internal for compile time analysis of bounds checking. So it can sort of say, oh, I started with the full integer range, and I went through this if statement, which cut that value down to, minus, int min to, 5. And then it like can track what's happening, and it might encounter a place where it says, oh, you're in an array that's only, 3 bytes long, but I see the value range is this huge range. That could be a problem. So there's a whole bunch of warnings, but especially -w array bounds that will trip on this. But walking the path back to how it figured out what the value range was is extraordinarily difficult, and especially true with Linux because of our extensive use of creative macros. So it can be really, really hard. So one of the things that got added for GCC, because it has the value range tracking, is this diagnostic show context, and it'll actually break down on this if with this thing across this shift, we ended up at this result. And so you can actually walk back through it and understand it. And this will help us really split real problems from false positives. And because we've had a lot of cases where we encounter one and then spend a month trying to figure out, oh, it's not actually a false positive. It's just an incredibly complicated thing that GCC was able to see, but couldn't explain very well. And then another piece that got done in Clang, we have GCC plugins in Linux those features were only in the plugin, some of them. And one of them is this kernel stack erasing. So this needs the coverage sanitizers, stack depth tracking with callback to be implemented. So the callback piece was missing in Clang, so that got added. And then GCC doesn't yet have stack depth tracking. So if we got that added, then we could remove that plugin as well, and we'd actually have it natively upstream in GCC. So I'm hoping someone would take that up again, because there was a series to get that done. And then there's the larger umbrella of the work going on in Clang for -F bounds safety, which is a pretty comprehensive way of describing all situations around bounds. So we've got the, like the vectors and bidirectional pointers, where instead of passing just a raw pointer, you're always passing a pointer with its length. Like, how far can I move this pointer in either direction? Whether or not things are null terminated. Like, there's an entire descriptive language around this, and this is slowly making its way into the Clang side. There's work with the C Standards Committee, has had some presentations made by the authors of this. So this is coming and interesting, and we're sort of in the middle of using bits and pieces of it where we can already, because we've been trying to drive the work on counted by, just because we can put that to use immediately without like completely re-engineering the Linux's APIs. And that's it. I have 5 minutes for questions, if that's good. Anyone have anything? Awesome. No questions. It's all done. You have a question? Yeah.
How will you prioritize the next? I mean,
You just say that there is different things that you will like to see done.
Yep.
Let's say next year, but how will you prioritize them?
Prioritization for me is always a funny question, because like with open source projects, there's always like, who is interested in available? If there is someone interested in available, that's the highest priority item. Thanks, I'll take it. But if anyone has the time and wants just a straight priority list, I'd say it's still like KCFI has been an open issue for a long time. So that one sort of bubbled to the top, I think, most recently. So anyone who wants to help with that, I'm still very interested. And then I think looking at the overflow behavior types is another big place, because this is sort of the unsolved gap in C for 50 years, is there wasn't type, you couldn't do per type control of overflow. Like, you couldn't specify what happens. So being able to say this type specifically should trap if it overflows, or this type should specifically wrap, having that descriptive language in C has been missing for decades. So I think that's a pretty high priority. And then I think we've got a lot of little things that, I've sort of scattered out throughout this, of like, oh yeah, we need to finish cleaning this up. We're almost done with this. So there's like a lot of little bits and pieces that I think are still getting finished up. So yeah, that would sort of be my priority list.
Okay. Well, okay. I was going to ask something else.
Okay.
Speaking of KCFI, is there currently some interest from Linux distros in adopting it? Is it Android, or who is going to be the primary user?
Android's had CFI in their kernel for 8 years. So that's all built with Clang. So anyone who's building Linux with Clang has KCFI available. But the distros we've had, Gentoo, a person from Gentoo asked, yesterday, like, oh, good, we want to try this. We've been waiting. So I know that's in there. The performance overhead is so low that once it's actually landed in GCC, I'll probably start my arm waving march to every distro to say, please turn this on, please turn this on. So I'm in talking to distros over the years, there was never we don't want it. It was but we can't switch to Clang. Like that was always the statement. So as far as I know, people are on board for it. And if they're not yet, then I'll go find them and convince them.
That's great. Yeah, we're currently thinking on S390. Do we want to implement it in the compiler or not? But this now depends on whether distros want it.
Okay.
That's the context for the question.
Perfect. Yes.
Thank you.
Please do.
So I think, I mean, I told you, I think yesterday, we discussed it yesterday, but there is some recent discussion like 3 days ago on the C committee on whether we could have attributes or for the saturation overflow behavior, wrapping, trapping. They're also discussing modifiers instead for the type. So yeah, it's going to be interesting, I think.
It will be. It has already been a very long road. Yeah. I think Justin has completely implemented it 5 different ways.
Exactly, and it keeps going and going and going.
But we're close with like the Clang steering committee seems happy. Last time we talked to them.
But there's so many C++.
Just regarding the overflow types and whether they can be qualifiers or not. We've had a lot of C++ problems which aren't relevant here, but that's the main blocker right now. But what is nice is we get a better compatibility with Rust when we have, I think the Rust equivalent is like num wrapping and num whatever, non-wrapping, something like that. And then saturation as well. We can do.
Yeah, in Rust, you essentially have strong types, and then you decide which operation you want for each, for each code, and that's what we want. And we don't want, at least personally, I don't want to see in C, if possible, mixing and rules about promotion. As you said, we agree on this.
Yeah. So the other piece on the overflow behavior types was dealing with all the implicit casting, implicit promotion, all this other stuff where it's a huge mess. And there was a pretty big pushback, well reasoned, from some of the Clang developers looking at why we have to allow that, at least in the first iteration of this. And I went back through like kernel, I went through like last 20, overflow vulnerabilities in the kernel, and I just looked at every single one like, oh yeah, okay, like 90% of them would have been caught even with that weakening of the thing, so there's still a benefit. And then Justin was talking with them in person at the LVM summit, and it was, oh, we should probably lift this out as a strong type where we eliminate implicit operations, implicit casts, as we can specify that for a type, and now that type can't be involved in any implicit operations. So that'll be phase 2. That's like phase 2, right? So
And it's very difficult.
Yeah, the more explicit, the better. At least that's my humble. Yeah. Are you planning to go to present it to the C committee?
Maybe.
Maybe. Let me know. I'm happy to.
I want to get it working. So.
Okay.
Cool. Thank you.
Do you want to throw it?
Hi, thanks for coming. Okay, on the same topic.
Hello. I've been told my title is a bit clickbaity, so sorry if you came for the excitement. I hope it's going to be exciting. I wanted to talk about 2 completely different things, and the only umbrella I found to cover them was that they are exciting and compiler flags. So that's what we have. So for context, I work on kernel security at Google, a different team from Case, but I work on the production servers, blah, blah, blah. So I wanted to talk about SELSAN, also known as selective sanitization, and what I like to call profile-guided sanitization. I think it's a cool idea, so I wanted to share it with you. And then on a completely different topic, I want to talk about heap isolation and how it can help defend against some memory safety exploitation techniques. So let's start with SELSAN. So what is the idea here? I assume you all know about sanitizers. Sanitizers can catch bugs. They can stop bugs from happening or being exploited, which is great. But sometimes they come with a performance cost, which some people might consider prohibitive. So the idea is, what if we only apply sanitizers to the functions that get rarely called? That's kind of the main idea, really. And so yeah, if you collect some sort of profile for your binary, or for example, for the kernel, you can apply some sanitizers, like for example, UB bounds, only to the called paths, and you get a large coverage for a small portion of the cost, which is nice. It's a step up in the right direction, at least. And I have some sort of intuition, which I can't really prove, but I'm going to state it anyway, which is that the cold code, so the code that doesn't get called, sorry for my accent, a lot, is probably less maintained, so it's probably also more bug-ridden and has probably more vulnerabilities. But I can't prove it, so yeah. And also, I don't want to take credits for work I have not done myself. So the things I'm going to present today, I've worked on deploying them at Google, but I've not developed them per se. So I want to credit the authors. So in this case, for example, Vitaly, also from Google, worked on all the LLVM plumbing. So congrats to him. Anyway, so how does that work? There are basically two flags, which I call CELSAN. This is the first one, lower allow check percentile cutoff hot. Simple name. You can you can set a cutoff to your FDO profile, and this will distinguish between the hot code in your FDO profile and the cold code in your FDO profile. And the way you can take advantage of this is through a compiler built-in, this built-in allow runtime check, which at compile time evaluates to 1 or 0, depending on whether the place where you call it is hot or not in your profile. And for example, UBS and bounds already take advantage of that built-in, and it can optimize away all the bound checks from hot code, which you would rather not have if you decide so. And so, yeah, the nice thing is that it integrates with your existing FDO collection pipeline. So if you already do PGO, for example, some sort of profile-guided optimization, maybe you already have some sort of pipeline where you build the kernel once, you run it with some workload, hopefully that is very representative of your production, and then you finish your build with that profile. So you can just reuse all of that, and it will magically work and apply CELSAN. But on the other hand, it's the same issue as with any FDO payload, is that if the workload you use for your FDO collection is not very representative of production, then maybe you will still instrument hot code that you would rather not instrument. So you can actually complement this solution with another flag, simpler this time, fsanitize ignore list. And this flag takes a file, and this file can describe files or functions in your code base that you would like to sanitize or not. And so it's an ignore list. But for example, you can express things like ignore everything, so do not sanitize anything, except the block directory. And if you have this rule, for example, you will only apply array bounds to your block directory. And so you can, for example, leave out certain pieces of your kernel which you consider performance critical, like the scheduler or networking or whatever. And this gives you also extra confidence. If you add it, like the two flags will mask one other. Yeah, you can be confident you will not by mistake accidentally start sanitizing some hot path. So yes, that's basically what I had to share with CELSAN. One more thing I can share is there's no real plumbing in kconfig, but you can provide them with KC flags if you like. It's rather simple stuff. That's all I had to say around CELSAN. And now you can just context switch entirely, a completely different topic. I'm going to talk about heap isolation. So before I talk about heap isolation, I want to give a little bit of context on heap exploitation. So when we look at how attackers exploit kernel vulnerabilities, we find that the vast majority of the time they take advantage of memory safety issues in the heap, which comes up all the time. What those vulnerabilities give them typically is some very small corruption. So they can corrupt some field in a structure that's on the heap, and that's about it. So what I want to do is to escalate this small corruption into a stronger primitive that lets them do stronger things. And usually they have a chain of stronger and stronger primitives that eventually give them maybe an arbitrary write or arbitrary code execution in the kernel or stuff like that. Anyway, the insight is they have some small corruption, and they will try to use it to corrupt some more powerful structures and get a stronger primitive. How do they do that? They use a technique called heap feng shui. And so if you know feng shui, it's about placing things nicely in your room or in your heap. So what attackers do is they cause a lot of k-mallocs or k-frees in certain patterns to lay out the heap memory in such a way that is favorable to their exploitation technique. To be more specific, I'll give you an example. So assume you have a use after free vulnerability in an object. So you have an object that is allocated somewhere, you have a dangling pointer to it, you free it, still have a dangling pointer, so you can still access that freed object, and you can still write there. And let's say you can write at offset 5. Now, what attackers are going to try to do is they're going to try to allocate something in that same location with some juicy, interesting pointer at offset 5, such that they can corrupt that pointer and get something more powerful. Anyway, that's the general idea. It always works sort of like that, or mostly works sort of like that. And the inside here, the idea is if we separate objects on the heap based on certain properties of the allocation, for example, certain properties of the type, we can make heap functory significantly harder. So again, I'm not going to take credit for work I have not done myself. Marco did all the heavy lifting here. Marco implementing all the LLVM plumbing, and he even sent an RFC to the list to make use of that in the kernel. I'm just going to present his work. And she had the excitement, of course. So what Marco built is this concept of allocation token. And it's implemented in Clang, starting from Clang 22. Essentially, what it does is Clang becomes aware of those C allocation idioms. For example, if you do kmalloc size of struct blah, Clang is able to introspect this expression. The first argument to kmalloc is an expression that evaluates at compile time to 10. It's the size of struct blah. But Clang is now smart enough to introspect this expression and figure out, oh, what you're trying to do is allocate a struct blah. And therefore, it can do introspection on type, and it can infer certain properties of the type, and make certain decisions based on that. So that's kind of the plumbing that is in Clang. And the way it's exposed is through this built-in. So again, a new compiler built-in infer alloc token. You give it an expression, like size of struct blah, and it will tell you an allocation token, which is a type hash. So there are different mechanisms for hashing a type, and currently there's only one that is implemented, which is this type hash pointer split. So it has a number of buckets. By default, it's 16, and essentially will guarantee you that the objects that contain pointers will be in certain buckets, and the objects that do not contain pointers will be in the other buckets. So that's the guarantee that Clang will give you, given that isolation scheme. But the plumbing is general enough that it could be extended with better type isolation schemes. And for example, Apple worked on, let's say, stronger proposal for their kernel XNU. It's called kmalloc type, where they have, let's say, smarter or more powerful type hash. Yeah, so that's the plumbing that is in Clang, and what goes with it is the plumbing for the kernel.
Sorry.
Yeah.
How does the compiler identify the allocating functions? By attributes?
So if I remember correctly, kmalloc is implemented as a macro, or in WinDispatchet, it becomes implemented as a macro, and therefore it expands to a call that is like the inner function of kmalloc, size of struct blah, and built-in infer alloc token size of struct blah. And the compiler will, when it evaluates that second argument, the built-in infer alloc token size of struct blah, will replace that statically with the allocation token for the type.
Okay, so basically kmalloc expands to something that calls malloc.
Yeah, basically, yeah.
Okay.
There's this indirection layer.
Oh, sorry.
Ah, yeah.
Should be missing that.
Yeah, okay.
I tried to repeat the question, but it was basically, how is this implemented? That was the question, right?
Yeah.
Okay. So yeah, how does the kernel can take advantage of this? Marco also sent a proposal to the list, this RFC for config typed kmalloc caches. It sort of builds on an existing config random kmalloc caches parallel series. So it's very similar and very simple patch. And so it extends slab, which is the allocator that implements kmalloc K3. And it extends slab to do what I just said, like figure out the allocation token for a type and use it to isolate objects in different slab caches. These slab caches are what I've been calling buckets. I find buckets is a better name, but it's called cache. And so yeah, right now it's hard-coded to 16 caches. I think this is to mirror the existing random k-malloc caches series, but doesn't have to be. It can be made configured. And obviously, the more buckets you add, more caches you add, the more secure, the more isolated your objects will be, but also the less performant, because they will be more spread in memory, maybe have a less efficient memory usage. So. And now a big word of warning. As much as I absolutely love this config and I can't wait to enable it once it's all reviewed and landed, and I can't wait to deploy it. Unfortunately, it is not a solution to anything until we have Slab Virtual, which is a mitigation against cross-cache attack, which is kind of a variant of what I've been talking about, where attackers take advantage of the fact that these slab caches, they can be freed entirely, given back to the page allocator, and then be reused for a different cache. So even if we had very strong type isolation right now, attackers could still take advantage of cross-cache to do exploitation anyway. So we need Slab Virtual, but doesn't remove any merit to this config, and still I can't wait to have it enabled. So that's kind of what I had. I hope I shared some excitement with you. I hope you're all very excited. I see Case is already very excited. So
I am. I think another thing you can say on that last slide is Slab Virtual needs this to be a complete solution as well.
Yeah, maybe I don't see it. Can you expand on it?
So with Slab Virtual, you get the larger cross-cache defenses, but you can still do inter-cache confusion. So we actually need both.
Oh yeah, absolutely.
But it's not complete without having both. So there has been some debate like, oh well, it's not perfect. You need both simultaneously for it to work. It's like no, just get one, and then you get the other. Order doesn't matter. We just need to get to it.
Yeah,
so, yeah,
certainly. Yeah,
it's good. No, this is exciting.
I had a question about the selective sanitization stuff. You don't have to go to the slides. Currently, how you explained it, it's kind of like all or nothing. You set a threshold, and I wonder if you guys have thought about more of a stochastic approach where something's likelihood of being instrumented is directly correlated to how hot it is or how cold it is, the inverse. So if something's cold, it's more likely to be instrumented. If something's hot, you get instrumentation sometimes. I don't know how you would do that. Maybe right before you call it, you make a you have like two instances of it. One's instrumented and one isn't. And then you flip a coin and choose which one to go to, something like that.
I see.
So that you still get instrumentation on hot things occasionally, 1% of the time. I don't know.
So I think there is, so it's even a different stochastic take on this. There is another compiler flag, which I didn't use, which randomly samples your sites and randomly decides at compile time whether they get sanitized or not. But not, it seems that what you're saying is at runtime, you decide whether you will randomly decide at runtime whether to call the sanitize or not function.
Right, and
I think this is, for example, what kfence does, is kind of like that. I think it's great, but addresses a different need from the one I have in mind. Like kfence, in my opinion, is fantastic for finding bugs from your production fleet. It's amazing. But because the probability of hitting kfence is so low, it's unlikely to prevent an attacker from doing anything useful. Whereas with Celsan, you can make the somewhat wacky, weak case that if an attacker finds a vulnerability in your code, it's sanitized away. Yeah, that's just, yeah.
That's it. So how much it got improved by this cell with normal sanitize?
I mean, yeah, I don't really have a number that I can give you in terms of like code coverage. Depends what is your cutoff, of course. Yeah, you have to believe me. It's it's a wide coverage, but obviously less than if you enable the full sanitizer.
Another question is you talk about the representative of this PGO. So have you considered using something called AutoFDO?
Yeah, so I believe the way this plumbing is done in LLVM I have no idea how this works. Is incompatible with Auto-FDO?
Depends how they implement this. I don't know how they implement this. Because PGO counters, they drop only available in the instrumentation pass. After instrumentation, we drop the counter.
Yeah. Also, one concern we had around this idea of using the production data is that the production contains the kernel of yesterday. And so if you're doing a kernel upgrade, maybe the functions have changed. So the function name, like a function that was super hot, is going to get renamed, and then you will consider it to be called in the new.
This
file.
won't happen for PGO, right? PGO always use the.
Yeah, exactly. Yeah. Yeah, it's a trade-off. Yeah. Nothing else? Thank you.
Thank you. Who is next? Okay, so which one is yours? I forgot about it. Distribute. There you go. Okay, thank you very much for coming.
Yeah.
I give you the spotlight.
Okay. Yeah. Hi. My name is Rong Xu. I'm from the Google's compiler optimization team. Today, I'll be talking about the distributed SingLTO build for Linux kernel. So, linker time optimizations, LTO, allows compiler to do the cross-module optimizations to get a better runtime performance. SingLTO is one of the cleanest implementation of LTO, and it's known for strong scalability and good performance. SingLTO has been added to kernel about 5 years ago. So let's see. Okay, SingLTO has a 2 build mode. Here is the diagram shows the workflow of the so-called in-process build mode. So we started with the front-end compile. This is produce the IR and a small summary. Then we call the linker. So the linker, the first is the synlink stage, which link all the IR object and emerge the summary and do a global analysis, then generate something we call the index. So after this step, there's a backend compile stage. So basically, we use the index with the IR, and the linker will call back to compilers to do all the optimizations and generate the native object. Then we call the final link to produce the final binary. So the output is the final binary. All these things, synlink, backend compilation, the final link happens within the linker. The incremental build are managed through the caching. So in the backend compilation, the compiler first check if the files existed in the cache. If it's there, we'll skip the backend compilation. So here's the workflow for the distribute build. Note that the distribute here is to differentiate with the previous build mode. This build mode works well with the distributed system, but it does not require a distributed environment. This mode essentially does the same thing as the in-process build mode, but it exposes the internals of SingLTO. Users manage all the sub-steps, including the synlink, the backend invocation, and the final link. So with this mode, the user will call the compiler directly in the backend compilation and generate the final native object, and the user need to provide the linker command. Thin link and the final link are still in the linker. So why the distributed single tube is preferred? So we think that the in-process single tube is generally preferred, is favored for its simplicity. It is easy to integrate to a standard build system that does not supporting the linker time optimizations. However, it lacks the final object, can be problematic. And also, one more thing is enforce a single set of unified options for all the backend compilations. So for all the backend instance, you can have only one set of the compiler options. So I think, in contrast, the distributed build mode reviews all the final object files, which can be important for tools like a Kpatch and object tool. So with exposed object, Kpatch can easily find the pair of objects to find the difference, and the object tool can work identically to the non-LTO build under this build mode. So in addition, as I said before, the backend compilation can have its own options rather than using the unified ones. This is very helpful in like debugging and the performance tuning. Sometimes we do want to have pass some compiler specific flags to one compilation or set of backend compilations, but we simply cannot do this with the in-process build mode. Least but last is we think that the distributed single tube build mode are better supported and is widely extensively tested. So within Google, this is the predominant build mode for a single LTO. So this is the kernel build workflow. So it works like this. Each subdirectory makefile generate the IR and sync archived to the building.a. So all the subdirectory building.a sync archived to the upper level, and finally we get a building.a in the root directory. And with this building.a and with some libraries, we generate a VM Linux.a. This is also a sync IR, the sync archived IR. So then we invoke the sync LTO linking stage. Then we generate the VM Linux.o. This is relocatable native object. Then we do a final link to generate a VM Linux. So here is the implementation of the distributed build of single LTO. So basically, we add a new configuration called a config clan sing distribute, and we add a makefile for the sing link, and the initial implementation actions, the backend actions are directly generated from makefiles. But the latest approach is co-developed by Masahiro. We used the file list stored in VM Linux.a, and we only call the backend compilations for the files in VM Linux.a that is IR object. But under this mode, we have to utilize the options stored in the front-end compilation. So I test both implementation. The both build performance is about the same. So here are some results of the distributed single-tier build. So single-tier and the distributed produce a different binary. It's not surprising because the option handling are different. So here I list a few options that can generate different binaries. The first is in-process mode turn on the function sections by default and cannot be disabled. And also some O0 and O3 that is specified in the make file are ignored in the backend compilation for in-process build. So the same thing happens for the options if aligned loops equals to 1. So this option just dropped in the in-process compilation. So even we use the same set of options because we can force the options in distributed build. So even use the same set of options, unfortunately, the binary generated by these two builds are still slightly different. This is due to the function order difference. I check a large number of functions. Except the function orders, the binary assembly itself is identical. So here the build performance between the single-tier and between in-process mode and the distribute mode. So basically, if function section is enabled, these two build mode have roughly the same build time. So here's a build breakdown of the distributed build. So we can see the most time are spent in the front-end compilations. Also, the final link if the function section is enabled. So here's a summary. We think the distributed single-tier offers better option handlings compared with in-process mode, and it works well with kernel kbuild. This patch is pending. Like we wish this can be landed in the main kernel, and more people can use this. That's it. Any questions?
Have one at this time. All right. In one of the slides, it's mentioned that the IR remains in vmlinux.a.
Yeah.
Now, I don't know much about kernel builds, but what is vmlinux.a exactly? Is it like an archive with all the objects?
Archived object.
Okay, so this means that all the objects in the archive?
Single-tier in-process build. Yeah, it's archived, archived IR.
Okay. Is the vmlinux.a used for any other purpose? Like in the kernel?
No.
Runtime or anything? No?
No, yeah.
Okay.
vmlinux.o is used.
Yeah, but not .a, not the archive.
Yeah.
So it can contain like compiler-specific stuff, and it's not a problem.
No, yeah. In the distribute mode, we override this IR object with the final object. With yeah.
Question for the build time comprehension. Can you go to that page?
Yeah.
So you can you just disassemble the stage breakdown, the stage breakdown one.
Okay.
What if the in the in-process scenario tier one? What's the do you have data for the stage breakdown?
I don't have that because the thing is for in-process, everything is wrapped in the LLD kernel, LLD linker. So, I mean, if we change the LLD, yeah, we can get this information, but it's not that easy.
Okay. And another question is about previously we got the experiment that the we changed the linker to another one called mode one. A mode doesn't support the linker script, but we can just separate the part apart from the linker script one. So let the mode finish the most time consuming one.
Yeah.
And then we just use LLD to finish another part. Would that be possible to use this kind of linker to accelerate this process?
I think it can definitely accelerate the distribute mode, but it's not that easy for the in-process mode because there's a lot of handling of the single TO part in the in-process mode. I think there's something wrong with the function sections for the LLD. This is the time just does not make sense because I look at the do some analysis. Most of the time is spent in the path called some orphan function handling. I think this is just too much time. Just too much, like 83 seconds. Yeah.
Thank you.
Just because it's like based on kernel build, and this slight tangent to the whole process. At build time to our K build, I'm doing some modifications of the trace point code, and one thing there's compiler folks here, right? I'm just compiler folks here. So I have a hack that basically to convert enums into their actual values to print in the print formats. So otherwise, like when you do a print symbol, I have the enum to what to do, enum to what to do, and the way the trace event macro does it just copies the string of the enum. So I have a hack at boot up that I actually modify. I go through and you could define enum which will now look at the trace event code and then take the print string and actually does a string swap, like it just replaces the enum with name with the actual value, so user space could see that. I want to do that at build time, because right now this actually happens at boot up. And the problem is I try to look at it, and for some reason when I go look at I put it into sections, and when I go look at it in the L file, it will be all zeros, and it's like the values are modified, and it's really hard to find, here's the string, here's the enum, I want to swap it. Even though I can have a string, I'll put it into a section table where I could find it at runtime easily. But looking at the L file, is there like any help? If anyone can help me with this, I could really use some help on how to parse to replace this at build time, because I want to get rid of the boot up version of that. Yeah, well, yeah, maybe I'll have to talk about that, because I tried a bunch of that, and it worked on one architecture, but then I tried doing it on another architecture and it doesn't work at all. So that was just similar to that.
I just want to make sure that I, as a K-build maintainer, understand the implications of distributed versus the in-process. The main focus is moving and getting more visibility into the actual LTO process as part of the build system rather than in the linker. Is that kind of my understanding? And like that's one of the biggest reasons that we would actually want to integrate this, is making it so that we have a little bit more control and visibility into the process and be able to modify it or use it further, or modify it further, or again, just understand it and have access to those objects more than we do now.
So my personal opinion is in-process mode is like, you can think of this as a basic single TO mode. And this in process is can be advanced or expert mode. And there's a usage for the basic mode doesn't work well for the K-build system. I think the distributed, more advanced ones works well with this, because we do a lot of tunings and release bug fix in the compiler for a single LTO. And the distributed, hands down, is the choice. So we never gonna use the in-process mode in production.
And you also mentioned that with the distributed mode that we would be able to, or that F function sections isn't enabled by default. Is that right? I know that there is some handling in the kernel within like the linker scripts and stuff specifically for LTO. So that might be something to check as well, that maybe we could drop some of that if.
As a compiler guy, I'm not suggesting we shouldn't use that. I support to use that. I just point out the difference.
Okay.
The only thing is, I don't like it is it cannot be turned off. As a compiler guy, I would recommend it to turn on the function sections, because you can reorder the functions based on the core affinities. But yeah, it's not this is just not the way this should be, because if you want to disable this, they should have a way to disable that.
Okay, that makes sense.
Thank you very much. Where is it? Oh, it's the first one.
Well, it's probably in order. So everyone knows the drill, well, at least for those of you that know me. Say, I have this thing that you can't make phone calls with, but smile. There's a long story behind that. Anyway, today actually this is actually a first for me. I have 4 slides. So if anyone knows me, that's usually about a half a second. So, but anyway, reason why is because I didn't want to make this wasn't supposed to be a presentation. This is sort of like bring you up to speed, and I want this to be like a discussion. That's why I'm like, I don't want this to be a presentation, but I'll try to go kind of quick over this. Yeah, you're over here too, so good. Come on. So slide 1, no. So I start off with a problem statement, because that's what I think this microconferences are all about. And the font is really small here, so I'm trying to read what I wrote. Basically about lock contention. As everyone knows who does anything with applications, that's usually one of the biggest problems, bless you, with performance and everything else, is especially something that's an issue within the kernel. And we, at the real-time kernel, I'll bring that up first. Well, I'm going to go back a little bit of history here too. So when we first did the real-time kernel, performance on large-scale machines was horrible. And there's times where if you had a 64 CPU machine, boot up time that usually would take maybe 5 minutes would take like 20 minutes when you installed the RT kernel. And it was ridiculously slow. And people would suggest, these heuristics, everyone, lots of people like heuristics. I hated heuristics, where you say, well, we're going, because a lot of times it was lock contention. And the reason why it was slow is the real-time kernel converts spin locks into mutexes. So where in a normal 64 CPU machine, where you hit a spin lock, you'll spin knowing that the owner is on another CPU and it's going to run and release it. So you just sit there and spin. When it releases a lock, you grab it, and it actually could go very well or relatively fast. When we convert that to a mutex, and spin locks are all over the place in the kernel, when you hit a contention, you go to sleep. And a lot of times these spin locks are held for very short periods of times. So you're constantly going to sleep, constantly waking up, and sometimes you get serialized and the system turns out usually 5-minute boot turns into a 20-minute boot. And people like say, well, let's spin for like so many, milliseconds or something like that. And I said, that could be great for one workload, but may not work for another workload. But Susie came in and had a patch series called Adaptive Mutexes. And they said, I'm like, okay, another heuristic. I'm like, well, this is a special heuristic. I'm like, what's that? It says, when you block on one of these sleepable mutexes, instead of going to sleep, you look at the owner. If the owner is currently running on another CPU, don't sleep and just spin. If the owner goes to sleep, then go to sleep. And I was like, that actually makes sense because now it's emulating a spin lock. But the thing is, it's still preemptible. So we don't ruin the preemptibility of the real-time patch. We can still preempt at any time, but now we're just spinning. And guess what? I applied this patch, that 64 CPU machine booted in 5 minutes, the same time it took the non-preempt RT kernel. So I was extremely impressed by this, obviously accepted the patches and took it. And I've always been like saying, this is the greatest thing, since sliced bread. And I always wondered, like, can user space use this? I'll bring it back to when we were in Santa Fe, Linux Plumbers. I sat down with, I can't remember the guy's name. He was like one of the maintainers of Postgres. And he was telling me about user space spin locks that they do. And I'm like, what are you talking about? User space spin locks are like the most horrible thing. One of the main issues from a real-time perspective, and we're always worried about worst case scenarios, real-time user space spin lock doesn't have the control of like the kernel. You can't stop yourself from being preempted. In the kernel, you could spin, you're not going to be preempted, so you're not going to cause weird side effects from spinning. Where in user space, if you're doing a user space spin lock, what happens especially if you're a real-time task and you take a user space spin lock, but you preempted like the owner who was a lower priority task, and if you didn't have priority inheritance, you just deadlocked your application. Your application will never move. So that's why really saying, user space spin locks is horrible. But the guy said, the Postgres guy said, but our benchmarks, prove otherwise. And I'm like, well, don't you have these issues with, as long as you're not running in real time, but you're like, don't you have these issues where you preempt the owner and you're spinning and what happens then? And he goes, yeah, that happens, but once every million times. So we only care, they're not real-time people. Real-time people care about the worst case scenario. So I care about that 1 in a million times. He doesn't. He wants throughput. And database people on your machines, they want throughput. And I was like thinking, well, what about Futex? Now, the Futex problem is you have to enter the kernel. And a lot of these spin locks are held, basically, you grab a spin lock, you modify a variable and unlock. And you're doing this on large-scale machines where there is going to be contention, but you don't ever want to go into the kernel because by the time you do the system call and come out, that shows up into benchmarks. And so, yeah, so like I said, I'll mention here. Let me just go to the next slide. So another thing happened recently is we got a new feature inside Linux kernel called basically need resced lazy or lazy need resced or preempt lazy. What that is if you know of like the preemption modes and everything else, you have non-preemptible kernel, a lot of people use for servers and whatnot, which means that once you enter the kernel, your task will run and no other task will run until you actually exit back to user space. And when you go back to user space, then you'll be scheduled out. Then we have the voluntary preempt, which is lots of little places you'll see might sleep within the kernel. If you hit one of those places, it will say, hey, is need resched set, which means like, another task needs to run. It will call the scheduler at these points. So it's preemption points. Then we have full preemption, which means that if you don't have a spin lock, or if you don't have preemption disabled, if an interrupt goes off, we'll just say, stop the guy where you are and preempt and run. And then we have, real-time preemption, which actually even does spin locks and mutexes and has a lot more other things. There was an issue with one problem with non-preemption that we have, with the server mode, is the fact that you run forever while you're in the system call. But we have some system calls that could last seconds in the kernel. And we have watchdog timers that look for lockups. And if the kernel thread or user space, if you're in the kernel for longer than a certain amount of time, you trigger a warning from the watchdog timer. What they added throughout the kernel, they sprinkled all these things, condition variables, so that within the kernel, you'll say, hey, I know I'm in a non-preemptible kernel, but if you hit this point, we're in a long loop. Like usually like if you're doing a loop of 1,000,000 things, they'll say, hey, every time check to see if need resched's set. If so, call schedule, in a condition bar. Well, Linus blew up about this where someone was starting to add some more stuff. And Linus like, can we just get rid of these damn things? And this is where a lot of talk came up. Some people had some proposals. And then finally, Thomas Gleichner came out and said, you know what? Let's add a new preemption model. And this is where we're hopefully moving soon for very shortly. And what that preemption model is this. If you're in the kernel and a timer tick goes off and you're not a real-time task, it's just a normal scheduling tick. Instead of doing need resched, we enable a new flag called lazy need resched. Lazy need resched will not preempt inside the kernel. When you go back to user space, it will say, oh, lazy need resched is set, and it will preempt you, which is basically simulating normal server tasks. But if another tick happens and lazy need resched is set, it will say, okay, you've been in the kernel for way too long. Let's just schedule you. And it actually turns into a preemptible kernel and you get preempted right there. So it has both the server side and the full preemption, not preempt RT, but full preemption, both there. And if a real-time task wakes up, it will just set need resched, because if need resched will then preempt, it acts like a normal full preemption code. And the reason why we do this is because we've actually done the benchmarks now. A lot of people didn't want full preemption because they said overhead and stuff like that. But over the years, the benchmarks shown that being a full preempt kernel is not much different than a no preempt. So we added this feature. This is when I went, aha, this is an interesting thing. So I said, interesting, we have this lazy preempt. What happens if for user space spin locks? Because I'm still thinking about that talk with Postgres, and you have these user space spin locks. What happens if lazy need resched is set, and you're about to go to user space, and instead of scheduling there, is there a way that user space could say, hey, I'm in a critical section. Don't preempt me if you can't, if it's like, if the timer goes off, don't preempt me if you can. Give me a little extra. And I wrote a proof of concept that was basically less than 100 lines of code. And I added it on top of the lazy preempt. And it uses our restartable sequences. I don't know if you guys are familiar with restartable sequences. It's something that Matthew Desnoyers wrote to, I'm not going to talk about what restartable sequences are, but what it does is it has a shared memory space between user space and the kernel, where user space can set flags that the kernel could read all the time. So there's no system call involved. So I used the restartable sequences memory location to add a flag, or actually it was a counter, that says I'm in a critical section, up the counter. And when the task, or when the task will go back to user space with the lazy need resched set, it would check this counter in restartable sequences, and if it's set, it'll say, you know what, give the user space another tick. So now this will help prevent preemption. This is kind of like the adaptive mutex type of thing. So if you're spinning, you have a user space spin lock, and a timer goes off, it will say, okay, we expect you to run a little bit longer and hopefully release that spin lock real quick so you don't add unneeded contention. And this actually had some benchmarks that showed that this really improved things quite a bit. When I submitted this patch, Peter Zilstra didn't like the fact that it was dependent on the lazy preempt. And we had this whole thing, and finally he had some ideas about not a full tick. It should only be 50 microseconds. And I was like, fine, whatever. And I kind of gave up on it. Someone from our Oracle, was it? It was an Oracle person that I think took over. I think it was an Oracle person that was like worked, because I think that was originally where the condition vars came from. They kind of took over and started doing it, trying to follow, just saying, I'll do whatever Peter Zilstra says. And he started doing this. And then Thomas Gleichner was looking at it, and he didn't really care for and then he looked at restartable sequences code and said, wait a minute, there's a lot of issues with the restartable sequences code here. And Thomas jumped in and basically almost redesigned the restartable sequences from inside the kernel to make this whole mess. And then he said he just took over the entire project. And hopefully, I don't think it's going to be in this I don't know if it's 619 or maybe it's going to be 620 or whatever the next, or 7.0 or whatever it is, kernel. But the extended time slice is now, I think there's an LWN article on this, I believe. The extended time slice is going to go in. So the user space will be able to set this up. So those that are working in glibc and such, I'm letting you guys know, yep, that there's probably going to need an interface somehow where you're going to be able to set a bit or a counter in the restartable sequences for extending this and not get interrupted. Like I said, it's perfect for short spin locks and contention. Now, I think it was last year, was it? Yeah. So Andre over there, last year, okay, so I think it was even maybe before, maybe 2 years ago or whatever, we met in FOSDEM. And you rewrote Futexes, or you had Futex 2. And I, by the way, I have to state the whole thing. Futex 1 was written, and a lot of people had issues with the Futex API, and we're all upset about it. And then, Andre came up and asked, Thomas and Peter and Darren, everybody was saying, hey, I want to extend the Futex code. And they said, no, you need to write a new interface. If you want your feature, rewrite the entire Futex code or Futex API. And he went off and did it. So congratulations. So there's a Futex 2 out there. To get his feature in, he actually did that. He's like, wow, I really got taken advantage of on that one. He won't do that again. But no, he gave his talk at FOSDEM about this. And I went down and said, there's another feature I really love in Futex 2. And it's the adaptive spin lock. And I kind of told him about this, because the thing is, the problem with user space for the adaptive spinning is, how do you know if the owner is still on the run queue? There's really no great, because, the scheduling switch, the sched switch, where you go from, being on the run queue to not being on the run queue, is a very fast path. And there's a lot of, I don't want to add code in there to basically say, there's stuff in the kernel that could easily see, but trying to export that to user space is, very tricky. So the idea was, maybe the Futex code, all anything has to do is you have to pass the owner of, like when you hit contention, you pass the owner down with you when you say I'm blocked. And now once you're in the kernel can now look and say, oh, here's the owner. Is it running? And if so, spin inside the kernel and then come back out. So the idea is, with both the extended time slice with the adaptive spinning, I think we should be able to get rid of user space spin locks completely. By the way, the adaptive, if you look at some of the code, that was the person that was pushing the extended time slice stuff from Oracle or whatever, they did a database stack and it sped, the benchmarks went up by 55%. In fact, yeah, Thomas was like, wait, what?
55.
Yep. Oh, the throw. In fact, that was what I saw on the, am I wrong? That's what I saw on the thing. Yeah, no, he's like, wait, what? It was incredible.
So in 2010, I wrote a version of this. And in 2016, Wayman wrote a version of this. We didn't have the new stuff that you're talking about, but using the same Futex policy that we use for PI, we're able to do what you're saying, to spin on the end. So what, why is it different now? Am I giving it to?
Andre? What, but what's different between, I don't know, wait, so why would it be accepted now, or what was the error? Okay, ask you, what was the problem for, why wasn't it accepted?
You heard the part where I said 2010, right?
So what is it different now? It's 15 years later.
Yeah. Okay.
Seriously. No,
fair enough.
It's something I've been asking about.
And all that. Yeah.
Right. I've been asking about this for a long time. And actually, I think I'm on my last slide. So no, I do have more slides. This is the last slide. But this is more of just a summary. So we still talk. So this is like something we've been talking, I think we talked about. I guess I've been wanting this for the longest time. Well, one of the biggest problems that when I brought this up, because I brought this up with some of the I met some Postgres people afterwards, I messed up and they said, no, you still have the system call. They rather just do the user space spin and never do the system call. Now, here's the thing, the combination of both the restartable sequence, the extended time slice as well. So you only do the adaptive spin if your extended time slice fails. Or basically the addition of both. So the extended time slice is great, but if you also have a little bit longer, now maybe we could do a spin. So the thing is, the point of that's different now is that we have something that you don't go into the kernel immediately, because when the what's it called? Well, you do. Okay. No, the idea is
we could have.
No. There's two things. I'm sorry. The extended time slice means that it's less likely that the owner will go to sleep.
But we could avoid going to sleep before, because if we used the PI policy, you had the TID in the lock.
But no, but you still did system call.
You didn't. Well, you would only do the system. No, you're right.
Yeah.
Yeah.
Yes. Oh. Yeah.
Just from experience back in the 1990s and all the proprietary Unixes, 55% is not unexpected. Tens of percent was pretty common for that. There's a reason why all the proprietary Unixes did something different from this, but you get the effect.
Yeah.
This is actually related to a talk I have later about like enforcing pi by default. So by enforcing pi, one of the issues people are seeing is that performance, and they are asking for unfair locks to be implemented or like be provided in user space, because I think you are kind of implementing some kind of unfairness, and I think that needs to be really generalized. So I would love to see how we can connect these two work streams together, because it's definitely an issue where like the waiter needs to opportunistically hold the lock, because this is very common and it's not outside of, and I come from Android, by the way, so this doesn't have to be a system with a huge number of CPUs and everything. These are common problems like in normal systems as well. It's not just really special to the server market. And the desire for this unfairness is really quite high for performance.
Yeah. So I just want to point out, just so you know the difference here with the two things. RSeq with the extended time slice is for the owner. So the owner is less likely to get preempted and leaving the lock held for a longer time. So it's basically a way of saying, because a lot of the user space bin locks are very short. So the idea is, and also, by the way, when you unlock, there's a way to check the RSeq location if you got the extended time slice, because if you did, you should go to sleep, right? We have a new system call that's called RSeq yield or something. So you hit RSeq yield, basically saying, hey, I've got an extended, any system call will actually work. If you do a system call, it'll schedule right away. But if you get extended, it's expected as soon as you release the lock, you do that. One of the questions that someone came up is like, what happens if you just set this bit? I'm like, am I going to always get the extended time slice? Well, the way EEVDF works is the longer you go beyond your normal slot, you actually lose eligibility to run. So basically you may run longer, but you're going to run less often. So you will still run the same amount of time, even if you try to abuse this. Yes.
Is it time bounded for how long you steal?
So actually, I think it still has the 50 micro. So it's special. If you get the extended, it gives you like 50 microseconds or something like that. So it's still short, but the idea is you're getting free time to release a lock. So this is only for most user space bin locks are very, very short. That's why you do a user space bin lock. Because if it's longer, that means we can do a system call. Wait, let's take is it time?
No, look at
I was also just going to say that I'm excited about the idea of keeping the process in the new Futex interface, because that would allow us to do proxy execution.
Wait, what was that? I can't say.
Being able to do proxy execution on a Futex would be possible if we are able to have the owner.
Yes. Okay. Yeah. So we could pass the owner.
Something that would be really useful for that.
Yeah. So another reason why pass the owner. So I don't know. We have LPC people that will work with Futexes. So this is telling you basically the reason why I'm giving this presentation is basically to try to explain the rationale, what we're doing, and hopefully get help from the toolchain folks on making sure that this gets implemented. Any other question or like?
Do we have callable C wrappers for the
new Futex 2 syscalls. I have a whole talk about that in which I volunteer my time to mentor someone into getting those into place. But I think we talked about this at Tools Cauldron as well. I still need to see like more concrete details about how user space could use this. I mean, we can assume that the spin lock basically is something that the application developer has thought carefully about and chosen specifically because the critical section should be short. In that case, are we saying that for user space spin locks, we would use the restartable sequence registration process to basically put some information in there?
Yeah.
That then the kernel would know
that
the owner is in the spin lock critical section, and at the unlock, we would unlock. Now, I think that's going to be an interesting implementation in user space because
why?
Well, because to make it a restartable sequence, I'm just going to have to like write some of this in assembly. It's going to be some macro logic. It's going to be some compiler goo, but it's work. You're not
Actually,
wrong,
when we
there's nothing
implemented
wrong,
the test cases, we did it in C. I mean,
did you for
yes.
the?
I mean,
For the restartable sequence, how did you get back out of the restartable sequence on the failure case?
No. Okay, you're talking about restartable sequences.
Oh, you just want the registered data in the RSec object.
Yes.
Okay.
This has nothing to do with restartable sequence. We just use the shared memory.
Yeah.
We're abusing the memory that's shared between user. Well, the reason why I was going to do something else, and they said, wait, we already have shared memory between user space and. I mean, Matthew just also mentioned that the rewrites and everything went to 619. So the update.
Okay, so then I'm not actually going to use a restartable sequence.
Correct.
In the
you just
general
use the
sense.
memory. You just use the memory for it.
Okay.
It's just a location there.
Yeah, that's basically it. It's
Where's Matthew?
using the
Oh,
RSec area.
I didn't notice him up there. Hi, Matthew.
So you're using the
I
RSec
think
area
are you
to
mute, or-
communicate between user space and the kernel, but you're not doing a RSec critical section per se. It's just another use of that area.
Yeah.
Yeah, that answers my question, Matthew. Nice to see you.
Anything else? Well, in that case, thank you.
Okay, before the remote people goes away for the break, we have to restart the BBB session. So at some point, this is going to go down. So you will have to re-enter again before we get back from the break, which is in 30 minutes.
It's on another.
Yeah,
So it turns out that they added all these levers. That's the essence of it. On the internet, could no longer send messages and pictures. Everyone, actually, everyone in my part.
How bad was it?
Well, yeah, I mean, it's just called or what? Oh, wait, at least I can see. Yeah. Oh, you just want the system available to you. I thought you want the system like. I thought it was sorry, that was pretty good. Actually, that was the first question. Yeah, I know. Apparently. address is available for any other business.
Yeah, well,
But if this thread gets that address,
right? I was gonna say,
this is the second year in a row, I'm like, the last year was a good track. I wrote here, and yet this thread gets ordered under it, I wrote here. You now have non-causal order in the total global order buffer because the kernel did things behind that. In terms of
Yeah.
creating a block
Okay.
at a VA and giving it to the thread at a different.
And also everybody hates
So, you're right.
No. I don't know. What he happened. I mean, asking. He was attending like.
In this case, it's obvious.
But I don't know. I'm curious.
You should not have handed it as memory that it's not yet been released. So these two threads should go this way. But I think for some of these complex issues, if I were to try to express something in the kernel, I don't know exactly what is a language of the kernel to replay these threads, because it's not just these threads, it's like that thread and a instruction string and a certain number of instructions will stop.
Everybody is.
And then in that instruction string is going to be a syscall. And that syscall might be a M unknown. And then when you switch to the other thread, and it has a M, I guess it would see that address and probably take it, but what if you don't want that? If you don't want
Yeah, right.
Like if you want to emulate the sequence of two things happening at the same time, you might want to give the address for the next
that are.
and so that not only tell the kernel, this is the order I want
Things
to
are moving fast.
you also have to tell it, this is how many instructions the stream I want to send it to, and then you have to tell it for causal future results.
Arm by.
I want to pick which one of these threads in the sequence you're going to give your results. Right? Because otherwise, the next thread that's called mmap is going to get that.
As long as it's not to get
I don't want that. I don't want this thread to get it. Because I want this one to show up just ahead of that one and write something. That's it.
It makes me nervous a little. Oh, look.
There we go.
Carlos. Yeah. Ready, red. Thank you.
Arigato.
Arigato. Even to Indico was the only one. And he sent an email to everyone yesterday.
I saw it. I didn't check to see if yours was up.
No.
You have to re-upload all the slides.
Yeah, but he did actually.
Okay. But you may have to do some more stuff.
So, do you see what I mean by like? So
All the rest of the
this
slides.
is like it's really it's like
Yeah,
DSL.
we have like 3 more activities and we
I
want
think
to.
it'd be great.
I know this morning we had to
The
re-upload
malloc
several
tracer
times.
that we have implemented.
Ah, yeah?
You will have to
Because
restart.
I get that
Well, I got the room warm up already.
So in fact, we trace malloc and then we post-analyze the trace, reorder some events. and fix
But
the
no.
non-causal issues.
I suppose next year we will be back.
Things in a different order than before. And then it
Sure.
Like if you
Unless you're running it by yourself, I'm here, I'll see what I can do.
Yes.
Let me know.
Oh, that would be nice.
Maybe I did obviously good part of it before, so. It sucks. The rest is really, really nice.
Well, but it's not actually the organizational part. The thing is that if I'm by myself.
Yeah.
We could do it. We could build a.
No. What bothers me a lot is that
The only way to do it was we expect is
So then there's that.
drive GB and a test library. Like slowly, because GB has
every year, you know, we will get together and we will speak over video and he and me both. We will go through everything.
If you have ptrace,
When you are by yourself,
the ability to single
you
step
work less.
instruction.
It's true. Because you don't actually
And with Nick, we will look at it, we will send, submit the okay, let's make it more of a discussion. With the by myself, I try to do it too, right? But it doesn't work like that.
When you have a bunch of people talking like that,
But
get
you
somebody.
that will be also.
We need,
Because
we
it's
need
always, you know, Google and.
this call. We need them implemented so that people can subscribe with the right library or something.
Maybe we can.
Oh,
all right.
Yep.
What do you want to help implement? This is a call to action.
I know I'm headed.
Okay, that's fine. I mean, it has been on my to-do list for a long time.
What has been on your to-do list?
I think just called repertoire.
Everything.
Yes.
All of it.
All of it.
I just reviewed Openet 2, and I was just talking to Andre about getting free text weight, free text weight.
But it's good because you, yeah.
Yes. I mean, I have no idea what you're going to talk about, but
Oh, just
I've
20,
been
20 minutes of,
Next year is in plan.
here are some ugly things to make you feel, and then at the end of the talk, you're gonna go, yes, I'll help her. I promise my end of the talk is I promise to shepherd patches through and mentor people. If anybody wants to write code, you'll see, you can write it in. You want to write a rap.
For the first time, it will be like.
So I want to do the infrastructure that gives you.
We have been trying for years.
Machine readable descriptions of.
I don't know.
I'm not even tackling that in this talk, but we can talk about it.
Yeah.
I'm not tackling it because every time we started with that conversation, we've never gotten anywhere. And so therefore I have given up on that and I'm just gonna do like if I did them one at a time. And we just
Sure.
added them.
Thank you,
Because even so. Yeah.
Just stop with it.
Yeah. We'll start with
1 minute to get there.
Yeah.
Yep.
We'll get there.
I don't know if the live.
I think it is now, yeah. It said top recording.
Okay. Nice.
Yeah, no, it's running.
Still a minute.
1 minute.
Yeah. Oh, now.
Now we can start. Welcome, everybody. My name's Carlos O'Donnell. I work on Red Hat Enterprise Linux at Red Hat. I'm an upstream glibc maintainer, and today I want to call to action. I'm asking everybody in the room, let's add C library wrappers for all syscalls, whether you work on Bionic, or whether you work in Muscle, or whether you work in glibc. My call here is really like a wide net being cast about adding C library wrappers for all syscalls. So in the light of this being a micro conference, which is a collaboration between all of us to determine what we should be doing, the question is like, what problem are we trying to solve here? And really what I want to do is make it easy to use kernel functionality exposed via syscalls. I mean, not everything is exposed via syscalls. Some things are exposed in other ways. But for the things in which we have them exposed via syscalls, we should make it easy for people to innovate, people to write libraries, people to use interfaces. I don't list this in my talk explicitly, but I was talking to Andre about futex wait, wake primitives in user space are incredibly useful for implementing library primitives. For example, in libstandard C++, we're calling futex directly. Why? Because there's no wrapper for futex that libstandard C++ can use. And many of the things that you would implement in C++ 20, for example, you want a wake primitive. So today, how do we expose the kernel functionality that I'm saying we should make simpler to expose is we provide libraries. They kind of encapsulate these things. So where the kernel interface is really complicated, you get things like liburing, which has a lot of helpers. And I'll show some examples of liburing. You get libIB verbs. So those of you that are familiar with like networking infrastructure, RDMA and other things, there are ioctyl interfaces that talk very complicated verb-based communication between the kernel and user space. Those aren't things that necessarily we're going to replace. We need those complex libraries, but we can help those developers by making sure that there are C-callable versions of the syscalls that we have to make that easy. And C-callable, I mean lingua franca, like something that's easy for you to do a foreign function interface to, and for the implementation that makes sense. Sometimes people use syscall directly, which is usually provided by your libc, Bionic Muscle or glibc. So the wrinkle there, and the thing that I urge caution with syscall, is that it's not always portable, right? Across architectures, across interfaces. Sometimes your question is like, well, that's a long, right? Like, how does the long parameter, or how does your type get exposed to the kernel? Is that type 0 extended? Is it sign extended? Is it truncated? What does the architecture do from an ABI perspective and a procedure call standard perspective when it's calling, and when you're just calling raw syscall, which is generally a variadic function, and it's taking those types and doing what with them when it passes them to the kernel? So it's not trivial to use syscall. So if I were to challenge people in the audience and say, here's syscall, call all of the kernel functions with syscall and show me what that looks like, and you would soon be like, okay, some things are easy. And then you'd sometimes get to some parameters and be like, well, how do I encode that parameter in the variadic set of arguments that I'd pass to syscall? And things get really hard really quickly. And then you quickly realize, oh, and it varies by architecture too. So it again, all of that just slows down work in user space, where we can be working on libraries and actually solving the problems that we want to solve, which is you've got a workload, or you've got something that you're trying to do. And the last one is like assembly for custom per arch, per syscall calling conventions. That assembly, so some people say like, well, where does that assembly exist? And I'm going to show an example of it. It often exists in language runtimes, where the compiler and the language runtime compile to a single static binary artifact that's usually the program that's being executed. And I'll show an example of that. So yeah.
Maybe I'll add some salt to the wound, is that like even a syscall is not enough. Like skid attribute, for instance, in the kernel, it's really hard to use as it is. And pthread wrappers would be even better to help user change certain aspects of the attribute. But adding NP interfaces as well is a bit of an uphill battle. I'm not sure, like I think there are some concerns how the skid attribute is basically supports backward compatibility. But I think the syscall wrappers is a great step ahead. But I think sometimes for some of the syscalls, they need even extra wrapper around them to be more useful.
So that is a great point. And I think that goes to like kind of the first slide, which is if we don't even have a C-callable interface, then you often can't even mock something up and then say to someone, this doesn't work yet, or you can't mock up a higher level library. You are right that there are, and that is a problem on top of what we have today, which is extensibility of certain syscalls and how extensibility is designed. Like if you look at how StatX handles extensibility versus how you look at sized struct syscalls handle extensibility versus how you look at other things, I am leaving that as like the general open problem for the entire community to look at. How do we make that better? But you're absolutely right that there can be wrappers on top of it, because I would say, so this maybe gets to Futex 2, which is what I was talking about with Andre, which is a simplified wait-wake primitive for user space to use is great, but the original Futex syscall, which is multiplexing, is not that. It is very complicated to use a standard Futex, and the usual illustrative example I give is it took Torvald Riegel 2 years to write the man page for Futex to document all the cases and error conditions that Futex would return by call path for each of the operations that you're multiplexing, so that we could then say, yes, this is a contract we can all agree to, and then write user space code that could assert some of those conditions under which like under which case do these futex operations actually fail or return E again, and you might have to retry them, right? So I agree 100% that I wouldn't want someone to use futex directly as a thing unless you wanted to. But I think one of the things I would want us to like talk about and maybe agree to in this kind of thing is, if it's a kernel syscall and it's part of the kernel ABI and we have a released kernel with it, we should have a wrapper for it, right? And that's just a thing we should aim to do in order to spur work on other parts of the ecosystem. And rather than maybe like judging or saying like we should have a newer interface or have a separate interface, but we should just do that work, and then we should look at how can we improve it and then use it as a stepping stone and move forward. Arnd, do you want to say something?
So your example has the same bug that most of the users of Futex have. I'm not sure if you're getting to that, but
I'm not. And in fact, this is, I believe, this is URCU code. So if there's a bug, submit it to
the same bug that everybody has.
Paul.
The timeout argument has the wrong type because you're using the libc time spec, which is not the same as the kernel time spec.
Yes, and it doesn't translate the types, and 32 versus 64. Yeah. So my point with some of these is that the knowledge and the experience and knowing what not to do is often heavily leaning towards the C library authors that have gone through the hard learning experience of working with the kernel developers to say, okay, yeah, that's a pattern that's broken. And so by having the wrappers, you would avoid these issues. The other one here I have is like, this is not a huge one, but this is like systemd wants to do IO prio, and it wants to do IO prio set and IO prio get. There's no wrappers for them, so it has to do the which and who and the IO prio parameters. So these are two examples of syscalls. This is an example of the assembly one that I was going to say. So this is in Golang. In fact, Golang has the assembly for a six argument syscall, which would be the max 6 argument syscall that you could do. And I mean, the reason that this parse exists is because Golang's compiling Go into a standalone Go program, which is normal. And so it doesn't have in a non-C Go scenario where you don't have a C library and Go is creating the syscalls directly, it's going to use assembly. And so a syscall wrapper exists, but calling syscall would require C Go because you'd need dynamic linkage. And so in some instances, when you're compiling Go, you end up with a statically linked application. Now, there are ways to work around this. I think many C libraries could provide an archive that contains syscall as an assembly piece that you could then link into the final option. But that requires, again, a cross-language kind of agreement between the kernel and the ecosystems that the C libraries would provide us a static stub that language runtimes could use to not make mistakes in these wrappers. I'm not saying there's a mistake here. I'm just saying this is just an example of a case where you've got assembly for the wrapper. How's my time? 10 minutes, good. All right. So this is, it's funny, did you mention the sched set adder, sched get adder? And I had this use case because, we were working in a case where we're looking at testing some of the deadline scheduler pieces. And so when we went to test the deadline scheduler pieces, which had been introduced in 2013, we quickly realized in the glibc team, there were no syscalls for them. We couldn't even write tests for them. And one of the things that we'd even been looking at was like, well, in systemd, when you have a systemd unit file, can you start a process under the deadline scheduler? No, you can't, because there's no user space pieces. And in fact, we found an RFE from 2018 where you wanted to add it to the CPU scheduling policy so systemd could start it. Now, there's a complicated wrinkle there because to enter into the deadline scheduler, you have to be allowed into it. So it resets on fork. But systemd we could still begin the design of a more complex interface where you could have a stub piece of the application that starts with the unit file and finds its way into the deadline scheduler. But again, what I want to call out is just that in 2013, we started doing the work on the syscall and put it in. In 2016, util Linux was using it in CHRT so that you could actually enter sched deadline. 2018, we have this RFE, and it took us to 2024 to come around and say, hey, let's have the wrappers for it to actually enable the back work. what does better look like, right? Like if I ask the if I ask the audience anything here, it's the call to action is like, what does better look like? Are we serving our end users if we aren't providing them the options that they have in the C libraries that we have, or libraries? Like I think in this case, it doesn't have to be a C library. It could at least be a library that provides these things. Now, when you look at the options, it's like I think I am not telling anybody what to do. You can absolutely write your own C library, write your own library for these things. I think liburing is a great example where IOUring needs a bunch of custom functions to help you out and do the right things. It makes total sense to have a liburing, and so that's a great example. But in other cases, like the wait primitives, it makes sense for the futex pieces to likely be in libc. There's some coordination. We have prior experience doing parallelism and concurrency issues there. And so I think there's a pro there that for existing C libraries, Muscle or glibc or Bionic, like they're available in production, they have the existing ABI logic and infrastructure, and they can coordinate with existing functionality. It's not a minimal solution, right? Like if you want something minimal, I think you can go and write it, but we would do better in that step if we could begin adding the wrappers just to the core runtimes. Now, there I want to pause and say that definitely when you're adding to existing C libraries, there is often the complexity of what header does it go into? Do I use the UAPI interfaces? Is there any coordination with existing like ISO-C or other defined standards? And yeah, you might run into a conflict, but likely that's a similar conflict that your end users will run into also, because they'll likely be developing something either in C or they'll be writing it in Rust. And so I do think that we need to think of what's it going to look like in Rust? What would it look like in C++? What would it look like in C? Often we default to C just because it's the simplest from a foreign function interface perspective. It's well understood and can be leveraged. And if we have them there, at least we can begin again writing test cases, examples, and having conversations with the other language runtimes about how to implement them. Like, would we expose them in Python or not? So I'm going to pause briefly here because Arnd raised the question before I started the talk. I said, so if glibc knows about all the kernel syscalls, and here I list some of them. In fact, glibc has auto-generated all the list of syscalls specifically because for a couple of reasons, we want to know which syscalls are present in the most recent kernel so that we know about all the syscalls. Can we create wrappers for all of them? And what I want to pause here briefly was, for many years, we've talked about machine-readable, auto-generated syscall wrappers. And it's kind of been seen as this like holy grail. I remember in like 2014, Santa Fe Linux plumbers talking with Sasha about like, what if we had machine readable? What if we could do that? And in fact, I remember a discussion with other libcs saying, yes, absolutely, we'd be able to consume that. It'd be great, but it becomes such a large problem to tackle, and we haven't been able to tackle it because it actually is quite a bit of work that I think at the very least for those gaps of syscalls where we have identified, like in this case, I think right now I would prioritize futex and futex2 being added at the very least so that we have some wait primitives for parallelism and concurrency in user space. I just finished reviewing OpenAT2 for glibc, so I think some of the like low-level file system syscalls we definitely want to have pieces for. But some of the really weird esoteric ones, we can always just take time later to review those and do them. So Arnd, did you have any questions about auto-generated or machine descriptions for the syscalls?
So I had some ideas of how to do the kernel side. We have macros that wrap the entry points for the syscalls, and those have all the information we want. So one of the ideas that I had was to move all those wrappers from the implementation file into another file that either is used to generate inline stubs in the kernel, or one of those ways, either generate something or have something that gets pre-processed into the actual call inside of the kernel, but then can also get pre-processed. into something we can use from user space.
Yeah. Now, usually with the syscalls, you have an attendant set of declarations, macros, constants, enumerations, things that are part of the header pieces, either in UAPI. But we don't have any way to machine generate those, right? So to some degree, there's always going to be a little bit of manual work beyond the raw syscall wrapper.
Yep.
But that is, I think that's okay. Having the auto generation piece at least makes that process a little bit easier.
So one bit that I started was to get to a point where the internal names in the kernel are unique per calling convention, because we have some system calls that are like different across each architecture, or we have 10 different versions of the calling conventions, and I want to give every one of those a unique name that we can identify, and then have one set of declarations for all of them.
Yeah, and I raised the point here on this slide is like, well, what if the kernel syscall is later specified by SOC or POSIX, right? So like you have a syscall that is like foo, and in fact, I think in the case of the kernel, we have some of the scheduler syscalls are the same name as the POSIX version of the scheduler function for some things, and they do different things.
Well,
right?
even for the basic system calls, we have
Yeah.
somewhere Linux decided, well, the POSIX behavior is stupid. Let's just define
Yes.
our own behavior. And they differ. Like
Yes.
you have a wrapper in glibc that does
Yep.
the POSIX thing, which is not what the kernel does.
Yeah. So, and I guess like this is why I've got this slide up. Like, what should we agree to? Which is, so in 2014, I wrote the work in progress kernel syscall wrapper, which was to say we should absolutely be having wrappers for everything. And so in 2026, I'm going to move it out of work in progress to be like, this should be what we agree to. And that's what I'm going to push for. Now, that means agreeing to just making some of the foot guns, like the really difficult to use interfaces, just be present so that people can layer things on top of them, right, if they need to. And Andre, do you want to say anything about Futex 2? Yeah.
So for the Futex 1, do you think that we should have one syscall wrapper or one syscall wrapper per operation? Because we have the problem of the argument overload as well, right? For compare requeue, one argument is like overloaded. They change the type.
Yeah. So I'm going to be opinionated and say that the C callable wrapper should be as close to the syscall as possible, and that somebody in the audience will then get excited about how terrible the interface is and write a libfutex. And the libfutex will expose futex wait, and those kinds of things. And then if the kernel is new enough, it will, instead of calling Futex 1, call Futex 2 syscalls under the hood. But hopefully by then the C library will also have the Futex 2 syscalls. So then all that library has to do is have a path for a kernel version and then call the right thing.
But the other question about the Futex syscall, if we go that route and have the raw syscall exposed, is what we do about the timespec argument. Like if the timeout argument is not the same type as timespec in glibc, and we have two versions of the Futex syscall, the version 1, we have the time32 and the time64 version on 32-bit architectures. Do we do a wrapper that picks one or the other depending on what the libc does, or do we expose both?
So that's an interesting question. From a libc perspective, it makes sense to be coherent in that if libc is a 32-bit arch compiled with 64-bit time t, that you are doing some translation for the user on the syscall for the time t because it helps. So this is why I said that the syscall could be as close to this user space C wrapper can be as close to the kernel version. And maybe at that point, someone shows up and says, oh, but I wanted the raw version. And then we may have a discussion about, do you want a C callable raw version of this and why? Because I think in many cases for the timeout time specs, you definitely want a coherent view of time across the C callable interfaces. And so you don't want to just pass the kernel interface out.
Absolutely agreed, because that is the part that I still think 70% of the people get wrong. And most of the time, it doesn't even matter, because if you're on little endian and you have a timeout of more than a second, you get the correct behavior by accident. And
Yeah. And are we over time? Has somebody been counting our time for us?
A couple of minutes, but it's fine. We have some buffer.
Okay. And one thing I wanted to make here is like, for example, like the other piece I want to do is when we add these syscalls, not to break existing applications or to work with existing application developers. Like when I looked at liburing, glibc now has memfd create and like statx, but no wrappers for other things. And so I just want to make sure that we don't break stuff. And that it might just be the case that in some of these headers, we end up breaking things if we add the syscalls for them. But that's just going to be long-term work and cleaning things up where people had their own custom wrappers and they need to be cleaned up. So what should we agree to? So in 241, we added sched get adder, sched set adder, because we were adding the deadline scheduler pieces into glibc to make it easy to write deadline scheduler code. In 243, I was just reviewing like we're going to add openat and other things. In what I want to encourage here is in glibc 244, I want to add the syscalls that you want to add to work with me. So I challenged Andre to work with me to get futex wait and futex wait because they're not there, and it would be great if they were. So I am agreeing to review, coach, and mentor syscall wrappers through the process. So it's just an upstream process of learning how to write the wrapper, deciding if the wrapper should be cancelable sometimes because there's actually pthread cancellation. Threads can try to cancel something if there's a long-standing syscall. So there's a couple of steps, plus getting headers that you're either using the UAPI version if the UAPI version is clean enough. So maybe one piece I might need is if the UAPI header is not clean enough, I would love to have a kernel maintainer who'd volunteer to help us shepherd the cleanup of a UAPI header, for example, if we want to get that clean. And so I'm happy to shepherd the glibc piece through. So, and
cleaning what way clean?
So some of the UAPI headers are not namespace clean for ISO-C. So,
Oh, I see. Okay.
Yeah. Like you want an enum for something, or you want a constant for something, you want a macro for something. And so in some cases, they either conflict with existing C definitions. And so you just need to clean them up.
Yeah.
So, okay. Well, thank you, everybody. And I'll talk to Andre later.
Okay, thanks.
Forcing PA logs.
Yeah.
There you go. Thank you.
Thank you. No worries.
If you use a laser pointer on the screen,
Yeah. You can advance your slides. Okay, totally. Okay, that's great. Thank you.
Good point.
Hello, everyone. My name is Kais Youssef. I work with the Pixel kernel, and we want to talk today about more Pi issues. If some of you were on the scheduler micro conference today in the morning, you probably have seen that Pi has come up at least 3 times maybe in the talks. And it's not only a kernel problem. So we want actually like to get Pi to be useful. We want user space to use it. But like this is actually the major issue that we are seeing. Inversion issues are really common across the board. Like we see them I come from Android background, and it's really common. It's not RT specific problem. And it's not really like exclusive to SCHED 5.1 and SCHED RR. SCHED normal inversion is actually real because like these tasks like do care about performance. And we want them to be like when people using logs, we want them to use them the pthread priority inherent by default, which is, to be honest, one aspect of the problem we're having. There is more into it. And I'm hoping today that we can actually like discuss how we can at least share some awareness of the problem, because I'm not sure like how many folks outside of like kernel and like us may be aware of this, and look for some path forward into getting libc to basically help us with like getting Pi to be the default behavior, because this is really important. And outside of libc, actually locks, I did find out, like, which is related to the talk, people don't actually always use like libc directly to implement locks. So there is a lot, especially languages like Java, I'm not sure about Go and other things, but some languages implement their own locks. Actually, some applications as well use this calls directly. Getting awareness to them and like get them to get on board is going to be even more difficult. Pi is usually associated with the blocking calls, but like at least in Binder in Android, which is not always blocking, we need inheritance over there. And at least when I speak with folks who write applications, they tell me condition variables or non-blocking primitives are really nice to get Pi like and done with them, which I have no clue how we can do that, but there is interest into these primitive to describe the dependency and get some performance inheritance be done somehow. And we have done as well like very important aspect, which I think we've touched on during Steve's talk, the speeding up the Futex. So Futex Pi is very slow because of the same issues that Steve was talking about before. And there is an interest of unfair like Pi mutex being implemented, and that's need to be all visible from user space. First, I would like to stress that P, like in my perspective, stands for performance. Like priority is one aspect of the things that you want to inherit, but you need to actually inherit many aspects. That's why in the kernel level, we've been working at the proxy execution. Like you have DVFS where things can be slowed down, big little, task stuck on a little core. There are so many reasons like CFS, throttling, and a lot of aspects of the scheduler that can actually cause performance issues that you need them all to be inherited, including the policy, for instance. Like if something runs as skid idle and like it holds a lock, it will be starved and it will starve everything else waiting for this lock. And we don't have like, priority does not save the day over here. Proxy execution can. But people are not aware of these issues, particularly, like even when they look at their application, and we want them to use Pi by default. So the question is like, how do we get that done? And that comes to the first point. So we know that Apple, for instance, has like for pthread mutex, they have flipped the switch. They actually ship with Pi as a default behavior for all pthread mutexes. We want the same for Linux. So the question is basically, how can we do that? Like my idea is like LPC is the first point of contact, but it's not enough. But it's the easiest thing where you can get a huge number of users on board. But really, it's not limited to that. And like because of the unfair issue, like shipping by default will potentially break a lot of things. So we need some sort of a switch. My idea, and that's really not I'm proposing the right way. I think there are more people expert in that. It's like, how can we do that? Like I'm thinking maybe introducing some environment variable that like at load exec time, we can look and basically decide what's the default behavior. And this will help us basically like ship something that can potentially enforce the default behavior across the C library, but without changing the default one. So, but people have the option to basically flip a switch. The other thing is maybe like it seems to me that like the current Futex API for Pi specifically is not good enough. It needs to improve to somehow to really be better. I'm not sure if we can introduce a new one that will basically take the owner as like as an extra information. So it behaves like the existing Futex, but takes the owner. And maybe we can do something at the kernel level then to flip the switch of the behavior of that new Futex call. I'm not sure, and that's where like I think the first point of discussion that I would like to hear from experts in this field, like what do they see as a problem, potential things to do.
Thank you. So yeah, adding an environment variable. So I can't speak for Muscle or Bionic or other C libraries, but for glibc, we've had tunables for a long time now. And we're using tunables for runtime behavior selection where it doesn't violate a standard. And I think I think Pi would not violate a standard. Or would it?
Potentially, I think I've had some discussion. I think POSIX expect the protocol to be non-Pi by default. So I think it will.
But is that observable? Is it visible from the application's perspective whether or not that is a thing? You know what I mean? Like in some cases, just because you were Pi, it doesn't mean that if you were non-Pi, you couldn't have observed the same thread behavior, the same thread ordering. And so as long as it doesn't break a standard, then we could just add a tunable. And with a tunable, the tunables can be inherited
So, but you get into questions of like whether a set UID processes children from a security perspective is allowed to inherit this, because you now then get into security issues where if a set UID parent spawns a child and continues to enforce pi by default, and yet that causes a security issue, then we're going to have downstream distro security issues around this. But ignoring that piece, but it is a piece we have to think about, we could put a tunable on it.
Okay.
And we are looking at what's called, it's not done yet, but system-wide tunables. Whereas an admin could, for a system or a collection of processes, like for example, in a container, when you start up a container process, say, this is my system-wide tunable settings, and then the C library for every process in the container or for every process on the host would have those same settings enforced. So we could do that. But that then just leads to an experimentation piece, which is getting some of the distros on board to run with pi locking enforced and seeing what comes out of it and gathering information.
Yeah.
Have you tried this
Yeah,
already?
yeah. So like I've been working with Chrome. They have
Okay.
actually flipped the switch, and the first feedback is performance issues. And that's because like the Futex Pi uses RT-Mutex, and RT-Mutex basically will force you to sleep. So maybe I
Okay.
can go a little bit to the last slide.
Yeah, and yeah. Oh, you don't have to go to the next slide. We can keep talking about your other slide.
So that's actually like one of the issues that needs to be fixed, but it doesn't break any standard. But like there are visible performance issues that need to be fixed. But that's part of the experiment, because if other OS basically ship with this, we can ship, but we probably have more work to do. And I'm worried that the life cycle of shipping all these libraries is quite long. If you merge something today, it will probably like be 2 years to see it in most systems.
2 years minimum for sure.
Yeah,
It takes us a year and a half to 2 years.
So like
to see it
having
in
this
production.
tunable will just allow us to decide when it is safe to flip the switch. And for people who wants to help with experiment, or they think they can benefit, they can at least use that switch. And maybe you can flip then the default at some point when you think it's safe, but at least having the switch will enable us basically get the ball rolling into basically getting this pi behavior as the default and iron out all the problems that are actually discovered for whoever tries it.
I agree completely. If we don't enable innovation and experimentation in upstream, what's upstream for, right? Like, so like we can turn this on. So the other nice piece is the ABI contract for us for tunables is at least every major release, we can throw the tunables away.
Yep.
So then if some release we decide that the default is now this, then we just throw the old tunable away and we just ignore it when it shows up again. It is something we could do. I've never tried it. I mean, we could try it.
So the only issues came is this one, and that actually brings us to the other problem, because like probably we need to implement some kind of unfair lock with the pi, which might require kernel changes. And what would you need from the kernel in this aspect to be able to get this unfairness? So what people are seeing is that this fairness, at least the way it's done with the RT-Mutex, and John here maybe can give us more context, but you are forced to sleep, as you can see here, like in the image below with the Futex Pi, you are forced to sleep often. So you always enter the kernel and exit and wake up. But they want this optimistic kind of like spinning, the same way Steve was talking about, where it's unfair, like in a sense that you don't have to go to the kernel to basically release the lock and hold it. You can opportunistically grab it. And that's as well like something that ships with Apple. So I really like the details is above my head to explain them properly, and it's not enough time, but something worth looking at to understand what's needed to get us to the same quality. And is it something you can do completely with existing wrappers, or do we need to think about completely new wrappers? So that's also another open question. But I think, given as well like history with other OS, Pythread Mutex as it is made to be pi by default. So like you get all the benefit automatically for all the applications.
So one of the key pieces for moving work like this forward, though, is identifying the workloads that you care about, because I know so Chrome is interesting. I think that's good. Do you have other workloads on a list of workloads that you care about?
Generally, like in Android, we see this all over the place. But Chrome, because they are really keen on this and they are willing to help and they are willing to experiment more. By the way, if there are any experimental patches. But
we break Chrome all the time.
Basically, it's easy for me to work with them to basically try to identify what are the bottlenecks, because we should either see a benefit or it works, it doesn't work. So apparently, I mean,
Do they have
It works,
custom?
but not because of the performance issues. So there was a big performance regression rather than big performance improvements of using Pi, because they see this inversion quite a lot.
Are they custom? I don't know if they're custom locks in Chrome for.
Mostly
for
not,
this?
but they have
Okay.
mostly not. So like, they use pthread mostly.
Do they
but
care
have
about condition variables?
No, not yet. So this is, I'm not aware for them for the condition variable.
Yeah, it's a wry smile because I think Darren Hart had worked on trying to make condition variables PI aware, because that'd be, and like that's an unsolved problem.
So it's the request doesn't come from them, which is the next like part of the problem is that like languages like Java, because like in Android Java is used a lot. And a lot of the Java languages actually does have synchronization mechanism that are non-block based.
Yeah.
And Java, unlike C, there is no pthread mutex. Like, I mean, even the application wants to be Pi, they cannot do that. The interpreter itself has to convert everything to Pi. And maybe Java is one because of probably Golang and other languages, they have the same problem. So this is actually another problem, which I'm not sure how we can tackle. It has a social aspect, which I think you need to bring awareness to the whole ecosystem to make them aware that locks needs to be Pi by default. Otherwise, there are performance issues, especially as like systems go move forward. But there are technical as well implementations, because from Java at least, knowing the owner is not always easy, which is very important from Futex Pi to basically know the owner of the passing these details. I'm not sure if they need more information over here, but there are definitely like more technicalities to go into outside of LPC, how we can get Pi to be done, and we need more faults from languages. And I don't know if we can wrap it all with LPC, and like from your previous talk, like do they really need to cook their own, use their own syscall directly? Can we give them better wrappers, all these languages to rely on that do the right thing? So at least we know we can communicate with you on how to get things better, and they use you rather than try to convince the whole, try to change everything, which is really hard.
It is hard. I do think that if you start with some core C libraries and you have a implemented solution, that's just code that they can go read and they can look at and they can experiment with and test with. Like, I don't like the best way to convince other language ecosystems is by having at least one language ecosystem start with an implementation that works. And the same with the stuff that Steven's looking at for, enhancing with RSec, bin locks. It's the same thing. I think if we have an implementation and we can share the implementation and we have an implementation that's usable, I think it's a good way forward. But we will need to like go to the OpenJDK team or other teams and say, or the Graal VM team and say like, look, this is what we have in C, because the primitives are going to be the same, the behaviors are going to be the same, and yes, you may not be able to have an ID. That'll just be a new revision possibly of the problem that you'll have to deal with.
Okay. Yeah, we can definitely start with libc, which is my main thing. I wasn't sure if there are enough language faults in this talk, to be honest, but I thought it's important to share that this is actually these locks. People handwrite locks is actually more often than not is actually there, and there is more work to be done. So like, this is to the last point actually, which is like for non-blocking primitives. I don't know, like it seems we need a new syscall, and this is actually a wider discussion. Like we saw the talk before, maybe like that's enough. What's the work we've been done by Steve and like Thomas, but it seems to me that we need to do a bit more to help like the wider use cases. But what is more over here is maybe the feedback we are looking for. If somebody has any experiment working in this area. One idea that I had, which I don't know if it makes sense, like try to introduce in the kernel of the concept of a performance lock, which is not a real lock, but it's just basically something that try to annotate the critical section. It might make implementing these dependencies for blocking and non-blocking a lot easier, like rather than losing like Futex. I mean, instead of having a Futex and Futex Pi, we just have Futex, which takes the owner and have like this other one, like other primitive to denote like a performance critical section where you need to take Pi into account. And maybe in the kernel, then we can do automatically. Like if it's blocking, proxy execution can do it. If it's not blocking, maybe we can just introduce like simple mechanism to boost or do whatever to help like these non-blocking cases to reduce their waiting time if we notice it at the kernel by knowing this annotation. So it's an idea, I'm not sure if it makes sense, but like introducing some kind of a new primitive that handles these is something on the maybe should be on the board. But we'd need more feedback of people who work in this area to let us know what actually works best to help basically get these things done.
So sorry if I missed something, but so basically the Futex PI semantics requires that you go to the kernel even if you take the lock, right?
So it's used RT-mutex, and like whenever you free the lock, you'll have to go to the kernel and wake up the next path, and like you always force like as well like strict ordering of like who wakes up next. So like the idea over here is like if there is a new waiter comes in, if they can grab the lock opportunistically, like they want to grab this lock. So it doesn't have to be like in the strict order like the way the RT-mutex forces it today.
Okay, but isn't that overhead that you observed like is the context suite for calling the syscall, or not really?
Yes, I think so. Like because you'll have to block, you have to enter the kernel and block and wait.
Mm-hmm. Yeah. So
because this is how the RT-mutex work, right?
yeah, and yeah, the good thing about Futex is that you don't need the kernel when you grab the lock, but also this is a bad thing because a lot of people.
Is it true for Pi as well?
Sorry?
Is it true for Pi?
No, for Pi you need to get.
Because that Futex Pi is the only way to enter the kernel for Pi.
Mm-hmm.
And what I was told as well, you don't have like the wider variety of free queue in queue. I don't know, to be honest, like I've never worked with the Futex, but like with the normal Futex, you can do more. With the Futex Pi, you can do less. So you have less like ability or flexibility around the Futex Pi like the Futex. So one of the ideas actually was John is basically maybe if we can make the normal Futex takes the owner, maybe we can implement Pi over there with the proxy execution without having to have a Futex Pi. Which I don't know. Just a suggestion. I don't know if it makes sense.
So just a comment when it comes to tunables. This Pi interface, it would be used underneath by the pthread API, I guess, right? So basically, as a user, in principle, you actually don't care if underneath it uses Futexes or what kind of Futexes it uses. I am a little bit concerned about the tunables because usually or often when you add a new tunable, especially if you want to enable or disable it system-wide, sometimes you have to introduce binary tagging as well. So is that the case here? Like marking some particular programs to actually override the tunable.
So, okay, so taking a step back, there's a question of binding, right? So to what part of the program do you bind a decision, right? And so you can go down a rabbit hole of like, does your tunable, today a tunable binds to the whole process. And so every thread in the process is impacted, the process, all of it itself is impacted. So the question you're asking could be related in that like, well, what if you just wanted it to only apply to a shared library? What if you wanted to only apply to something else?
But even with binary tagging, you can do the shared object. My concern here is that you mentioned that the ABA contracting is that you can get rid of tunables after any major release.
Yep.
But if you use binary tagging, that you cannot get rid of.
But there's no binary tagging today.
Okay,
that's
but that was my
there's no.
Would this particular case actually require tagging executables?
Well, because your question is so. I forget who was the one who went before about the opt-in. Opt-in discussions on features. So the problem with opt-in is how do you opt in? Opt-in is often with binary markup, and so you binary markup either the loadable shared object or the executable itself, and in the binary markup it's present. Now, one way to work around this with system-wide tunables that we had was DJ's initial design says you name a path to the objects. And so rather than storing them in the binary, you write into the system-wide config file, this path has these tunables.
So it is per particular.
Per particular
then.
path. But it's somewhat janky, but it is a solution to, like, here's my system, here's my container, here are paths in the container that are executables that I know are opting in, and you can specify them by paths. And it's basically a top-level config file. So, and then what happens is the dynamic loader, when it starts up, it's able to load that data out of the LDSO cache file and map it in quickly and know this is a thing that's got these parameters and these tunables, and I'm going to set it for that thing. But it's still on a per process basis, a per executable basis. So the whole thing would have to buy in.
Yeah, so the only thing when I tried with this with Bionic, the feedback I got is that, like, because the way I wrote the patch itself, I was trying to change the init path when you init the mutex to change the protocol. It's like statically defined mutexes need to basically change. So maybe this is implementation details, like we have to worry about statically defined, how the protocol is set, hard-coded basically by statically defined code. So it's actually part of the shipped binary. It's like,
yes, but that's just the type, right? So
yeah,
the
exactly. It's implementation detail rather than real. I don't know if it impacts this tunable, but like that's the only tricky part. If it has no impact on the tunable, then I think it should just work.
I mean, it does have an impact because, like, in a statically compiled application, which has static parts of the C program, you're never going to change that. So that we can't care about those.
Yeah, you need to.
So from a given point forward, whether you're statically or dynamically compiled, if you've got the new tunable piece, then you behave as per the new tunable, and your implementation of pthread mutex lock will, for a normal mutex, for whatever value got passed in, whether it was initialized statically by a static initializer or initialized dynamically by pthread mutex, and it's always just going to go the PI path.
Yep.
So today in glibc we have recursive PI, error check PI, normal PI, adaptive PI, and the robust PIs. But I'm looking at the code right now. Yeah, I mean, the suggestion here would be you basically use this path for everything, and the tunable could set that.
Okay, so I'll look at that, to that then.
Yeah, I have no idea how this is going to behave when you do that, though. So
I think having the switch is the first step. Then we need to iron out lots of problems, of course. But I think the first step is at least getting libc. But hopefully we can then show other users how they can get into Pi safely and without any regressions or problems.
Do you care about robust Pi as well, like recoverable?
Nobody has mentioned that to me. So
Okay.
I think not, but I'll ask.
Because also the robust protocol between user space and the kernel is broken.
Yeah. Okay. So I need to look into that then.
Yeah.
Why?
Because, yeah, it's broken. That's a really long conversation, and I can show you the example, but not today. Yeah, it's broken. It needs to be better specified.
All right.
Okay.
Thank you.
Thank you very much.
Wow, we are only 10 minutes late. This is very good. Okay, so the next slot is my little status update about the BPF support in the GNU toolchain. I call it GCC BPF because everyone is doing that, but it's not just GCC. It's GCC and GNUtils and GDB and so on. So this year, this time, I'm not gonna use like the typical text buffer, where I am annotating details, because it's not gonna be detailed. It's gonna be, like just a little status update. And an important question that I have for you, and then to see some different challenges that we are actually facing at this stage. So it will be fast. All right. So first, I wanted to give like some sort of follow-up during the Knutuls Cauldron that was held in September, as every year. We had like a kernel session there and also a BPF session there with several kernel hackers present. And so this is a little summary of what was discussed there and also what has changed since then, because some stuff has changed for good. Well, first of all, during that session, we actually shared with everyone that on the GCC BPF perspective, when we started this project, it was what, like 5 years ago already, or even 6 years ago, long time ago. Basically, we have been struggling for several years towards one particular goal, which was to get on par with Clang in terms of BPF support and to make it possible for people to use GCC instead, practically. And it's taken us a long time to reach that point. But finally, I think it was last year, for the first time, we managed to compile all the kernel self-tests, which, by the way, they are not compiling today, but more about that later. And in fact, there are several projects out there and several distros which are using GCC to build BPF programs instead of Clang. So that initial goal, it has been reached successfully after a long time. So basically now we are aspiring to something else, which is not only to make it possible to use GCC instead of Clang to build BPF programs, but to make GCC the primary compiler for BPF. And the reason why we want to do this is because we really believe that GCC is a good compiler for BPF. So yeah, there is that. All right, so during the Cauldron, basically, we talked about the BPF declaration and type tags, how not, and I am glad to tell you that since then, it's been applied upstream in GCC, thanks to the tireless work of David Faust. Finally, after I think 2 years of repeated patch series and a lot of discussion and a lot of changes in the door format, also with John Hong and with other people on the kernel side, we managed to get the stuff upstream in GCC. So we hope that the kernel will make good use of it after so much insistence. Then also, we basically told during the Cauldron about a new test suite that is coming to GCC, where so the test suite in GCC obviously is mostly about the semantics of the compiled code, right? I mean, to make sure that you are not generated code that doesn't match the semantics of the source file. However, when it comes to BPF, there is a new dimension there, which is that you don't only have to generate code which is semantically correct, but also you have to generate code that will be likely verified successfully by the kernel verifier. Because if it is not, then the resulting code is basically useless. So fortunately, Piyush Raj worked during the Google Summer of Code this year, and he built infrastructure in GCC, so we can have a normal GCC test suite using this usual infrastructure, but that invokes the kernel verifier, invokes the kernel in order to actually tell the GCC test suite infrastructure whether the program could be verified or not, and also to run it. The stuff is working. It is still to be installed upstream, but I want to install it before GCC 16. That will be out like beginning of next year or around May or so. So this is good news because this will allow us to detect regressions, because any change in the compiler can break the BPF, right? Even if it's not directly related to it. Also, during the session, we talked about the -O verifiable that got changed to -F verifiable. We discussed a little bit about that. Also, we got curious about a tool which is called SMT-GCC. That the purpose of this tool is to actually detect bugs in the compiler in GCC. And the way it does that is, it's like magic. It's very impressive, that program. The way it does that is that it compares the IR that is get by an optimization pass with the resulting IR after the optimization pass. And then it checks that the semantics are not different. So we actually got curious and we thought, okay, could this tool be actually adapted to make the compiler, to actually cover the verifiability of the code as well, right? Because it's checking for semantics. Well, it turns out that the answer was no by the author of the tool. So it cannot be used for that for several reasons. However, this was motivating enough for him to port SMT-GCC to the BPF backend in GCC. And this basically found several bugs in the backend. So it was useful. It was good. Also, we talked about improving several core built-ins. Andrew Pinsky, who is a first-line GCC hacker, he has some suggestions on how to improve the interface of the built-ins. Obviously, no, in their current incarnation, we will need to add additional built-ins, but there is room for improvement there. And also, Alexei talked in the event about an idea about perhaps generalizing core attributes out of the BPF world. So we did all that, and as you can see, there is some updates on it, all of them positive. Stuff is getting upstream. But I wanted just to show, to share this with you. All right, so after this, and very quickly, what are we up to? As we, I mean the few people who are working on the BPF port. So basically, you can see there all the different bacillas, the different PR that we are trying to get fixed right now. It covered there is one for the assembler, which is the make goto. The make goto, I think you don't absolutely need it in the assembler because it's some sort of knob as well, but it's good to have. And then on the compiler side, oh God, this is very small for me. Well, you can see that all the different PRs we are working on. Verification issues, we just fix a few of them, but this one is pending. Then we have a whole category for the kernel self-tests because they have a tendency to stop building with GCC. The good news is that in most cases, it is just because of different warnings that GCC emits and Clang doesn't, or vice versa. Some of them they don't have like a PR number because we still have to file them. And then, well, at the bottom, you have those two elf-utils PRs, even though elf-utils is not technically GNU-toolchain, but still, it would be nice to fix those because it turns out that elf-utils have some support for BPF, but it is ancient and nobody has bothered to update it. And that's not good because if someone tries to use elf-utils for BPF and it doesn't work and it crashes, it's not nice. So time allowing, we will probably go and fix those as well. All of this is basically bug fixing in general. So, the bulk of the support for core and for the other BPF infrastructure is already there and working. And then, all right, in terms of support and usage of the GCC BPF, more and more distros are packaging it, and more distros are actually using it in order to build the BPF parts, BPF little programs of some of the packages they ship. I'm thinking about System D, for example, which distributes like 4 or 5 BPF programs. and a few others. Well, it is generally available. Some of those distros, they provide like latest version of GCC, even unreleased one, like Debian. It provides, you have, I think you already have even GCC 16 in the unstable version of the distro. But the the BPF support in GCC has been already stable like since 15 or even 14. So if any 15 version will be okay. And then some of the programs that use BPF, they are being built with GCC already in some of those distros. And then let's come to maybe the interesting part of all this. Okay, what are the challenges that we are facing right now in GCC BPF? Well, first and foremost, and most importantly, is the staffing problem and the attention span problem. What do I mean with this? So the people who are working in this port, primarily, we don't work on this full time. We have many other things to work on. So this means that not only we are few in numbers, but also that our attention span is limited. Meaning that we cannot, I mean, we can focus on it for a certain amount of time, but sooner or later we are going to be derailed, you know, to look at something else or work some other project for a while. Then we go back to this. This means that it is very difficult for us to follow and keep up with the extremely fast-moving BPF world, right? If you look at BPF next mailing list, you will see, you know, that it's not just the number of messages that get sent there. It's also, you know, that, I mean, you look like this for like a couple of days, and all of the sudden, Clank is already implementing something new, which, okay, yeah, it's optional, but people are using all the time. So actually, you have to support it in GCC or you are in trouble, right? So how to reconcile both things? Well, it's not easy. And as the maintainer of this port upstream, I would be very curious to hear any suggestion on how could we make this better. The goal here is that we should be able to not only follow the BPF development on the kernel side, but also we should be able to avoid having features which are only implemented in Clang, and even if they are optional. So any idea? It's not an easy problem.
What I've seen back in the past looks like the BPF. What I've seen in the past, like the BPF folks did the first initial upstream to LLVM. Maybe are they still doing this work to get the BPF support, and maybe they want to consider getting GCC to get the same functionality? Like whoever is adding these features, why is it considered like for one tool chain, not the other? Answering this question will help.
Well, some of them are here in this room. Is that something that they will consider? Come on, this is a discussion. Yeah, well. Yeah, I mean, yeah, sure. But things have improved a lot through the years. And actually, without the help from the kernel BPF community, we could not have done this, actually. Because I remember at the beginning, it felt like impossible to actually get parity with Clang. But if it has been possible to do so, it's also because at some point, we actually learned how to have a productive relationship with the kernel BPF people. Now, what I'm saying, or I'm not complaining, you know, but what I'm saying is that I think it's now the time to make another qualitative step forward here in that direction. like we did before, because it's moving too fast. It's very fast. And I'm not talking about something that you can do like easily, like, oh, let's add this new instruction or this couple of new instructions. No, we are talking about features which are complicated, and it takes a long time to implement. And also, it takes a lot of effort to actually put yourself in the context. You know, I mean, to context switch to do something like that, it takes time and effort. I'm thinking about, for example, these first calls, right? Which is some sort of inlining that the compiler does. Well, sorry. It is about the compiler generating the call site of a function in a way that the BPF loader can actually do the inlining. So it is so peculiar, and that it's not something that you can actually switch quickly to it and say, okay, let's implement this in GCC. It's like, okay, wait a second, right? The second is not a second, it's 1 week to start wrapping your head around the concept and around it. But usually what our experience is that we read about it in the BPF mailing list, we find it actually already implemented in Clang, and then before we can react to it, you know, I mean, we are always reacting. That's the thing. We are reactive, yes. And again, the kernel people, they have been helping us quite a lot. But anyway, something to think about maybe. Then there are a few like problems, but not really like challenges. There are still some BPF self-tests and maybe BPF programs on the wild which are including glibc headers, be it directly or indirectly. I think this is something that has been fixed like step by step, like when you find one, then you fix it. But, well, just mentioning it, it really should not happen because the glibc headers has been built for a different architecture, be it x86 or whatever, and you never know what is coming with it, with the rest of the stuff, right? Also, getting rid of the Clang-specific stuff, like in particular this push-pop attributes for structs. That is something that we need fixed for the vmlinux.h. And that's something that, for example, some people who have been wanting to port their applications to use GCC, the problem they have is that until this gets fixed on the kernel side, they need to patch, I don't know, maybe a BPF tool or a vmlinux.h file. So I don't know if, I mean, is there anything else that we can do to speed this up? Yeah, well, basically, I mean, we send a patch to get this fixed.
And you can remove the allocator and put the attribute directly to the struct itself. It should work, right?
Yeah, but I mean, it's that header file gets generated by the kernel, by BPF tool.
Yes, and then just BPF to do that.
Yeah, well, I mean, we sent a patch that did that, but then a different approach was attempted. Oops.
Oh, Edward probably has some comments.
Okay, so this one is on me, and I need to take a look at it eventually, like soonish. I will do it.
Okay, thanks. All right, so then there is another challenge that we are finding, which is sometimes GCC generates sleep calls. When GCC finds some pattern and it doesn't find that it doesn't know how to translate into instructions in the target, then it just generates a func call, which is a function call. Now you can imagine that that's not good for BPF because nothing is implementing those function calls. So again, this is something that we fix as we find them. we have one current issue open, which is with one particular instruction that Clang actually generates some, but that's something that you have to do it in purpose, right? You need to, for that particular pattern, you need to generate some particular sequence of instructions which should also be verifiable. So we are wondering if it will be possible to actually somehow fix this with linking.
This is what some Rust community try to do, and they have a separate, basically, library, and which will be linked to the BPF program. And currently, and at the client side, we will just reject, and for any function like that, libcall, anything, right? But I think we are open, and if people indeed want to have that one, and maybe LLVM could also expand, try to link some calls. Currently in LLVM side, we just reject any calls like this, but I think we can add some of them, but it'd be tricky to add who, because there's a lot of this little intrinsic calls, right?
Yes. But also the compilation model will be different because right now BPF, it's a compiled object, it's not linked.
Yeah, it will be great to compare and why Clang works and GCC not working, so we can decide what next.
Yeah, I mean, it's not a big issue at the moment.
Okay.
It's only one instruction at the moment.
Okay.
But yeah, and also the alternative as well. For example, in this case, is one instruction. One should wonder whether it will not be better to actually add a new BPF instruction for that particular instruction, which I think in this case will be JITed into one-to-one in all the supported architectures.
We could do that, and some of the calls actually is pretty simple, and we could have new instructions, and just a few, I mean, the x86 or ARM instruction to implement this. I think we will be okay, and we can discuss later.
Okay.
If it's simple enough.
Okay.
In the JIT, we just.
Okay. And this internal and external linking, with external linking, I mean like the typical linking that you do in any other architecture, right? But with a linker, with a link editor. With internal linking, I mean the linking that the BPF will do, or the BPF loader will do.
Yes.
And this brings me to ABI.
And we have this hidden thing, right? I think you're probably aware. In file linking.
Yes, I know.
Yeah.
I know that you are, yeah, but that brings me to ABI. Because up to now, I don't think that BPF code generated by GCC or by Clang will ever interact. But if you start linking, then that could happen.
It is a hack.
Well, all right. Then another challenge that we will be paying attention to is compiling Rust to BPF. In this case, with the Rust frontend in GCC. And then finally, something that it's been showing up lately, which I think is interesting, which is that there are some BPF variants out there, and some of them are something else. And I'm mentioning this SBPF from the Solana blockchain thing because someone contacted me and said, okay, well, mainly they use Rust. Well, this is like a blockchain thing that is not only for crypto coins, but for all sorts of transactions, everything legal. And they use this SBPF variant, which is quite interesting because it started like BPF, and they are extending the instruction set quite a lot. And they are doing some choices in terms of instruction encoding that I think it's interesting. Not to do exactly the same thing, but maybe, you know, I mean, as inspiration at some point. And maybe we will have on the compiler to support this, maybe, or some other BPF variants in the future as well. So I think this is also just interesting, just to mention. Anyway, we are super late. So any question? Okay, so let's move on. Thanks. LTO.
Good evening, everyone. My name is Song Liu. Today we're talking about challenges with kernel build with LTO. And it's a work I did with Yonghong. And let's get started so we can go to the party. So first, LTO versus tracing. So we have talked about this multiple times, and with kernel inlining, tracing become very hard and very confusing. So what do I mean? It's hard. So like if a function is inlined, if you want to trace this with a kprobe, with ftrace, that's you are not tracing the thing you think about in the source code. And it can be very confusing because a function that is inlined can still exist in the kernel. I have multiple cases, people spend like hours, days trying to trace something and realize, oh, I'm not tracing what I'm thinking about. And so some details like static functions in the same file that can be inlined. And if there's no LTO, global function can still be inlined in the same file that the function is defined. And also with LTO, and both static and global function can also be inlined as the call set from a different file. And this, like about LTO, this thing is like a cause confusion for many folks because they think, oh, this is a global function, it will not be inlined when I call from another file. But with LTO, that's not the case anymore. So we did some experiment. We used 618 kernel with LLVM 20. And the config was a production config, so it reflects whatever we have in production. So without LTO, we see 6,800 some inline, but still exists in the kernel functions. With LTO, the number goes to like above 8,000. So yes, we cannot blame everything on LTO, but that LTO definitely make it hard, make it harder. So we try to, I want to propose a solution. So what if we have a way to say, okay, if we consistently say, if we inline everywhere and remove the function itself. And if we do not inline, we just do not inline anywhere. So logically, it works like if the function is inline at some call size, let's just inline it everywhere. If for whatever reason this is not possible, let's not inline at all. But I had some discussion with Yonghong, like this seems very tricky to implement given how the optimization of inlining and cross-file inlining was implemented in LLVM at the moment. So, but I want to hear people's feedback, whether it is possible or whether it is makes sense to get rid of this confusion. Yes.
Yeah, I think it's possible, but from compiler point of view, this is a bad idea. So, first question is you talk about the LTO. So is that a single LTO or full LTO?
Single LTO.
Single LTO. So you didn't change the parameters, tuning parameter.
No, we use default.
Okay. So your number may change because the default parameter for single LTO is very conservative. But I think definitely compiler can do this, but as a compiler guy, I think this is not a good idea.
So we'll talk about it later, and you're more aggressive. There's some other side effect.
Okay.
It's actually a question I always have for the default inlining even, like, is it easy to prove that the decision taken by the compiler by default is better? So I think some configuration to change the behavior at least will enable some experimentation to collect some data. Because I always have the question, because inlining does have impact on caching. Because like sometimes if you inline too much on some platforms, you will get worse caching. On others, not. So like, just to comment on like, is it a good idea or a bad idea? I think that's a harder question to answer.
Yes, we fully understand it will be more convincing case if we have the numbers. If by doing that, the performance is changed by this much. But also given this is hard to implement, at least from what I understand, it's like it's not easy to collect the numbers saying like how much this changed the actual performance in real world cases. So it's kind of like a chicken egg problem. Okay, let's speed up so we can go to the party. So now the next is with LTO versus kernel level patch. So we do kernel level patch in a binary diff based toolchain. So right now we use the toolchain is kpatch build with some downstream patch we added to support LTO. And we're also experimenting with the new KLP build work by Josh. Thanks for coming. And so a little bit of background is this, we presented this before, but I wanted to give everyone some background. So this is how we do compile without LTO. So we compile the C file into the L file. And then we use the linker to link the L file into vmlinux.o, and we run the script to do a lot of magic things to get a final VM Linux. And so to build the level patch, we do a binary diff. Basically, we take the source code before the patch we want to build. We build the L file, and we do the source code after the patch. And we do this thing. CDO is a created diff object. Basically, take the two, like foo.o before and foo.o after, and see which functions changed. And whatever changed, we add to the kernel level patch. So this is the workflow with LTO. So with the clone, we get the .o file, but now it is IR, is not ELF anymore. And in the linker, it will do the cross-file inlining and generate some internal object files. It's never dumped. It's not dumped out by default. And we get link them into the vmlinux.o, and we do object2 and the next steps. So later we found that there's a trick with this option. We can actually dump these files out. And so what we do in our downstream patches is like we use this option and do the binary diff like that. So basically we do the before patch and after patch side, and we do the IR, and then we go to the linker, and it will generate the before the O file and after the O file. And then we do the binary diff here. Oh, I forgot to mention why we need it. Because the alternative or the default way is to like we do the binary diff of the vmlinux.o, which turned out is not possible with the kpatch toolchain as is. This takes like days to finish. So, and let me see. Okay, so that's what we do for now. It's not ideal. It got a few issues, but it works for us so far. So what about the new KLP build workflow? It actually enables us to do the binary diff on vmlinux.o, and which is great. We don't need this hack anymore. And the problem now is like we do not have ARM64 support yet. So we recently added ARM64 support to our production in the kpatch toolchains. I do not want to diverge my toolchain for like a different architecture. So I hope to add that first, and then move to the KLP build toolchains. However, this doesn't really fully change the challenge come from the LTOs. We still have a lot of challenge. I'll show details. So here's a very simple, like I call it a MD dummy. It's not even changing anything, but I just have a new pointer check, which is actually guaranteed there's won't be new from the caller. So we do this thing with our K-patch build and with our this 613 based kernel. We just changed one function and binary found this much for me. And it shows like which object file is actually which source code. Seems crazy why we changed so much. So here's a little bit why. So we have this thing. This is an object, and somehow after that change, the compiler decided, okay, I need to give it a new name. And this is actually a real problem because after the new name, the K-patch build toolchain thinks it is a new data, it's a new object. So this actually, if we load it, it doesn't really work because it add a new like a list and just everything just mess up. So how about we do the same thing with K-patch build and with LTO? And I think this is with a different compiler. Whatever we do here is with LLVM 19, and the new one I think is what we show here is. Let me see. Sorry. I think I tried both 19 and 20, so they get a lot of things. Oh, there's no correlation, and something else changes, and so what? One thing we noticed that, yeah, I think it is LLVM 20. So there's like a change of this thing, and it's changed to a new function, and this is the postfix added by the LLVM. Do we have the speaker?
This is actually called we call externalizations. So we add these numbers. This is a hash actually. Is promoted to by scope functions to global functions. But when we promote, we need to add some unique strings to avoid name conflict. So this for single LTO, this string is used. It's not properly implemented because the same hash is used both for the naming and for the caching. So there is internal options. Don't use this hash because this hash will hash the IR. So anything change the IR, then you have a different hashing. So there's internal options using a source file name. So the best way to do this is to the hash of the source file name, but using user file name is okay. It will solve your problem.
Yes, we recently learned there's such an option, but I think it's not. I don't think it doesn't look good to me at least. But yeah, let me finish so we can come back later. So. And what we see, we also observe that like with the new compiler, it seems to make it more aggressive and the behavior is getting worse. So with the LLVM 19, for the same patch, with KLP build, with the same patch, we get a 26 changed function and all in the same file. And we move to a new compiler, things a lot more and get even more from more files. So probably something changed in the optimization from like one version of the compiler to another. So this is the solution. I think whatever you suggested, I think that's definitely one way to solve this. But I think we want to propose the idea to what if we have an option to just remove all this postfix
But
altogether.
it's not safe, right? You can have if you remove this, you can have a conflict.
Right. We're not proposing to blindly remove like them. So if we have.
But what's wrong with the current internal option use a file source name? It's starting from your root with the function. For example, like kernel foo.c, we expand all the strings, then added the function name. You will not have a name conflict.
So yes, I think that will work. I think there's other side of this is with tracing. I think last year someone proposed something similar to have like the file name too, because right now in the kernel we can have two functions of the same name.
Yeah, but with file name you cannot, right?
Right. So there are two static functions. They have on two different files. They have the same name. Everything just works. So in that sense, it works. And there's people hate that, and I think that's a presentation in last Plumber proposed to have the full file name embedded, not just for this LVM promoted global function, but also for static function, just add that file name in some format, so there's never a like a duplicated name in the KL symbols. But I think
there's the
people,
option to do that. But what I'm talking about is when we promote, we add this name only when we promote promoted functions.
Right.
The other is a unique. What is a unique static function or something?
Yeah, sorry. I think my point is like, at least I personally do not like my kernel function look like something with a source code path.
But
And
if we promoted, this is you have to do, right? Otherwise, you have name conflict. Your link will fail.
So I think we have the data here. So we have like this. I think this is from BPF Next, a recent BPF Next tree, and we use SynLTO. We get like 2,000 of this, and actually, like they are not really conflict. So I think when you get the data, none of them are real conflicts. They are not real conflicts. So in other words, like for 99% of the chance, we make this thing, LVM thing, and that's we're not really resolving a conflict. And speaking of the KL symbols, like this dot thing mess up the symbol sorting. And that took us like a few rounds of patches over like maybe 2 years or more to actually make the symbol sorting right again in the in the kernel.
We can improve the thin link to know in advance that without this name suffix it's safe. But you cannot just blindly do this.
Yeah, no, I mean, not mean blindly do this.
But how do you know? This is a post fact, right?
So, Yonghong, you think about a
I don't know
solution?
how to do that, but the goal is, and after basically import, and you try to promote all this static function with .LLVM suffix, everything is done after that, and we could have a pass and try to see whether there's a conflict.
Oh, yeah, after.
Yeah, that's what I mean. After
Okay.
that, there's the option, maybe have a pass can do this. And clearly in this particular case is like 2,117 functions have the suffix, and all of that are no conflict. This makes things really beautiful, right? And they just full. And LLVM have a convention, right? And things changes, they try to maintain the same name. Even signature change. So why we can do that? We can do this, right?
Okay.
Yeah, just promote, right?
Okay, that's all I have for today. Any more questions?
Actually, I got one. As he mentioned that for the first question, he got the the first potential solution, the first one. You go back to the slide 4. Yeah, my question is more likely. He mentioned that this is a bad idea. Just wondering why it's bad.
I think you messed up with inline heuristic. Yeah, but if you want to do this, it's going to be easy in the compiler because you can have always inline attribute because always inline will always inline for these functions. So then you disable all these heuristic. This is just all the inline or not inline. But this is a bad idea is because compiler inline is important for the performance. I mean, even for people use that always inline heuristic, they are asking for like a per core site attribute. I think a claim supporting that. It's like for this core site, you are inline, not core site is not inline. I mean, this is for, purely from performance point of view. Because inline is one of the most important transformations.
If the only problem is that people get confused, maybe instead of changing code generation, emit an extra section with addresses of functions that are like this, only partially inlined, and then in ftrace, for example, exclude them or emit a warning.
Yes, that's another idea. Like I have sometimes just like if there's something, just at least say you're trying to trace it, and this is like inlined somewhere, so you are not tracing the whole thing. You assume from you see in the source code. So there's another idea, and there are also yet another idea to say what if we can simulate the tracing for the inline place. Basically, you're at this function at this offsite, and you look like that.
Yeah, but I guess within lines, that's not always possible, right?
Yeah, but from my side, like if this is easy to implement, we would like to give it a try and see how good, how bad the performance is. Maybe it's just like a very small performance change. We would like to keep it simple for the rest of the system.
Yeah, fair enough. I was just suggesting it in case performance turns out to be bad because the compiler inlines things for a reason, right? So
yeah, totally. We do LTO for performance. If the performance is horrible, like there's no way we're gonna ship it. Thank you.
Okay, thank you.
All right.
Thank you.